accompany me step by step so I could be in the same level as my classmates. It's been 5 years that I came and back from this campus, but I've never got tired of it. I've been visiting a lot of big cities in Indonesia, but so far Solo is my favorite one. This city just amazed me by the way it looks, by its people, and especially by the sympathy and friendly way that Solonese people welcome me everywhere I go. I would say that I love living in Solo because I love eating, and food is just everywhere with affordable price, and I would definitely recommend Solo for anyone who wanna come to visit Indonesia. I'm very happy to be a part of this beautiful campus, and I also feel lucky because I could make my studies here, and especially I could meet new people from all around the world. Merci beaucoup, UNS.
My name is Walid Sulaiman Karbous. I'm from Sudan. I feel comfortable during my study in UNS because what I found from the international office, from my classmates, from my lecturer, the environment study, the facilities in campus, everything make me happy and creative during my study in UNS. I'm enjoying my life in Solo. Actually, everything in Solo make you feel comfortable. The people are very kind. The food is delicious. The prices are cheap. The tourist area around the city, everything make you feel comfortable in Solo.
My name is Yuzuna Mao. I'm from Myanmar. I'm studying Master Program of Public Health in Universitas 11 Maret. Difficulties during my study, but there are always some when I came back. Solo is like my second hometown. People in Solo is friendly, polite.
Both in the rapidly changing 21st century. This is what encouraged Universitas 11 Maret to shift its governance and management to an autonomous public university. With this change, Universitas 11 Maret will have the autonomy and independence to improve the quality of teaching, learning, and research in implementing the 5 development pillars of Universitas 11 Maret to accelerate its transformation process towards becoming a world-class university. Universitas 11 Maret. Science without nobility is blind. The core of Universitas 11 Maret logo, which is a head-like shape with a flame in its center, is described as Wiku. The term Wiku is Old Javanese, borrowed from Pali, meaning an educated noble disciple. The flame, or prabha, in the center of Wiku's head represents the brilliance, wisdom, and nobility of the human mind. The flame also symbolizes the light of knowledge that shines and makes a positive and eternal impact on the world and humanity. Universitas 11 Maret, established on March 11, 1976, is one of the leading universities in Indonesia. Its noble goal is to contribute to the development of the nation through education, research, and innovation that benefits society. Universitas 11 Maret has built its vision and strategic plan on becoming an internationally excellent center of development of science, technology, and arts based on the noble values of national culture, focusing on enhancing its specialized subject areas and on developing its capacity to meet world-class standards. Universitas 11 Maret has established 3 centers of excellence in science and technology. The 3 centers are Center of Excellence in Lithium-Ion Battery Technology, Center of Excellence in Fintech, Financial Technology, and Center of Excellence in Javanology that focuses on the study, development, and preservation of Javanese culture. Universitas 11 Maret is located in the city of Surakarta, also known as Solo, Solo is a very comfortable city to live in, where Javanese culture and modern life combine. The life in Solo, which upholds the value of harmony, has prepared Universitas 11 Maret graduates to be future leaders who are tough, creative, friendly, generous, calm, and adaptive. To achieve the vision of Indonesian higher education, freedom to learn, independent campus, Universitas 11 Maret offers a variety of courses on a wide range of subjects conducted by 11 faculties, a vocational school, and a graduate school. Various library services, such as thousands of print books and ebooks, access to various international journals, and academic librarian assistants are available to support the teaching and learning process and promote the academic achievement of all students, lecturers, and researchers. With a comfortable learning environment, a green campus, and supported by an integrated information system, Universitas 11 Maret has an academic culture that fosters a global perspective and is prepared for Education 4.0. Active and strong international partnerships and collaborations have become an integral part of the university. International partnerships provide opportunities for student and staff mobility, as well as collaborative research and community service projects. In addition to being a center of excellence, Universitas 11 Maret is home to students from all 34 provinces in Indonesia and 33 countries in the world. This creates a multicultural environment that promotes mutual understanding. Embracing diversity and respecting all cultures makes every student feel recognized and valued.
Assalamualaikum. My name is Suwarna Lavaratina Iren Narson. I come from Madagascar and I study design communication visual. So far, my experiences have been very colorful. On my first semester, I have been through a lot of difficulties, especially with bahasa issue, but luckily, I had the best and understanding lectures ever. They definitely accompany me step by step, so I could be in the same level as my classmates. It's been 5 years that I came and back from this campus, but I've never got tired of it.
Soundcheck 1, 2, 3.
I've been visiting a lot of big cities in Indonesia, but so far Solo is my favorite one.
Soundcheck 1 dicoba 1, 2, dan 3.
By its people and especially by the sympathy and friendly way that Solonese people welcome me everywhere I go.
1, 2, dan 3.
I would say that I love living in Solo because I love eating, and food is just everywhere with affordable price. And I would definitely recommend Solo for anyone who wanna come to visit Indonesia. I'm very happy to be a part of this beautiful campus, and I also feel lucky because I could make my studies here, and especially I could meet new people from all around the world. Merci beaucoup, Ernest.
My name is Walid Sulaiman Karbous. I'm from Sudan. I feel comfortable during my study in UNS because what I found from the international office, from my classmate, from my lecturer, the environment study, the facilities in campus, everything make me happy and creative during my study in UNS. I'm enjoying my life in Solo. Actually, everything in Solo make you feel comfortable. The people are very kind. The food is delicious, the prices are cheap, the tourist area around the city, everything make you feel comfortable in Seoul.
My name is Yuzuna Mao. I'm from Myanmar. I'm studying Master Program of Public Health in Universitas 11 Maret, Indonesia. Studying in Universitas 11 Maret is enjoyable and it is a good atmosphere to study. I got so many chances to contribute in non-academic activities also, so it improved my knowledge about the social and culture of Indonesia. Of course, I have some difficulties during my study, but there are always some helping hands for me. Here I got experiences I think which I could adopt in my country when I came back. Solo is like my second hometown. People in Solo is friendly, polite, and helpful. I feel safe when I live in Solo.
The complexity of the modern world is continuously increasing. We live in an uncertain world where change is rapid and unpredictable. Universities have a pivotal role to play in preparing graduates for jobs that don't exist yet, for technologies that haven't been invented, and for problems that need innovative solutions.
Universitas 11 Maret has three main agendas toward a world-class university. Acceleration in various fields of development is needed by embracing the foundation of UNS, Benteng Pancasila. Therefore, 5 strategic policy pillars were decided.
It is important to understand that flexibility and adaptability are the keys to growth in the rapidly changing 21st century. This is what encouraged Universitas 11 Maret to shift its governance and management to an autonomous public university. With this change, Universitas 11 Maret will have the autonomy and independence to improve the quality of teaching, learning, and research in implementing the 5 development pillars of Universitas 11 Maret to accelerate its transformation process towards becoming a world-class university. Universitas 11 Maret.
Assalamualaikum warahmatullahi wabarakatuh. Perkembangan teknologi semakin menuntut baterai dengan karakteristik yang baik. Kami di PUI Teknologi Penyimpan Energi Listrik dan aplikasinya saat ini sedang mengembangkan material aktif untuk produksi baterai litium dengan karakteristik yang baik. Pendanaan ini disupport oleh RISPRO Invitasi sehingga kami bisa melakukan pengembangan material aktif sesuai dengan karakteristik yang diinginkan. Terima kasih LPDP atas supportnya selama ini. Sukses selalu.
Dewasa ini perkembangan teknologi otomotif mulai beralih dari energi fosil menuju energi listrik. Isu ramah lingkungan dan potensi energi fosil yang akan habis mempercepat perubahan menuju energi listrik. Kebijakan dan penelitian mengenai mobil listrik terus digalakkan oleh pemerintah Indonesia. Hal ini disambut baik oleh Universitas 11 Maret yang melihat bahwa baterai litium adalah komponen kunci kendaraan listrik dan sistem energi terbarukan. Teknologi baterai litium merupakan suatu teknologi masa kini yang umum digunakan karena ia mengemas banyak energi dalam volume yang kecil. Prinsip kerja teknologi ini adalah memanfaatkan kemampuan perubahan energi listrik menjadi energi kimia pada saat proses penyimpanan dan perubahan energi kimia menjadi energi listrik pada saat akan digunakan. Cikal bakal pengembangan teknologi baterai litium ini dimulai pada tahun 2012, di mana saat itu Universitas 11 Maret ditunjuk sebagai salah satu dari 5 perguruan tinggi anggota Konsorsium Pengembangan Penelitian Mobil Listrik Nasional atau MOLINA, Kementerian Pendidikan dan Kebudayaan yang kemudian didukung dengan bantuan pendanaan riset inovatif produktif atau RISPRO, Invitasi Kendaraan Listrik. Milestone yang telah kami lakukan diantaranya dimulai pada tahun 2012 dengan memulai penelitian di formulasi produksi baterai dan material penyusunannya. Kemudian di tahun 2015 kami berhasil memproduksi baterai berjenis lithium ferrofosfat dengan kapasitas produksi 5 hingga 10 sel per hari. Sampai dengan pada tahun 2020 dengan mitra industri PT Pertamina Persero, kami dapat meningkatkan kapasitas produksi menjadi 1000 sel per hari. Teknologi baterai yang dinamis memberikan semangat kepada kami untuk terus berinovasi dengan melakukan penelitian dan pengembangan baterai berjenis lain diantaranya LFP, NCA, dan NMC. Seluruh baterai yang kami produksi memiliki tipe sel 18650 berbentuk silinder dengan diameter 18 mm dan tinggi baterai 65 mm. Rangkaian proses produksi baterai di Pusat Unggulan IPTEX Penyimpanan Energi Listrik Universitas 11 Maret meliputi 4 tahapan proses, yaitu dimulai dengan pembuatan material aktif, pengujian material, pembuatan baterai sel, dan hilirisasi produk jadi baterai. Pada tahapan pembuatan material aktif, kami memulai produksi material aktif berupa katoda dan anoda pada lab scale atau pilot scale yang secara umum kegiatannya meliputi formulasi dan persiapan bahan baku, pembuatan larutan bahan baku, proses reaksi pembentukan bahan setengah jadi atau prekursor, proses penuaan atau aging, pengendapan, penyaringan, dan pengeringan, proses penambahan dan penyampuran sumber litium, proses pemanasan dengan menggunakan furnace, proses pengayakan atau sieving, dan penyimpanan. Bahan material yang telah jadi selalu kami evaluasi untuk menjamin mutu dan kualitasnya. Proses evaluasi kualitas material kami lakukan dengan bantuan beberapa alat uji, antara lain X-ray diffractometer, FTIR, Fourier Transformed Infrared Spectroscopy, SEM atau Scanning Electron Microscope, potensiostat. Proses kemudian berlanjut pada produksi baterai sel. Dalam proses ini, material aktif yang telah lolos uji kami olah menjadi produk akhir berupa baterai pack yang dapat diaplikasikan pada sistem penyimpanan energi, kendaraan listrik, peralatan elektronik, peralatan kesehatan, robotika, dan militer. Proses pengolahan material aktif tersebut melalui beberapa proses. Proses mixing, proses coating anoda dan katoda, pressing film anoda dan aktoda hingga mencapai ketebalan yang diinginkan. Winding, pengelasan, pengisian elektrolit, karakterisasi sel, quality control, pengujian kapasitas, cycle, dan temperatur. Setelah lolos, seluruh proses produksi baterai sel kemudian dilakukan proses packing sesuai dengan spesifikasi dan kegunaan, dan baterai siap digunakan. Sebagai langkah konkret hilirisasi dari produk-produk yang kami kembangkan, kami melahirkan 3 perusahaan pemula atau startup berbasis teknologi, diantaranya PT Batex Energi Mandiri yang memiliki fokus pada hilirisasi baterai sel dan pack, PT Ekoelektrik Konversi Mandiri yang berfokus pada penyedia jasa konversi kendaraan berbasis baterai, dan PT Polimikro Berdikari Nasional yang berfokus pada hilirisasi material aktif. Berbicara tentang sustainable production process dalam produksi baterai, pada tahun 2019 sampai dengan sekarang, Rispro LPDP selalu memberikan fasilitas dari segi material maupun non-material, sehingga kami dapat memproduksi material aktif secara in-house production, sehingga dengan seluruh hal yang kami lakukan dapat membantu bangsa Indonesia untuk membentuk kemandirian energi bangsa.
University Center of Excellence for Electrical Energy Storage Technology, atau bisa disebut PUI PT Teknologi Penyimpan Energi Listrik. PUI PT Teknologi Penyimpan Energi Listrik merupakan salah satu program dari Kemendikbud untuk penguatan pengembangan inovasi di lingkungan perguruan tinggi yang terfokus pada proses pembuatan baterai lithium-ion. Proses pembuatan baterai lithium-ion terdiri dari beberapa tahap. Tahap pertama adalah mencampurkan bahan-bahan yang akan digunakan untuk pembuatan lembaran katoda dan anoda menggunakan mixer. Proses mixing dilakukan selama 12 jam untuk memastikan semua bahan tercampur secara homogen. Tahapan selanjutnya adalah proses pelapisan bahan hasil mixing pada permukaan current collector elektroda menggunakan coating mesin. Lembaran elektroda dipres menggunakan rolling press mesin untuk memadatkan bahan yang sudah menempel di permukaan current collector. Lembaran elektroda yang sudah siap dipotong menggunakan slitting mesin sesuai dengan ukuran yang diinginkan. Proses berikutnya adalah pengelasan elektroda dengan menggunakan spot welding. Aluminium tab dipasangkan pada katoda, sedangkan nikel tab dipasangkan pada anoda. Untuk mencegah terjadinya short circuit, pada masing-masing tab dilapisi dengan kapten tape. Anoda dan katoda siap digulung menggunakan semi-automatic winding mesin sehingga menjadi gulungan atau biasa disebut jelly roll. Untuk mengantisipasi terjadinya short circuit lagi, dilakukan pengecekan ulang menggunakan short circuit tester. Jelly roll siap dipasang pada silinder case. Setelah terpasang dengan sempurna, dilakukan penguliran dan pemasangan tutup. Pengisian elektrolit dilakukan di dalam glove box. Proses selanjutnya adalah penyegelan tutup sel silinder. Pemasangan cover pada sel silinder atau proses wrapping. Baterai siap untuk melalui proses formation pada mesin analyzer. Dan mesin grading. Pengecekan internal resistance menggunakan internal resistance tester. Sekian video pembuatan baterai lithium ion pada unit produksi baterai lithium ion PUI UNS.
Science without nobility is blind. The core of Universitas 11 Maret logo, which is a head-like shape with a flame in its center, is described as Wiku. The term Wiku is Old Javanese, borrowed from Pali, meaning an educated noble disciple. The flame, or prabha, in the center of Wiku's head represents the brilliance, wisdom, and nobility of the human mind. The flame also symbolizes the light of knowledge that shines and makes a positive and eternal impact on the world and humanity. Universitas 11 Maret, established on March 11, 1976, is one of the leading universities in Indonesia. Its noble goal is to contribute to the development of the nation through education, research, and innovation that benefits society. Universitas 11 Maret has built its vision and strategic plan on becoming an internationally excellent center of development of science, technology, and arts based on the noble values of national culture, focusing on enhancing its specialized subject areas and on developing its capacity to meet world-class standards. Universitas 11 Maret has established 3 centers of excellence in science and technology. The 3 centers are Center of Excellence in Lithium-Ion Battery Technology, Center of Excellence in FinTech, Financial Technology, and Center of Excellence in Javanology that focuses on the study, development, and preservation of Javanese culture. Universitas 11 Maret is located in the city of Surakarta, also known as Solo. Solo is a very comfortable city to live in, where Javanese culture and modern life combine. The life in Solo, which upholds the value of harmony, has prepared Universitas 11 Maret graduates to be future leaders who are tough, creative, friendly, generous, calm, and adaptive. To achieve the vision of Indonesian higher education, freedom to learn, independent campus, Universitas 11 Maret offers a variety of courses on a wide range of subjects conducted by 11 faculties, a vocational school, and a graduate school. Various library services, such as thousands of print books and ebooks, Access to various international journals and academic librarian assistants are available to support the teaching and learning process and promote the academic achievement of all students.
Well, honorable guests, ladies and gentlemen, good morning and welcome to the second International Conference on Energy Storage Technology and Application, ICESTA 2022. Can I hear a big round of applause for this event, ladies and gentlemen? Thank you. I'm Albert, and on behalf of the committee, I would like to extend our gratitude for your presence here, for your participation, both for the offline audience and also online audience. And ladies and gentlemen, at this beautiful occasion, please do allow me to greet the Honorable Conference Organizing Committee Chair and our dear keynote speakers, moderators, presenters, and also participants. It's really an honor that you are all here and actively participate in this international conference. Well, ladies and gentlemen, ICESTA 2022 is organized by the University Center of Excellence for Electrical Energy Storage Technology, Universitas 11 Maret. And this year's theme is Energy Storage for Industry and Sustainable Environment. Ladies and gentlemen, there are some reasons why the theme was picked by the organizer. And one of them is that we do need to control the fastly growing energy consumption by improving energy efficiency and increasing the use of renewable energy. We know that renewable energy has uncertain output, so it requires energy storage to mitigate power variations, store and dispatch renewable energy. That's why, ladies and gentlemen, ICESTA 2022 is inviting experts to discuss this matter thoroughly, as we're going to have our dear keynote speaker. Can we give a big round of applause for Dr. Hasnan Abimanyu, Diploma Engineer, the head of Research Organization for Energy and Manufacture. Also for Professor Dr. Wahyudi Sutopo, STMSc from Universitas 11 Maret. Thank you. And we're also going to have Professor Dr. Rameste Subramaniam from University Malaya. Ladies and gentlemen, to start with, we would like to sing the national anthem, Indonesia Raya. Please rise. Di sana aku berdiri, cari padu ibuku. Indonesia kebangsaanku, bangsa dan tanah air. Marilah kita bersatu, Indonesia bersatu. Hiduplah tanahku, hiduplah bangsa kita semuanya. Angkat jiwa, angkat badan untuk Indonesia Raya. Ladies and gentlemen, please kindly be seated. Well, dear honorable guests, for the next agenda, I'd like to give the chance to the conference chair to deliver his report, Bapak Anif Jamaluddin, SSE, MSE, PhD. Now, the time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Thank you very much for the audience, honorable of keynote speaker, invited speaker, our participant, our colleagues, and all in the audience in this room, in hybrid, in second International Conference on Energy Storage Technology and Application 2022. I am a chair of this international conference. This international conference, we want to know the topic of this international conference is we want to learn about the topic is energy storage for industry and sustainable and environment. In this international conference, the committee already accepted around 27 proposals, 27 papers. They will publish in the Evergreen, the journal Evergreen, and they'll publish in the scientific Transtech publisher. And the participants come from the various countries, including Malaysia, Myanmar, and Thailand. And also, this international conference, we invited the keynote speaker and the invited speaker, not only from academic, also we invite from industry. We very thanks to our keynote speaker, Dr. Hasanan Abimanyu, from Head of Research Organization of Energy and Manufacturing. Also from the University of Malaya, Professor Rames, and also Professor Wahyudi Sutopo, this is for academics, and also from Kahon University, Thailand, Professor Nongklah. And we also thanks to Dr. Arif Jumari from Universitas 11 Maret. Also, we invited the keynote from the industry, from Mr. Yoke Chandra Katon from Komisaris Semen Gresik. And this event is not only from academician, but also we have a special session to discussion between the industry, especially for the developing energy storage in Indonesia. So we invite or already organize invite some the special guests in industry. Finally, I will say thanks to all audience, all our participants in this room, and with Bismillahirrahmanirrahim, we will will continue this conference, and we say welcome to ICESTA 2022. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Anif Jamaluddin, SE PhD. All right. Please return to your seat. And ladies and gentlemen, I'm sure that you can't wait for the first plenary session, but before, I would like to bring you all to get closer to know with the organizer, which is the Center of Excellence for Electrical Energy Storage Technology, or CEVIS, through this video. Ladies and gentlemen, please enjoy the video.
Yang disingkat CEVIS atau disebut juga dengan PUI PT Teknologi Penyimpan Energi Listrik, merupakan salah satu program dari Kemenristekdikti untuk penguatan pelembagaan inovasi di lingkungan perguruan tinggi. Lembaga ini dibawahi oleh Universitas 11 Maret yang berfokus pada pengembangan baterai litium. Dimulai sejak tahun 2012 melalui program Molina yang sekarang dikembangkan menjadi baterai litium di UNS. CEVIS memiliki visi menjadi pusat pengembangan teknologi penyimpan energi untuk aplikasi kendaraan listrik dan energi terbarukan yang terdepan di Indonesia pada tahun 2025. Adapun sarana dan prasarana dibagi menjadi laboratorium baterai, mini plant baterai lithium, mini plant material aktif, peralatan uji dan karakterisasi, charging station, gedung administrasi, training, dan pelatihan. Untuk meningkatkan kompetensi, aktivitas yang dijalankan berupa riset dan pengembangan teknologi penyimpan energi, layanan pengujian, pelatihan, konsultatif industri, inkubasi, dan komersialisasi. Lembaga ini telah menghasilkan produk-produk unggulan yang berupa baterai pack, sepeda listrik roda 2 dan roda 3, mobil listrik Molina, penerangan jalan umum, material aktif, untuk menciptakan hasil yang terbaik, ICESTA terus melakukan pengembangan next generation battery, material aktif dari bahan baku lokal, startup teknologi berbasis baterai, jurnal internasional ICESTA, ICESTA telah melakukan kegiatan kerjasama dengan berbagai pihak, antara lain workshop battery and energy storage technology, kick-off battery production, soft launching battery lithium ion, kunjungan rektor ITB, kunjungan rektor ITS, kunjungan Toyota Astra dan Kemenperin, penandatanganan MOU dengan Pertamina, launching teaching factory oleh Menristek Dikti Muhammad Nasir. Inilah tim dari University Center of Excellence for Electrical Energy Storage Technology. ICESTA terus mendukung perkembangan teknologi baterai dengan sumber daya lokal sebagai energi inovasi masa depan Indonesia.
Well, ladies and gentlemen, can we give a big round of applause for ICESTA? That's the profile of the organizer. Well, ladies and gentlemen, it's now the time for the first plenary session, as we're going to have Dr. Hasnan Abimanyu, Diploma Engineer, the Head of Research Organization for Energy and Manufacture, Badan Riset dan Inovasi Nasional, and also Professor Dr. Wahyudi Sutopo from Universitas 11 Maret. And ladies and gentlemen, to make sure the session runs smoothly, I'd like to introduce you all to our dear moderator, Dr. Adrianur ST MT. He obtained his doctoral degree from Institut Teknologi 10 November and his master's degree from Universitas Gadjah Mada. He was the head of the Mechatronic Division of UNS from 2016 to 2019, and currently he is the head of the Chemical Engineering Study Program of Universitas 11 Maret. Ladies and gentlemen, Dr. Adrian Nur.
Okay, thank you, Mr. Albert. Okay, I would like to join with me, Dr. Nan Abimanyu, Wahyudi Stopo. Please come in. Okay, good morning, ladies and gentlemen. Welcome in second ICESTA, and welcome in Solo for Dr. Hasnan. Okay, the first I will keynote speakers. They are Dr. Hasnan Abimanyu from National Research and Innovation Agency, and Professor Dr. Wahyudi Stopo from 11 Maret University. Okay, the first, the keynote speaker is Dr. Hasnan Abimanyu. I will read a brief CV. Okay. His office address is Kawasan Sains and Teknologi B.J. Habibie Puspitek Serpong. He worked in Research Organization for Energy and Manufacture from BRIN, National Research and Innovation Agency. So many training and workshop. The last is leader training level 2. There are 11 awards, 28 research experience, 19 keynotes and invited speaks or guest speaker. There are 12 patents and 2 licenses, and a lot of international paper or national paper. Okay, Dr. Hasnan Abimanyu, time is yours. Okay.
Yeah, thank you, Dr. Adrian, for your introduction. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, good morning, salam sejahtera buat kita semua. First of all, I want to thank the committee invited me to talk as keynote speaker in this conference, international conference. And also distinguished guests, honorable speakers, and invited also the member faculty of UNS. So I want to talk about the development of battery, EV, and charging storage, also charging station, and also hydrogen research in BRIN. May I have my presentation? No, you don't have my presentation? I think, yes, okay. Yeah, I have. Should I stand or sit, Dr. Adrian? Okay, thank you. Okay, ya, ada pointer. Cuma nextnya ada. Bisa next bisa ya? Oh iya. Bisa. Oke, bisa. So, as we know that Indonesia has been committed in Paris Agreement to reduce the greenhouse gas in 2030 by 26% when it's on efforts, but when there is international assistance, so we should decrease the greenhouse gas by 41%. So that's why Ministry of Energy and Mineral Resources has or set up the roadmap to net zero emission from 2021 until 2060. There is a supply and demand, but we take a look here in the demand. There is an increase for this electric vehicle. So in 2060, maybe around 229 million of two-wheelers and around 70 million of four-wheelers, electric vehicle. So with this huge amount of an electric vehicle, so we must have we must produce the battery for electric vehicle. So, and another storage. So another utilization of battery is for the storage, electric energy storage system. So battery energy storage system in this roadmap from Ministry of Energy and Mineral Resources, that come in an increase from 2030 until 2060. Also the hydrogen energy. Yeah. So as we know, lithium battery that is not working. Next, please. Okay. Yes. So there is a story of utilization of lithium battery, based battery electric vehicles. So start from 1991. Basically, there is before 1991, there is also battery-based electric vehicle, but we start from 1991 and until to 2019, there is a 100 kilowatt hour pack battery, and the target is 300 kilowatt. Next, please. Yeah. So if we break down the cost of the battery pack or battery in the electric vehicle, there is a 39% of the cost of electric vehicle belongs to the battery. Or not battery itself, but powertrain, yeah, electric powertrain. Then a battery pack is 77% from this electric vehicle powertrain. Next, please. So this is, we know that the battery supply chain, there's begin from the mining and then refinery and until the end use. Then the end use, we should have plan to recycle this battery. Next. And then there in the battery itself, so there are battery packing. So we have to take attention pay attention for this battery packing is 5 protection pillars. There's protection from the ingress, from thermal, and then the impact protection, vibration protection, and overload protection. So this battery packing protection, we have to manage. Yeah. Next, please. And another things that we have to pay attention, that battery thermal management system. So the degradation of the performance by the thermal exhaust by battery, so thermal exhaust in battery pack, it can decrease the performance of the battery. Next, please. So I will talk about the battery research in Britain. Next. So we have the battery laboratory here, from synthesis, component manufacturing, and also battery material recycling. Next. And we have also battery workshop, battery assembly and testing with the equipments. It's like machine coating, like here in UNS. Next, please. So this is the roadmap battery research from 2020 until 2024. Basically, we have began the battery research as the same as in UNS, so a decade ago. So that is roadmap from 2020 until 2024. The activities, research activities, is processing of the raw materials until the battery cell assembly. Next, please. So this is the raw material processing, like nickel laterite processing and purification from nickel ore. Next, the manganese ore processing by reduction and smelter, also leaching and solvent extraction. Next, please. And the ilmenite processing by two methods, caustic fusion and also by hydrogen sulfate leaching. Next. And this is the processing for zirconia, sand, yeah, until we got the zircon material for battery. Next. And there's the processing of secondary source, not from the mining. Also, we can use the e-waste, electric waste, industrial waste, also mining waste, and urban waste for circular economy. So like industrial waste, urban waste, and also mining waste, we can process this waste by mineral technology to produce the valuable metal compound that as precursor for raw materials of EV battery or magnet or sensor advanced materials. Next, please. Another research is the to mix the raw material from mining material and also raw material from the recycling process, and we mix it and then we use again to make a battery cell. Next, please. This is the battery recycling research activities. We have the pre-treatment equipment, and also we can use the hydrometallurgy process. Next. And we have researched also the battery pack design for the lithium titanate and also for the nickel. Next. And this battery management system from for the two-wheelers EV. Next. So this is the battery management system for electric vehicles for bus electric vehicle or a sedan, and also or other four-wheelers electric vehicle. Next. So start from 2015, we research about this battery management system until now. Next. This is the research about the battery thermal management system. There is active thermal management system, also passive thermal management system. Next, please. Yeah. So with phase change material. So we use the battery module with PCM, also battery with CFRP. Next. This design of a battery pack, lightweight. We use light metal or composite for the battery pack. Next. So in BRIN, there is also EV development like in UNS. But we start actually in BRIN from 2000, yeah, around in the beginning of 2000, research about EV, electric vehicle. Next, please. Yeah, 2005 there is a special purpose EV, and 2008 we moved to hybrid EV, and then conversion EV from ICE to EV in 2009, and 2010 we built the bus, micro bus, yeah, electric bus, and then also for sport EV 2011. Next. Now we move to autonomous EV from EV, and then we move to the autonomous EV. Nowadays, there is maybe next, please. Yeah, this is the micro electric vehicle teleoperated driving system. This is not full autonomous of EV, but semi-autonomous. Next. Also, we have 3 wheels EV for disables. This collaboration with our company, yeah. I mean the local company. Next, please. And we have also hydrogen-based EV development. So we use the hydrogen to by PMFC to generate the electric, and then to use by this electric vehicle. Next. Next, please. And also the EV charging system, because we have developed the EV starting in 2003 and 2005. Then we start this EV, charging, I mean DC fast charging, based on lead acid battery in 2006, and then we moved to 2011 charging to level 2 charging point, and then 2016 we began to research about the wireless charging. Next. And this is this DC fast charging. Next. Next is about this explanation about that what I have already mentioned. Next. Now began from the 2020, we built the charging station, yeah, AC charging station, and then 2020 DC charging station or fast charging, and we developed also the CS for electric motorcycles and battery swapping, yeah. And again with the CS management system. So until 2020 now, we already have built developed this AC charging system, DC charging system, battery swap, and also the CS management system. Next. So this is the charging station development. Next. Battery swap station, and next, this is the monitoring system for charging station. Next, again this management system. So now hydrogen research in BRIN, we start the hydrogen research for a couple years ago. Next, so with this focus research in BRIN, like biomass waste for hydrogen production, gasification biomass for syngas, until the smart microgrid for interconnection for hydrogen and others resource. Next. So there are multiple hydrogen technologies in Indonesia. So this from the gray hydrogen, brown hydrogen, until the turquoise hydrogen from nuclear. Next. And also we start to research about the hydrogen storage, because if we can produce the hydrogen, then we have to store this hydrogen gas. So that's why we start the hydrogen storage. Next. So this hydrogen storage, if we store the hydrogen gas by atmospheric pressure, then we should have a huge volume of tank, around 11,000 liters, for only 1 kilogram hydrogen. But if the liquefied this, we have to have the volume only 14 liters. Next. This is the type of hydrogen storage tank, like a type E cylinder, type 1, type 2, type 3, and also toroid composite vessel. Next. This is the inside look of the tank type 3 and 4. Next. Well, also we can storage the hydrogen by carbonaceous based sorbent material. And next, please. So this is the research group of fuel cell and hydrogen. So the activities like technology assessment and roadmap of co-firing hydrogen implementation, techno-economic of hydrogen fuel cell for microgrid implementation, technology assessment, the use of 40 megawatt small modular reactor, and also mil scale utilization of hematite for another anode lithium battery, and hydrogen research and development, hydrogen production, storage, and transport system. This is our partners. Next. Thank you very much for your attention. I give back to the moderator.
Big applause to Dr. Hasnan. Thank you, Dr. Hasnan. Very interesting topic about battery, about energy, electrical vehicle, yeah, and the last is about hydrogen storage. Okay, the next keynote is Professor Dr. Wahyudi Sutopo. I will read his brief curriculum vitae. Okay, Wahyudi Sutopo is professor in industrial engineering and head of industrial engineering and techno-economics research group, Department of Industrial and Engineering, Universitas 11 Maret. He also researcher for Center of Excellence for Electrical Energy Storage Technology, COIS, yeah. CIS, yeah. The President of Industrial Engineering and Operation Management, IEOM, Society for Indonesian Professional Chapter, and Director of IEOM ASEAN Pacific Operation. His background, his educational background is the profession of an engineering from UNS, a doctor and bachelor in industrial engineering from Institut Teknologi Bandung, and a master of management science from Universitas Indonesia. His research interests include supply chain engineering, economic and cost analysis, and technology innovation and commercialization. He has he written 4 textbooks and 7 chapter books and made 7 intellectual property rights and in front of 4 copyrights and 3 patents. Okay, Professor Dr. Wahyudi, time is yours.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you very much, Master Ceremony. It's very honor to me to stand up here to share our Center of Excellent Knowledge about energy storage for industry and a sustainable environment. Continuing the first keynote speaker, we would like share about energy storage for industry and sustainable environments. Next, maybe. Well, yeah. Yeah. Okay. Back first. Yeah. This, we have a outline. Lasernya nggak bisa ya. Oke, ini aja. Ini aja saya ada kok. Nah. Okay. Back to the outline first. Now, we have maybe we would like to explain about what is sustainable industry and environmental and why need energy storage. And then we will explain about why speed, creativity, and innovation is needed to get or to win as in the competition era. And we need technological entrepreneur development and TO to solve the innovation problem. And the end, I will also explain about why need the system of open innovation for energy storage technology. Next. Okay, what is sustainable and resilient? Sustainable is the ability to continue the important function identically without a decline in quality, and resilient is the ability to thrive in the face of a change. Of course, we can get an example. For example, sustainable development goals problem. We have very big a problem. For example, about the energy, lack of energy, and also the abundant population make the challenge to big innovation. National competition through affordable technology is needed. Of course, as a talking about battery electric vehicle technology innovation, we know that the battery electric vehicle technology innovation will provide transportation solution that are environmentally friendly, energy efficient, and our operating and maintenance costs. This is already as a conclusion that technology is needed to solve this problem. But the big problem, how the technology will choose, how the technology will achieve the market, how the technology will moving a sustainable and resilient industry, because the technology that develop it have so many obstacles until give the solution go to the markets. Next slides. Why energy storage needed? As we know that actually Indonesia have abundant renewable energy, but the problem how to deliver the technology to the application. Next slide. The technology from solar, technology from hydro, technology from biomass, and so on and so on. Okay, next slides. Now, the potential of a lithium-ion battery to be the major energy storage in the off-grid renewable energy is presented. Of course, longer lifespan than other technologies, along with the higher technology and power density, are the most favorable attributes of a LE-ion batteries. The key for mobility and stationary storage application. So, in this conclusion, this source conclusion, energy storage is needed to convert the energy to the application. Of course, one of the energy storage technology application can develop from lithium-ion batteries that can be used as grid energy and industry, in transportation, and also in customer electronics and also devices. This is why our Center of Excellence Technology Energy Storage as main our research. Okay, next. But the problem, if we are not research and development with speed, creativity, innovation, then the technology itself cannot as a winner in the market. Of course, the technology cannot solve the real problem that as I mentioned before. So we need creativity during competition. Of course, produce our creativity. Then this is in the picture that to show us how the creativity develop until can use to develop a productivity. Of course, so many steps in the value chain of creativity, innovation, and competition must be done. Of course, if we get the innovation, so the result of innovation is important. The problem is solved more efficiently, a process is more efficient, a risk is reduced, convenience is of course improved. Yeah. So the researcher, the inventor must move this curve, yeah, to the green one. So the time to market may be faster, and then the investment may be lower. Next. Now, besides that, we should also prepare that the technology itself must be commercialization can be defined as the movement of idea from the research laboratory to the marketplace, commencing at the very moment of ideation, ending in the point when a venture actually creates wealth. So we should make a bridging technical and also commercialization. We can call the technological entrepreneurship. We always remind our Center of Excellence not only to develop technology by technology push, but also always remind to market pull. We should know the express what is the market needed. So from the market, and then we create something, and then production and deliver to the market. But this is not easy, because so many obstacles that we know from the research, basic research, and then technology commercialization, and then technology technology development, technology commercialization, and then also market industry. Actually, so many kids that needed go-no-go activities. Go-no-go. If we are not solve the problem, no-go. So case is closed like that. Yeah. The technology will be offer, cannot until to the market, of course. Yeah. Go no go in the step 1, go no go step 2, and also go no go in the step 3. Actually, we should have a creativity, innovation, and competition ability to get faster feedback from the every steps. Okay, next. This is the illustration that we are now maybe engineers, student engineers, researchers, engineers, and then also many general society know well about technology readiness level. This is the simple one, how to measure the readiness of technology go to the market. We call technology readiness 1 until a 9. If the technology in the level 9, then of course can ready to commercialize. But in the step of the technology development itself, there are many problems, especially the problem about the product challenge, problem about business, problem about innovation, and problem about challenge. If the past, then we have the open to commercialize. Maybe the alternative to commercialization of the technology, we can choose license the product, a joint venture, spin-off, or a partnership. Then the technology itself can launch in the market and give the money, give the return, give the solution to the inventor. Okay, next. This is the illustration, our lesson learned from Center of Excellence for Electrical Energy Storage Technology, Universitas 11 Maret, that already established in 2019, but actually the research itself already start in 2012. That's accompanying the program government about mobil listrik nasional. Our milestone actually simple one, to develop storage and charging system product that are robust, reliable, and sustainable for imported product. Yeah, sorry, for substitute for imported products. This is our website, our Center of Excellence, and also our shorts information in the YouTube. Of course, we conduct a research like a brain, start from a material, and then battery cell manufacture, battery pack, control, safety, monitoring, battery management system, battery testing, and then also how to applicate energy storage in the electric vehicle and also the other application. Okay, next. Yeah, talking about the research, of course, in the part of a Center of Excellence, we have a division that's research about how to use early supply chain to support the technology commercialization. There are two objectives in the research early supply chain. First is to create the competitive advantage, and then the second one is to develop an efficient supply chain and service effectiveness. Because we are known that in the step of the startup, in the step of technology commercialization, so many obstacles, including product, business, process, and innovation. The common problem is to faster the time to market, and then to lower the to minimizing the investment of business acceleration. This is the two objectives of the research. By using the early supply chain integration, our Center of Excellence already make some research result, and we will explain in the next slides. Next. This is the illustration of our Center of Excellence. Start from idea generation, and then discovery the technology, and then study about the feasibility, the product, develop the prototype, until patenting and approval, production, and try to commercialize the technology to the market. Then, of course, after marketing, adopted or adoption step by the society in the real world, in the real case. Of course, we can take an example. Energy storage technologies will solve the problem of the pollution and shortage of oil self problem. Abundant, we have in Indonesia abundant renewable energy source and also natural resources. Then R&D make so many activities to solve the problem. There are many results including patent, and then also copyright, and then also industrial design. But the objective, the final objective is focus how to solve the problem itself by technology adoption. Next. Based on the real case that we already make the technology to solve and then make energy storage. For example, in the last slide we explained about Powerwall. We can make a lesson learned about the application of engineering innovation and innovation to accelerate commercialization through technopreneurship. Lesson learned from lesson learned for the startup, lesson learned for the commercialization, lesson learned for the tenant truck decommission, lesson learned for fostering business startup, and lesson learned about the measuring efficiency of the commercialization strategy. This is the step innovation from the research until the diffusion, and then we know that the state including conception, innovation, and the last diffusion. Okay, the next slide. This is lesson learned from our startup, Center of Excellence, PUI Battery Lithium Universitas 11 Maret already have 4 startups and already produce more than 20 patent, brands, and copyrights. From that, we also are running the model of a technological entrepreneur like that, yeah, starting from discovery until adoption, using our facilities that already integrated from the ecosystem. We can get so many feedback. Okay, next. First, we would like to remind all the importance of open innovation of energy storage technology itself. Of course, this is the PUI battery lithium that we call CFES. Actually, our center already developed internal technology base, but we need to faster to get also external technology to answer the problem to the commercialization. We can maybe technology in sourcing from the others, for example from BRIN is also possible, from industry, from the other university, but much faster. Then we can maybe deliver our research result to complete the technology itself. Then we can maybe commercialize by using licensing, technology spin-off, and then also open the new market, and also maybe other first market. This is the model of open innovation. In this occasion, we will like to remind all of us the importance of open innovation, importance of collaboration R&D process, not only UNS but also with the others, for example with BRIN and the other parties like that. So seeking new source of knowledge, market and outlets for the products and intellectual property rights, and collaboration with other, including customer, including rivals, yeah, including competitors, yeah, we should also collaboration, academic and also company outside of the industry sectors. Okay, next. Depend on the case of energy storage, for example, swappable battery, we already study about the importance of a standard. Of course, standardization can act as a catalyst for innovation. There is a relationship between standardization and open innovation. Open innovation system with a collaboration between supply chain players, universities, and the government to find thriving solution to enable the faster adoption and diffusion of a swappable battery. This is the implementation of open innovation in the face of the problem of swappable battery technology to get faster diffusion and of innovation, to develop and diffusion of innovation. There are so many interaction process to get outbound dissemination of standard, policy, regulations, swappable battery to the stakeholder. Okay, next. Of course, when we develop something, then we should also can measure the technology that we are develop. For example, we are also develop the method to measure the technology readiness measurement of open innovation tools. This is one of our research project team that propose by using THIO model, technology, technoware, humanware, infoware, and orgoware, and we can measure the level to accompany the technology readiness level measurement by a measure a low until ideal. We can make a calculation how ready the technology is and we can also predict the impact of the technology to the society and the impact the technology to the economic benefits. Okay, next. Then from the open innovation and early standardization of swappable battery, we already produce the standardization process. The standardization process can be characterized as a contributor to encouraging open innovation to support the development and dissemination of new technologies and the creation of a new market. Proposed strategy to leverage the swappable battery standards, technology readiness, and economic benefit, and open innovation, economic, and early standardization of swappable battery is can be established. For more detail, maybe the audience that's interesting about this case can maybe completely read the published paper in the international journal. Okay, next. Okay, as our concluding notes, we would like to explain that why energy storage technology is a key, because the energy storage is a potential solution for a sustainable environmental. Technopreneurship is also needed to manage innovation of energy storage technology. Then, lesson learned from Center of Excellence Electrical Energy Storage Technology UNS as a R&D and technology incubation already presented today, and open innovation to support commercialization of energy storage technology, and open innovation for swappable battery standardizations to encourage faster adoption and diffusion. Thank you very much. This is one of our lesson learned to solve the sustainable development goals, especially for energy. Thank you very much.
Thank you, Mr. Professor Wahyudi. Okay, very nice discussion. Okay, we go to the next session, question and answer. We have about 20 minutes before we go to the coffee break times. Okay, please say your name. Okay, the first is Professor Muhammad Nizam. Maybe another. Okay, Dr. Arif. Okay. Okay, second questions. Yeah. In this session. Okay, the first is Professor Nizam. Please.
Yes. I want to ask. Thank you for both speaker today. I want to ask to Dr. Hasnan regarding the research. As we know, previously we have a PRN that we must to refer to that roadmap research that we are already make our brain already make the PRN as the ministry decree 38 2019, if I'm not wrong. Sorry. As we know, we have now we have a scheme RIIM, right? So as we see that scheme RIIM is especially this is to continues or to replace the priority research national as I know. So what is now the status of the RIIM regarding the roadmap? Because as we see that we know is for the research especially we depend on the BRIN, because the BRIN is the organization that related to the national research. So what we this is the bureau. The bureau for the Indonesian Research Center, so that according to the roadmap, is it the same like the PRN, the previous PRN, or BRIN want to develop new roadmap, because when we see the roadmap to make or to develop the new roadmap is not easy. So how about this one? Because especially for the research, we are now on the especially for the battery energy storage, and also for the EV. We are now on on track on the PRN, but not recently, not because we don't know for the RIM roadmap, so we still following the PRN. What do you think?
Okay, thank you, Prof. Nizam. Okay, the next question, Dr. Arif.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I am very interested to the recycling about the spent lithium-ion battery. As presented before, that your institution also research about the recycling of spent lithium-ion battery. The question is how far the result of the research about the recycling of spent lithium-ion battery in the aspect of product. The product, whether precursor or directly as cathode. And the second one is how the capacity, and what is the recycling process chosen, whether pyrometallurgy or hydrometallurgy. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
This question to Dr. Hasnan. Yeah. Okay. Two question to Dr. Hasnan. Dr. Hasnan, please.
Okay, thank you. Prof. Nizam asked about PRN. So BRIN has not deal with the roadmap of each PRN. So roadmap of each PRN is responsibility for of this PRN collaboration, or what's that? PRN consortium. Yes. Yeah, PRN. It's a responsibility of this consortium. So doesn't matter if already the consortium already set up this roadmap, then please go ahead. So BRIN can provide the seed money, the seed money for this to implement this roadmap by consortium. But each member of consortium should have his own or its own allocation of money, research money. So not only from the BRIN, also from this each member of the consortium. So RIM or RIIM only provide the money for research for PRN by proposal that received by RIIM. So the RIIM or BRIN cannot change the roadmap, and roadmap set up by the consortium. And for Dr. Arif, thank you. So a recycling battery. Yeah, actually we just began this research actually. So until now we don't have any promising results. But as I mentioned about this process, we can have the both process, pretreatment or hydrothermal processing. Yeah. So I'm sorry, I cannot explain about further about this result of recycling battery, because we have just begun this research. Thank you very much.
Thank you, Dr. Hasnan. Okay, the next session, maybe we have time to questions. Okay, please hand your answer if you want to. Do you have questions? Okay. Please say your name and your institution.
Okay, thank you for the opportunity. My name is Cornelius Satriawida. I'm from Universitas 11 Maret. I would like to ask to both of the speakers today, to Dr. Hasnan. It's a very interesting topic that you brought today. I would like to ask about where is the position of the BRIN regarding the lithium supply, because we know that and the lithium-ion battery today is not only depend on nickel, which is been sounded by the government. So, is there any chance that Indonesia can produce its own lithium? And the second one is about the hydrogen production, about the blue production of hydrogen. What is the possibility? Is it going to use the solar cell technology or the geothermal technology for the BRIN? Okay, and the question for Prof. Wahyudi Sutopo, is there any plans for the standardization of the material or precursors in Indonesia? Because we know that it is very difficult to maintain the product of the cathode material when we try to produce a lithium-ion battery cell, because we as the consumer of the material often fooled by the quality of the product that being provided by the manufacturer. So I think it is very important for the sustainability of the technology. Thank you very much.
Thank you, Mr. Cornell. There are three questions. Two questions for Dr. Hasnan and one question to Professor Wahyudi. Okay, please.
Yeah, thank you very much for the questions. Okay. So for lithium, lithium supply, actually the resource of the lithium we can use not only from mining, so there is also a lot of resource in the sea, from the sea or from the biomass and so on. So we can explore, or we can use this resource for the lithium production. So that's why we have to research about this kind of resource. Yeah. So that's why I explain in my slides that we use waste, electric waste, electronic waste, or municipal waste, and so on. And for the second question about hydrogen production, so there are a lot of hydrogen production from the brown hydrogen, green hydrogen, or blue, and so on until the turquoise production. But in BRIN there is also a research organization for technology, nuclear technology. Then with this nuclear technology, we can produce hydrogen, let's say as turquoise production. So another technology is green production and also blue production, blue hydrogen, I mean. So from this different technology, we want to choose which technology is compatible for us and also efficient, efficient and effective for the hydrogen production. Yeah, thank you very much.
Okay, next, Prof. Wahyudi.
Okay, thank you very much, Mr. Cornell. Talking about early standardization, for example, that Mr. Cornell asked about standard for active material, that's ONS already produced about the active material. We would like to explain this. What is the standard? Actually, the standard is consensus between stakeholders, especially to give the assurance for our customer. Of course, we have a national standard we call Badan Standarisasi Nasional. But the problem, if the technology itself is new, we have a limited knowledge about that. So we can get lesson learned for our last activities about standard of battery lithium. Actually, UNS is as a institution that proposed the standard to Badan Standarisasi Nasional. In my stressing is standard is actually also can utilize as a strategy to commercialization, of course, but by government, but by the national policy. Of course, if we are already needed, we are need these standards, maybe UNS can also maybe deliver or send the letter to the Badan Standarisasi Nasional, then also make a team to as a initiator of standards. I think the government also will open about that, because actually if we writing the international standard itself and then we adopt it, then we are not maximized to explore our national differences. This is the problem if we are only adopted the standards. If we are make not different standards, a new one, we have a responsibility to make a standard that harmonize with international standards. And if our standard that developed by Indonesia not not have a problem with international harmonization, then our standard can adopt it as international standard. Of course, this is the challenge, Mr. Cornell, to our Center of Excellence, maybe to again propose the standard. We already have experience to propose the standard of cell battery lithium. Maybe I myself as one of the team to propose a draft standard to Badan Standarisasi Nasional. Thank you very much.
Okay, thank you, Professor Wahyudi. Okay, ladies and gentlemen, I think we come in the end of these sessions. Okay, I would very much thank you for both keynote speakers and to audience for nice discussion. Thank you very much. I think it's time is enough. I will back to Mr. Albert. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Right, thank you, Dr. Adrian. Ladies and gentlemen, please big round of applause for the moderators of the presenters. We're going to take a picture first. I kindly invite the keynote speakers and the moderator to stay on stage, or maybe here. And I kindly invite also to take a picture with keynote speakers, Prof. Muhammad Nizam, and Bapak Jamaluddin, and also Dr. Endah Retno Dartanti. Okay, and also I would like to greet Yes, and I would like also to greet the Vice Rector for Planning, Partner, Business and Information Affairs at Universitas 11 Maret. Good morning, Professor Dr. Renat Sajidan, MSc. Okay, we're going to take a picture, and also we have a token of appreciation. Okay, I am kindly invited to take a picture, Professor. We're going to take a picture first, and then after that we go with the token of appreciation for the keynote speakers. Okay, smile in 3, 2, 1, and go. Okay, is that enough? Pak Arif, yes, please join. Okay. Okay. Okay, we do hope that there is space. Okay. So for the media, hope. Check 1, 2, 3. Okay. Okay. We're going to take a picture. Everybody smile in 3, 2, and 1. Okay, ladies and gentlemen, give it big applause for dear Modi. One more time. Okay, one more time, everybody. In 3, 2, and 1. Okay, thank you, everybody. And we give also the token of appreciation. Prof. Nizam, I would like also here, Prof. Nizam, to give token appreciation. Okay, we're going to take a picture. Okay, look at the camera, Prof. Nizam and also Dr. Hasnan, look at the camera. Okay, in 3, 2, 1, and okay, the next one. Okay. Okay. Yeah, okay, we're going to take a picture. Okay, look at the camera in 3, 2, 1, and there you go. Also for our dear moderator for the first plenary session. Okay, look at the camera in 3, 2, 1, and go. Thank you. We kindly please return to the seat. Thank you very much. And ladies and gentlemen, right now, before we move on to the coffee break and also the parallel session, I would like also to pass the microphone to the Vice Rector for Planning, Partnership, Business and Information Affairs, Universitas 11 Maret, to deliver his remark, Professor Dr. Renat Sajidan, MSc. The time is your professor.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Dear colleagues and participants, on behalf of the International Conference on Energy Storage Technology and Application 2022 Organizing Committee, we are honored and delighted to welcome you to the second ICESTA 2022 in Universitas 11 Maret in Solo, held on 12 October 2022. We believe that all of you will get a platform to exchange ideas, broaden your knowledge, meet new friends, and also build a new colleagues in a wide variety on scientific areas with the common interest in renewable energy. This conference theme is entitled Energy Storage for Industry and Sustainable Environment. As part of the increasing global energy demand, there is growing interest in developing renewable energy technologies. Renewable energy sources such as wind and solar have great potential to reduce dependence on fossil fuels. However, renewable energy has uncertain output. So it requires energy storage to mitigate power variation and storage and dispatch renewable energy. Therefore, energy storage is expected to contribute to creating a cleaner environment and healthier society. ICESTA 2022 provides a platform for all participants to discuss specific areas such as the latest development and application in the fields related to energy storage, battery lithium battery. Furthermore, this meeting is expected to strengthen international networking between Universitas 11 Maret or UNS and other university in the world, and also with other institutions in Indonesia and also in the world. We are pleased to have our keynotes and invited speaker today. The first one, Dr. Hasnan Abimanyu, Diplom Engineer. Diplom Engineer is from Germany. Pak Hasnan is Head of Research Organization for Energy and Manufacture, Badan Riset dan Inovasi Nasional Indonesia. Second one, speaker Professor Dr. Ramesh T. Subramaniam from University Malaya from Malaysia. I think is online, by Zoom meeting. Thank you for your presentation in this conference. And then also Professor Nangklok Mitong from Khon Kaen University of Thailand, and also with Zoom meeting. Thank you for your presentation today. And also Professor Dr. Wayudi Sutopo is my friend from Universitas 11 Maret. Is Vice Dean in Faculty of Technic, ya, Technic Faculty, 11 Maret University, and also Dr. Insinyur Arif Jumari MSc, that is the young PhD from Environmental Studies in UNS, and the last one is Pak Joko Chandra Katon, STMM from Komisaris PT Semen Gresik Indonesia. Thank you for your presentation today. We express our gratitude to participants from all researchers and young scientists to join this conference. Many participants, I think, is young scientists here, and we realize that the conference success depends on both participants and who have worked with us. We hope that this conference will improve our experience and knowledge, as well as our awareness to nature sustainability in order to improve human well-being. With Bismillahirrahmanirrahim, I declare that the ICESTA 2022 is officially open. Thank you very much for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Professor Dr. Renat Sajidan MSc, for the remarks. Please kindly return to your seat. And ladies and gentlemen, it's time for all of us to have a coffee break and also parallel session. We're going to have the parallel session at 10. Ladies and gentlemen, please choose your room to join. There are 3 rooms, A1, A2, and this room will be A3, ladies and gentlemen. So please check your program again to know the speaker in each room. Now we kindly please you to enjoy the coffee break. We have served the coffee break at the main entrance of this ballroom, so you can go to the left side, ladies and gentlemen. And we're going to start the parallel session at 10, ladies and gentlemen. Please enjoy the coffee break first.
Lithium-ion batteries are remarkable because the same fundamental technology can be used in many different applications like medical devices, cell phones, computers, power tools, hybrid and all-electric cars and motorcycle, and also microgrid or home-based energy storage. Automation activities can enable business to improve performance by reducing errors and improving quality and speed, and in some cases, achieving outcomes that go beyond human capabilities. Today, over 3 billion rechargeable lithium-ion batteries are produced in each year in automotive sector for the customer. The automatic factory provides a realistic production environment with highly automated machines and technology, include coating machine, roller process, laser cutting, slitting machine, stacking machine, and many more for the processing of the electrode materials, cell assembly, case formation, and cell testing. Laser cutting is a contactless process which offers a fast and flexible adaptation of the cutting geometry and also provide high-speed process compared to conventional cutting technologies within the same investment range. Lithium-ion batteries are remarkable because the same fundamental technology can be used in many different applications like medical devices, cell phones, computers, power tools, hybrid and all-electric cars and motorcycle, and also microgrid or home-based energy storage. Automation activities can enable business to improve performance by reducing errors and improving quality and speed, and in some cases, achieving outcomes that go beyond human capabilities. Today, over 3 billion rechargeable lithium batteries are produced each year in the automotive sector for the customer. The automatic factory provides a realistic production environment with highly automated machines and technology, including coating machine, roller process, laser cutting, slitting machine, stacking machine, and many more for the processing of the electrode materials, cell assembly, case formation, and cell testing. Laser cutting is a contactless process which offers a fast and flexible adaptation of the cutting geometry and also provide high-speed process compared to conventional cutting technologies within the same investment range. Lithium-ion batteries are remarkable because the same fundamental technology can be used in many different applications like medical devices, cell phones, computers, power tools, hybrid and all-electric cars and motorcycles, and also microgrid or home-based energy storage. Automation activities can enable business to improve performance by reducing errors and improving quality and speed, and in some cases, achieving outcomes that go beyond human capabilities. Today, over 3 billion rechargeable lithium-ion batteries are produced each year in the automotive sector for the customer. The automatic factory provides a realistic production environment with highly automated machines and technology, including coating machine, roller process, laser cutting, slitting machine, stacking machine, and many more for the processing of the electrode materials, cell assembly, case formation, and cell testing.
Cek, cek. Assalamualaikum warahmatullahi wabarakatuh. Cek, cek, cek. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Welcome to room A2 parallel session 1. Next. My name is Muhammad Nuri Sanudin and I am a research assistant at the University Center of Excellence for Electrical Energy Storage Technology, 11 Maret University. There will be shown 6 presentation from Ms. Ria Dinastuti, Ms. Dianisa Hoirum Sandi, Mr. Anjas, Ms. Hikmah, cek cek, cek cek, cek cek, Mas Hikmah, Mrs. Henry Widiandari, and Ms. Rista on this very timely subject. But before we get started, we will open this session by listening to the presentation from our invited speaker this morning, Dr. Insinyur Arif Jumari, MSc. Next. Dr. Arif Jumari is an associate professor in Advanced Material and Energy Storage at the Department of Chemical Engineering, 11 Maret University. This is his educational history from August 2019 until July 2022. He was graduate as a doctoral degree with the title Environmental Science Postgraduate School, 11 Maret University. And at August 1999 until September 2001, he was graduate as a master degree MSc from Process Engineering Otto von Guericke Mecklenburg University. And from August 1986 until May 1992, he was graduate from the bachelor degree Chemical Engineering Universitas Gadjah Mada. The research interests are in advanced material and energy storage, especially in active material synthesis. The last research was about how to synthesize the active material from the spent lithium-ion battery. The focus of the research was the leaching metals contained in spent lithium-ion battery selectively between lithium and other metals, proceeding to precipitation and generation of active material. The previous research was about composite silica oxide to carbon as a high performance anode where silica oxide was isolated from fly ash. Okay, now we will welcome to Dr. Arif. Time is yours. Cek cek.
relaxation to understand the phase stability of the material during charge and discharge, and found that the LFS materials phase transformation can form a transient phase, such as the amorphous phase during cycling. And then after relaxation, it can form the expect crystalline phases. These behaviors have profound effect on the cycling stability of the materials and making them not practical initially for commercial use. However, recently we have shown that doping manganese into ironite can improve the material electrochemical performance, such as the cycling stability, as well as improve the rate capability. We use XAS to show that the main reason behind these dramatic improvements come from the fact that the iron-oxygen bond length with manganese doping changes. These changes facilitate the lithium-ion diffusion and improve the rate capability of the materials. We will go a little bit deeper into detail of how the synchrotron X-ray based technique can help us to understand the behavior of these three groups of cathode materials. The first one is the silicate-based high-capacity cathode. The second one, olivine-based high-power, high-safety, cheap, and long-cycle life cathode. And the last one is the layer oxide with high-capacity cathode. The second group of materials that we have studied is the olivine material, or LFP. Before this study, researchers believed that during charging and discharging, lithium ions are inserted or extracted from the olivine structure, changing from triplet to heterocyte structure reversibly. During this phase transformation, the crystal volume of this material contracts and expands as the lithium ion come in and out. But after we have used the XAS to study them, we revealed that the dynamic phase transition during charge and discharge at different current rates are quite complex. We found that the phase transformation involve transient phases such as forming solid solution and amorphous phases too. And recently, we also use several new techniques that are available at the beamlines in Thailand, such as wide-angle X-ray scattering or wax, and the in situ X-ray diffraction to study the phase transformation of some newly developed materials like the manganese dope LFP. We probe the local and electronic structure around both Mn and iron H during cycling at slow discharging rate, such as at C/5, and at fast discharging rate, such as 5C. We found that the phase transformation of LMFP materials is even more complex than the LFP material, involving several stages of non-equilibrium phase transformations. We will go a little bit deeper into detail of how the synchrotron X-ray based technique can help us to understand the behavior of these three groups of cathode materials. The first one is the silicate-based high-capacity cathode. The second one, olivine-based high-power, high-safety, cheap, and long-cycle life cathode. And the last one is the layer oxide with high-capacity cathode. For the last material I want to show you today is the material called layer oxide cathode, or we usually call them the lithium-rich layer oxide, since this material contains more than one lithium per mole. This means that this group of material can give very high capacity and is considered one of the promising new next generation cathode materials for high energy density lithium-ion battery for mobility application. In this work, we use various several techniques such as the X-ray diffractions along with the electron microscopy and diffraction to study how to improve the cycling stabilities due to the phase transformation of the LMO components to spinel structure. We show that larger domain sizes of the LMO components can retard the phase transformation to spinel phases, resulting in improving cycling stabilities of this high-capacity cathode material. In addition, we have investigated the effect of synthesis condition on their crystal structure studied by in situ X-ray during heating and cooling, and electronic structure using X-ray absorption spectroscopy, as well as the electron microscopy to study their microstructure of these group of materials. We have shown that again the domain size of the layer LMO, layer LCOs have the profound effect on the cycling stabilities of this group of materials. Therefore, the optimization of domain sizes is the most important criteria for producing this material for next generation cathode. We also study structural changes during cycling of this material at different cycling or at different current rates. These will affect how phase transformation of this material proceed during using at different conditions at different applications. A surprising result from this work is that this material has higher cycling stabilities if they are used in the fast charging or discharging conditions. Unlike other group of materials that we know, fast charging and discharging usually dramatically reduce their usable cycle life and affects the performance of the batteries so much. So there's a recommendation not to fast charge or fast discharge the battery often. But for this material, it's the opposite. If you charge or discharge them at very high C rates, the material are very stable. We will go a little bit deeper into detail of how the synchrotron X-ray based technique can help us to understand the behavior of these three groups of cathode materials. The first one is the silicate-based high-capacity cathode. The second one, olivine-based high-power, high-safety, cheap, and long-cycle life cathode. And the last one is the layer oxide with high-capacity cathode. As I mentioned earlier, we are also interested in new battery systems such as aluminum batteries. We have recently studied the interfacial properties of the aluminum anode in various conditions of the electrolytes. This work will lead to better understanding of the effect of the passivation layer toward improving the electrochemical performance of aluminum ion batteries so that it can be commercialized in the near future. In addition to very fundamental works on phase transformation, we have also produced some various nanoparticles to study their electrochemical properties and making some key ingredients such as nanosilicon to make anode for fast charging application using the raw materials that are renewable in the local areas of Thailand, such as the Raihas. Based on our own technology, we have now produced our lithium-ion batteries in the cylindrical format in Thailand, as well as in a manufacturer in China. Our current customer of the cylindrical lithium-ion batteries are mainly to serve the fast-growing demands for the 2 and 3-wheelers, like e-bike, electric motorbikes, or some electric tuk-tuks in Thailand. We have also made battery packs for larger applications like energy storage system, as well as some special applications like for military project. We do also have a complete set of quality management as well as some safety testing in our factories. This make our batteries to have high reliabilities and high quality in terms of safety. We are in the process of being certified by the ISO 9001-2015 as well as ISO 17025 2017. Hopefully by the Q2 of 2023, we will be certified. This will ensure that our product and services comply completely with the international standard. Here are the summaries of my talk. I hope that during my presentation, I have shown you how important of the phase transformation behaviors during cycling of the battery materials are toward the understanding of their roles to structural and electrochemical properties of the battery materials. Several techniques are covered, including XAS, wax, and in situ XRD. These powerful tools are used in my research group and are open for future collaboration with Indonesian researchers, especially in US researchers. My interests recently have been in the alternative system that are not dependent on lithium or nickel or cobalt because we don't have these resources in our country. These alternative systems, including sodium ion based and aluminum ion based batteries. I also shown an update on the production facility at KKU and hope that this facility will be one of the key enabling facilities for Thai and ASEAN rechargeable battery industry in the near future. Thank you for your kind attention. Terima kasih atas perhatian Anda.
Thank you, Ms. Nonglak, for the presentation. Okay, moving to question and answer. You could use chat or raise hand feature, which is available in Zoom if you want to ask a question. For the first session, I will open 2 questions. Okay, in the chat room, Mr. Chico Hermano. Honorable Professor Nonglak, thank you, Prof. Your presentation is great. I want to ask about the battery material. How are the criteria for a good battery material in a tropical climate so that the battery has a long life cycle, especially for grid scale and renewable energy power plant applications?
Very good question. Thanks for the question. Basically, if we only focus on type of materials that we can choose to use for grid scale energy storage, if we only focus on lithium-based system, long cycle life is the characteristic of LFP-based system. So usually we recommend people to use LFP-based system for ESS. However, if you have followed some recent development for a grid scale energy storage system, it doesn't have to be lithium-ion based. So just to make sure that everyone understand that, there are some new kind of
system like flow batteries, like other ESS solutions. Those are being discussed and researched around the world. But in terms of lithium-ion based system, LT recommended. Yeah.
Okay, thank you, Ms. Nonglak. Is there any question? Okay, first question, one question from me. I'm interested in the aluminum ion battery. So far, to what extent Ms. Nonglak did your research, and what are the challenges when compared to lithium ion batteries?
Well, can I have the first question again? How far?
How far you did the research of aluminum ion battery?
Okay, so right now we are doing both the cathode and the anode. We have been working on the cathode of aluminum ion battery for maybe three or 4 years now, because we had a good collaborators in the New Zealand. He's Professor Thomas Nance. He's very famous in aluminum system. But the major challenge of aluminum system is actually the corrosion problem. So that's why we moving toward understanding corrosion behavior of aluminum anode right now. So that's why the synchrotron-based techniques come in order to understand those interface properties. Yeah.
Okay, thank you, Ms. Noklan. And the last question maybe from Mr. Cornelius Satria Yuda. Time is yours.
Okay, thank you, Ms. Sophie, and hello, Prof. Nonglak. I'm so honored to finally meet you again since I think 2018. Yes.
Yes, that's right.
18, yes, the last one we met. It's been a very long time, and it's good to see you. And we can wait for the arrival of your students to join in our facility. And I have this similar question with Miss Sophie earlier about the aluminum ion battery, because we know that Indonesia is rich of aluminum, and the problem is also the corrosion of the anode. Is there any study that have been performed by your team about the effect of the thickness or maybe the protection of the aluminum layer or maybe the electrolyte? It is very important factor for us to develop that type of battery also. Thank you very much.
Yeah, it's very interesting. I mean, if you think of in terms of resources, aluminum is one of the resources that very available. It's much cheaper than nickel. But the thing is, Indonesia also has nickel, so you guys are very lucky. Yeah. Yeah. Okay, we have another questions, right?
About the electrolyte, is there any what type of electrolyte that have been developed by your team?
Well, the thing is, the focus right now is using the most widely available ionic liquid-based electrolytes. You do understand that these ionic liquid-based are very expensive and very attaching to the aluminum anode. So we're trying to understand the process of producing a passivation layers in order to protect the aluminum surface first. We have some modified chemistry for making this protective layers, but it's still under developing, I would say. We're trying to understand it. Yeah.
Okay. It's good to know. It's good to know. And we also want to catch up with you.
Yes.
And we hope
we have a silicon anode question, right? The question is price characteristic. What
we
types of...
can collaborate in the future.
Yes.
Thank you very much for your time.
Thank you.
Okay, I think for Miss Nolak, time is up. The next question, Miss Adesianti, maybe.
I can type in the question. I can type in the answer for her, I think.
Oh, okay. Okay, thank you, Miss Nolak.
Thank you so much. Thanks for the invitation.
Okay. Now moving to our session, please welcome Mr. Chico Hermanu Brilianto Apribibowo from Universitas 11 Maret, who will be speaking to us on fabrication of electrode of supercap battery based on aluminum oxide activated carbon aluminum foil cathode and silicon carbon black nickel foam anode. And here is a video presentation that you can watch. Belum share.
Frequency harmonic question. Okay, thank you for your Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Cikwan Antipomo. I will take reason about research the fatal impact of the birthday storage system on operation cost for just loss of food and time. First introduction. The reason of the assistant the assistant of penetration renewability in our system with high amount of high penetration and renewability causes such as reverse power flow, salt occultation, frequency harmonization, and other way the characteristic of the renewability system, especially for power PV photovoltaics and wind turbine power plant, is high intermittent, high uncertainty. So it can be to make a disturbance for stability in grid power system. So the electric power system need to be flexible to use increased amount of reliability. So when absorption is using the BESS or battery system, is when our overcome the stability of the power system. BESS can improve the performance of electric power system. Can improve the pressure of the curtailment of P and reduce loss of load. The integration BESS can have potential and lowering the grid cost, so lowering the cost estimation and lowering the production of COX. So with amount of the height of interest in electric vehicle, we can grid advantage. One of the grid advantage is you using the second F battery or return battery. Return battery or second battery is a battery with state of heart amount 80%, 80% or 60 until 80%. So you can return battery can still use increased capacity of renewable energy system. The solution, one of solution can be assessed using is applying the optimal sensing and scientific PSA system with a great scale. The result is using pressure return battery is possibly compared again and lowering the operation cost. The challenging in our research is how to modeling about the pricing operating PSSS and invested using and setting and assessing in grid scale power system. And the optimizing and the optimizing PSSS will get best optimal result in sensing and setting with scenario in grid scale. The strategy to determine optimal grid capacity will depend on energy capacity and power rating. So the technical responsibility objective the from is the investor point of view and or utility point of view. You can see now the objective function in our research. In question one is about the total present cost on all total planning cost and one day scheduling. The costs are operation cost, variable, variable independent about the empirical, independent about present cost, the development cost, value of lost cost, and installation present cost. Equation 2 about field cost, equation 3 about the PV curtailment, equation 4 about loss of load, and equation 5 about the investment of battery energy system. The equality design constraint about the power energy balance, the active power flow, active power limitation, the limit for load or load shedding power. The problem between the about inequality DG operation constraint. RAM rate constraint about the PV operation constraint is consists of the limit of the power of PV output and PV containment power. And also we use inequality PS operation. You can see that inequality constraint about just and just is the key point use the PSSS as adding limit not just and just. The balance is our PSNG capacity also. The proposed method about using data parameter about beginning the data parameter, profile duration, profile PV, input the profile battery, input the profile demand, and input profile cost. We now solve the operational present cost is connected the next interlinear programming and method the branch and ball. Minimal total operation cost we use a power and energy data into the system. Use technology about the press and return battery, solve the daily operation cost about power aggregation loss of loss, overflow, voltage angel, power voltage, power charging, sensing, and EPS continue. When the minimum operation cost we know the total operation cost all of plus is trying. We know we cannot find the optimal placement or setting and sizing of the HSS with optimal solution. So optimal solution we can know about the bus and technology, energy and power battery. In case study in our research, I use IEEE 24 test bus system model with a PV scheduling with 1 day scheduling or 24 hour. The demand load is 24 hour. Table of one and data parameter PSSS, new battery and return battery cost, round trip efficiency, daily service discharge, power rating cost, energy cost, installation cost, and maintenance cost. And study to analyze the effect of PSS using a comparison of press and return battery on the cost of the function. We analyze 5 cases. Case A, daily operation cost without PSS. Case B, operation PSS plus battery without optimization PSS. Case C, of daily operation PSS with return battery without the optimization of PSS. Case D, using the press battery using optimization of PSS sizing and setting. Case E, daily operational system with return battery or secondary battery life using optimization sizing and setting battery. In case A, daily operation power system without PSS, we know the our total operation cost with high total operation cost are highly affected by uncertain and up to 8 million 2,500 dollar. So this happened because the energy supply is cost high. The loss of demand is high. Loss of load and demand and portable payment is production from demand is high, cannot be storage in battery. And next the case B, we now using fresh battery with fixed battery size setting. We now use you can see that the only displays battery charging and discharging in 1 day scheduling is 3 times charging. This time charging can be using power rating 80 megawatt 80 megawatt energy rating 100 megawatt hour and using a bus 19 bus. This can reach the loss of providing for competition and using this can reach the previous curtailment causes 75.35% from B and then case A. And case J with a return battery with fixed size and set. We know we find that previous curtailment cost more than lower about the 75.55% from case A can reduce operating cost more lower than case B. For 40.70% case B with total daily operation cost more lower than case B. In daily operation case D, press battery optimization with optimization basis with a number of PSS. You can see overrenting more effectively in plus 5, plus 7, plus 8, plus 30, plus 60, plus 90, plus 20, and plus 5. Because now we reduce cost more lower than case B, and because
Okay, time's up. Next, please welcome Ms. Adesianti Nurul Hidayah from Universitas Negeri Malang, who will be speaking to us on impact of fresh and retired batteries for optimal battery energy storage system on operation cost for increased flexibility. And here is a video presentation that you can watch.
For aluminum foil cathode and SE carbon black nickel foam anode. And the authors is Prof. Markus Diantoro, Dr. Nasipudin, Dr. Risa Suryana, me Adesnya Nurul Hidayah, Nadia Jati Nurmayanti, and Prof. Murawat Mipasana. The introduction, the increasing energy crisis worldwide due to the scarcity of fossil fuels, global warming, pollution, and environmental degradation has encouraged the development of energy storage technologies that have high performance, cost-effective, environmentally friendly, and sustainable. The development of energy storage media is one solution to deal with these problems, but the challenge is how to make a device with high specific capacitance, high energy, and power density. The devices that we know so far is battery and supercapacitor. Battery has a kind of not eco-friendly, so cycle life, low power density, and high energy density. And for supercapacitor, it has a characteristic of long cycle life, high power density, short charge time, eco-friendly, high electrochemical reaction, fast redox reaction, and low energy density. For the material that I used is aluminum oxide that has a characteristic like high thermal conductivity, high corrosive resistance, good chemical stability, high specific surface area, and low electric conductivity. And for activated carbon has a high specific surface area, good chemical stability, high electric conductivity, good cyclic stability, and long life performance. For anode materials like silicon, silicon has a high capacitance, low operation voltage, and environment friendly, but silicon has a big volume expansion on electrochemical process. And the carbon black has a characteristic of high thermal and electric conductivity, high specific surface area, and good cyclic stability. So in this study, the effect of the addition of aluminum oxide on the morphology structure, crystal size, functional group, porosity, and electrochemical performance will be studied to get a combination of supercapacitor devices with high specific capacitance, energy density, and power density. The materials that we used is activated carbon, carbon black, aluminum oxide, silicon, AT for NPF for electrolyte, PVDF cold fiber separator, and nickel foam substrate and aluminum foil substrate. This is the methods that we used. We're using a blending method. First, we prepare the materials with the ratio of active 10 and 10 with active materials, conductive materials, and binder. The active materials here is aluminum oxide and activated carbon, and then stirred 1 gram La133 binder with DI water 3.5 ml at 300 rpm for around 1 hour, and then add 0.1 gram carbon black and stirred with 500 rpm for 1 hour, and add an active materials with total mass of 0.9 gram. The solvent stirred for 24 hours. And then for the data thread calibration with scale of 20 micrometer, and then vacuum process of substrate, the homogeneous solvent coat on substrate. After this, heating the samples at 100 Celsius for 50 minutes, and then cut the samples in a circular shape. This is the fabrication of coin cell to check the performance of these materials. And then this is the method to make an anode of Se carbon black. We use PVDF binder and DMSC solvent, and then we fabricate the samples on nickel foam substrate with micropipette like this, and then we can make a pressure to make a sample more thin than before, and then the samples is in electrolyte like the last picture. And then this is the analytic methods we use as RV characterization, FTAR, SAM, and newer BTS 5000. The newer BTS is used to check the performance of the supercapacitor. Result and discussion. First, X-ray diffraction. This is the SRT pattern of aluminum oxide Ag aluminum foil with aluminum oxide composition of 0 and 10%. The diffraction pattern formed is dominated by amorphous arrangement, which shows the structure of activated carbon. The diffraction peaks of activated carbon are shown at angles of 2 theta of 26.50 degree and 43.36 degree with HKL planes of 002 and 100. In addition to the diffraction peak of activated carbon at an angle of 2 theta 38.47 with the HKL 111 plane, it shows the diffraction peak of the aluminum foil substrate used. And this is the SRD pattern of SA carbon black. The diffraction patterns of produced by the samples are in the HKL 111, 220, 311, and 400 planes. With GCPDS data number 27. Compared to SE nanoparticle, the diffraction pattern of the SE carbon black PPDF thin layer form has a lower intensity. So for the sample, the crystalline size of 0 aluminum oxide and 10 aluminum oxide has increased and the crystallinity also increased while the crystalline size is decreased. And then this is the FTER characterization. The FTER characterization shows a wave number at 30,529.73 until 1,288 centimeter. That indicates the absorption functional group between OH, CH, CC, and ALO. And the next is FTER of thin film SE carbon black. It shows the wave number between 3371.57 until 1141 centimeter that indicates the OH, CH, CC, and SEO vibrational group. The next is scanning electron microscope characterization. From the analysis carried out, is noted the particle size distribution of SE powder is 60 nanometer. This result of the SE particle size accordance with the research of Tian et al., which suggests that the distribution of SE particle range from 20 until 60 nanometer. The porosity of the supercapacitor is increased, while the composition of aluminum oxide is also increased. And then in the image A, there is a pore with a diameter of 4.3 nanometer, which shows the pores of the nickel foam substrate. The activated carbon has a morphology resembling a sheet lamp and has large pores. And then the addition of aluminum oxide makes the pores of the activated carbon covered by metal. And the last is GCD characterization. Based on the resulting Justice's graphic analysis, it can be processed to determine specific capacitance, energy density, and power density using this equation. And for the sample, when the composition of aluminum oxide is increased, so the capacitance, energy density, and power density is also increased. And the supercapacitor devices shows a superior performance with specific capacitance and energy and power density is higher than another sample. So the conclusion is the addition of metal oxide mass to the electron composite causes a decrease in crystal size and increases the degree of crystallinity. Same analysis show the porosity of thin film supercapacitor increases with the metal oxide addition at 10% composition. And for KCC analysis show that the performance of the supercapacitor electrode increases with increase in the mass of aluminum oxide. So this is all that I can explain. Thanks for your attention. I'm sorry if there is a mistake that I make. Thank you and wassalamualaikum.
Okay, time is up. And then please welcome Ms. Isma Lutfia from Universitas Negeri Malang, who will be speaking to us on zinc oxide microstructure modification and their potential for high stability performance supercapacitor. And here's a video presentation that you can watch.
Honored to be presenter in this international conference on energy storage, technology and application, ICESTA 2022. In here, I want to present about my research. For the title, ZNO nanorods are ZNO and R microstructure and modification and their potential for high stability performance of activated carbon manganese 2 3 oxide supercapacitor. For the author, for the first author, Professor Markus Diantoro, and me, Ismail Lutfia, and Mr. Hari Wisodo, and Mr. Joko Utomo. For the last author is Professor Associate Professor Warawat Mevisana from SUT Thailand. For the next slide, in here I want to present about the background of the zinc ZNO nanorods and how if I want to composite ZNO nanorods with the activated carbon and Mn2O3 and how about the impact for the ZNO nanorods for the performance. In the background, government plans sustainable development of the electrical technology sector from renewable energy storage in Indonesia up to 85% by 2040. So, this is effort will require electrical energy storage device with greater performance. And about this plan from the Indonesia, we need a big or the good materials to make the electrical energy storage device. And in here I make the research about the modification additional of ZNO nanorods. In here, if you want to make the electrical energy, you must optimization by the active materials and the conductive materials. For the active material, we use the activated carbon and Mn2O3. For the conductive material, we can combine by carbon black and ZNO nanorods. For the active material, we need the performance is like the specific capacitance is more high. And the low toxicity because in here, for the materials like the battery, is having very high the toxicity. And for the two, we need the material is low cost and abundant in nature. But the weakness from the active materials is having low electrical conductivity, accessibility electrolyte, and low ion diffusion. So, from that problem, we must to make the composite material Mn2O3 an addition by activated carbon and composite again with the carbon black and composite again with the ZNO nanorods is needed to improve the performance of the supercapacitor. So, the modification of additional ZNO nanorods is having in the research from the Mustika Sari et al. From that the research, we can know that the nanostructure modification has different physical properties. The structure of the nanorods can affect a material to improve storage performance because the surface area more higher than nanoparticle. And then for the other research from Songsan et al. At the 2016, the specific capacitance if you use with the ZNO nanorods increase multiple too with the addition of the ZNO nanorods. For the example, if you just using the MnO2 nanowire, you just get the performance is 120 farad per gram. But if you composite with ZNO nanorods, you can get more higher. That is until 261 farad per gram. So, based from that theoretical modification, ZNO nanorod and the MN, MN2O3 or MZN nanorod in here, I make that title for my sample. So, you must know that compound about the supercapacitor, you must the optimum by the electrode, electrolyte, and separator you use. And then, why? In here, I make the modification electrode because if you want to make more higher performance, you must optimize by the electrode materials. So what is the impact? The impact is you can get an effective way to improve the energy density and power density of energy storage device. And that is the optimum for to achieve low cost production while also be environmentally friendly. And that is the key or the key important to get the components determining the capacity performance at the electrode material of the supercapacitor. And in here I make the carbon black because the carbon black is having good in conductive enhance, and that is very good to know how to the electron it's can more stable for the supercapacitor. And the next in here I want to present about the experimental method I use. For the first, you must prepare the aluminum or activated carbon black. For the binder is PVDF, and for the solvent is NMP. And in here I make the electrolyte is 1 molar ED4 and BF4. And for the device, I use the spin code with the that specification. For the digital maze, for the measure the maze, and then I use the hot plate, I use the press for the coin cell, and I use the oven. In here, I make the experimental method for the nanoparticles, ZNO nanoroach. So in here, for the first, I must to make the material from the zinc acetate dehydrate and addition by 20 milliliter ethanol. And after this, I must to addition again with MEA. After this, I must to waiting at the room temperature, but it is still nanoparticle. So how do I make the nanoroach? I need to immerse in the solution for the 5 hours. After I get it, I must to use the furnace. After I get the film of ZNO nanoroach, I must to deposit again with the activated carbon, Mn2O3, and carbon black. This is after I get the solvent of activated carbon, carbon black, and Mn2O3, I deposit in the aluminum foil. After this, I must to fabrication my supercapacitor using the coin cells. For the first, you must be using coin cell kit. Separator electrolyte arrange the electrode. After this, you need to injection with the organic electrolyte for the 1 molar of ED4 and BF4. After this, you need the fabrication process shall be handled with the care because the electrolyte is very toxic. And the press is the coin cell. After you get the coin cell, you must characterize. And for the next, this is my result and discussion. For the first, I get the performance from the X-ray diffraction. That is, I use the variated by the speed speed of the spin coating. For the first of speed is 1,500 rpm, and the 2,500 rpm, and the 3,000 rpm. And here you can see that for my one sample is MZNO and R1, that is having the speed of the spin coating is 1,500 rpm. From my sample at the 1,500 rpm, you can see that the intensity for the material is more higher than other. You can see it that in the file 0.0002 and 001. And here we can get the conclusion that addition of the ZNO nanorods of the Mn2O3 activated carbon-carbon black materials in increasing the intensity diffraction pattern in the ZNO nanorod phase called the 011. And from the result of the refinement, you can see that parameter of Kisi, the higher rate of the spin coating parameter, the crystal width and volume will gather more lower. After this, the result and discussion. This is
I'm sorry. Okay, moving to the question and answer session. You could use chat or SN feature, which is available in Zoom if you want to ask a question. For the first session, I will open for Mr. Chico Hermano. Or maybe we can go to Miss Ade and Miss Isma. For question from Mr. Cornelius Satria Yuda. Is there any plans or recommendation on the improvement of material specific competency? Please, for the first, Miss Ade to answer the question. Hello, Miss Ade.
hello.
Oh, okay. Ms. Isma Lutfiah maybe can answer the Mr. Cornelius.
Sorry, maybe I will answer this question. Um, if this question is how plans or the recommendation on the improvement the materials, maybe I'm recommendation to modify the materials, like you make the activated carbon isoporous, or like the modification from the nanoparticle to be nanorods, or the modification from the nanoparticle to be nanowire, because for the storage or the having more higher the capacitance, I think that's enough to can modification the material of the electrode. Maybe Mr. Cornelius.
Yes, is that enough, Mr. Cornell, or Miss Isma? To Miss Isma, is there any doping strategy?
For now, from my research and my team for the doping, it's still under research. But if I'm read a paper, if you use the doping, you can move the structure and the properties of the materials. So if you want to doping something, you must know the characterize the material you want dope and the what you want to make a different properties. That's maybe. So I think it's strategy too, but for me, if you really want to more higher the performance, I think it's much better if you use the modified your properties, like use mesoporous or the nanowire, nanoflower, or something like that.
Okay, thank you, Ms. Isma. Hello, Ms. Ade.
Yeah, hi.
Okay, there is a question from Mr. Cornelius Satria Yuda. Is there any plans or recommendation on the improvement of material-specific competency?
Oh, okay, let me answer the questions. So I have a plan to improve the performance of my supercar battery. Um, I want to make a power of SE anode. So under my research now, I still doing a SE porous to improve the specific capacitance of my supercapacitor. Thank you.
Okay, thank you, Ms. Ade. And the next question from Mr. Iqbal Alfuadi for Ms. Isma. What is your reason to use the electrolyte? And can we use an aqueous ionic electrolyte for supercapacitor?
Okay, let me answer that question for Mr. Iqbal. I think before I ever the research for the supercapacitor is like the potassium hydroxide, like Na2 sulfate and another, but the performance is not really good. And from my research is very good if you use the organic electrolyte like ET4 and BF4. But the disadvantage or the weakness of the organic electrolyte is the organic electrolyte is uh, cannot you make a more time. Maybe just can use until 3,400 cycle for one coin cell. That's because after use a long time, the organic electrolyte will crystalline. Something it's not aqueous again. That's the problem now for the research of supercapacitor. Maybe that's enough or not? Oh, but the performance I think it's not really good too. But you can try in your materials maybe. But for a long time, my research, I get more higher the capacitance, more higher the energy density. Still use the ET4 and BF4 or organic electrolyte. It is enough. Okay, thank you.
Okay, thank you for all speaker. Now moving to the next speaker. Please welcome Mr. Bahtiar Suherman from Universitas 11 Maret, who will be speaking to us on the microstructure atomic bonds and the electric properties of neodymium barium titanate. And here is a video presentation that you can watch.
Assalamualaikum warahmatullahi wabarakatuh. Hello everybody, I'm Bahtiar Suherman. In this section, I will present my paper entitled Microstructure, Atomic Bond, and Dielectric Properties of Neodymium Barium Titanate. My paper was compiled by me, Dianisa Khairum Sandi, Fahrunur Roshid, and Juventina Iriani. In the first section, in the introduction, in the recent years, technological development in the field of sustainable and renewable energy have overgrown and prompted the exploration of high-performance energy storage system. Ferroelectric material are one type of material often developed and applied. Ferroelectric material has superiority, they have spontaneous polarization without the influence of an external electric field. One of the most ferroelectric material is barium titanate or BaTiO3. BaTiO3 has a BO3 perovskite structure. The performance of a ferroelectric material can be affected by doping. In this research, barium titanate will doped by neodymium ion has radius is 1.27 angstrom, and neodymium ion occupies the part of the crystal with the APO3 perovskite structure. Material and method. The material used in this work is barium hydroxide from sigma aldrich with Heg purity 95%, oxalic acid dihydrat from Mars with high purity 99%, titanium tetrabutoxide from Sigma Aldrich with high purity 97%, neodymium nitrate hexahydride, isopropanol or IPA, and distilled water. And the method of this research is co-precipitation. Co-precipitation has superiority for the first, more homogeneous microstructure, better electrical properties, low processing temperature, low cost, and high quality. The co-precipitation step, for the first, oxalic acid dihydrate and titanium tetrabutoxide were separately dissolved in isopropanol or IPA, producing solution 1 and solution 2 respectively. The second, barium hydroxide and neodymium nitrate hexahydride was dissolved in isopropanol and mixed with solution 1 and solution 2. And then distilled water was added into the mixed solution. The solution was using ethanol and distilled water. After that, the sample was hydrolyzed, making a powder. The sample were then sintered at varied temperature of 900 degrees Celsius and the holding time of 4 hours. The sample were analyzed using X-ray diffraction, Fourier transform infrared, and resistance capacitance inductance or RCL meter. The mole concentration of ND dopant were varied at 0%, 5%, 10%, 15%, and 20%. Accordingly, the sample were then coded as BT, BN5T, BN10T, BN15T, BN20T, and BT for its mole concentration respectively. The research purpose, this study aims to determine the impact of the mole concentration of neodymium doping on crystal structure, atomic bond, and dielectric constant of barium titanate. The mole concentration of doping used in this study were 5%, 10%, 15%, and 20%. The result and discussion. In figure 1, we can see that the diffraction pattern of barium titanate and neodymium doped barium titanate with various neodymium concentration inside the magnification peak of 101 planes. The figure also shows peak with marks star identified as the barium carbonate impurity base. The appearance of this impurity might be due to the incomplete reaction of all starting material during the sintering process. Further, the insight of figure 1 is the magnification of 101 planes of all sample. It is apparent that the addition of neodymium doping causes a right shift in the diffraction peak. The shift could be a sign that there is change in the lattice constant of the crystal structure due to neodymium doping. It is stated that substitution atom with bigger or smaller radii cause change in the distance between atoms and the value of the lattice parameter decrease. In table 1, we can see that G-square, lattice constant, cell volume, crystalline size, and tetragonality of barium titanate and neodymium doped barium titanate. The G-square and lattice constant we get from refinement using Redfield method from GSAS application. This is the Redfield refinement of barium titanate and neodymium doped barium titanate. After that, we analyze the atomic bond of the sample using FTIR. In figure 3, display FTIR spectra of all sample at wave number of 350 to 4,000 cm. Based on the figure, the prominent stretching vibration around wave number of 542 cm and 432 cm denote the presence of TiO and BaO bonds. Thus, it confirmed the successful formation of the barium titanate perovskite structure in this study. And then we can calculate about the density of the sample using this equation. Rho m is measured density, m is mass of bulk, and v is mass of volume of bulk, and rho t is theoretical density, m is molecular weight, v is volume of unit cell, and a is Avogadro's number. In table 3, we can see that the measured density, theoretical density, relative density of barium titanate and neodymium doping barium titanate. We can see that the relative density is decreased with increasing this neodymium doping concentration. And then we analyze using RCL meter to get the dielectric constant. The dielectric constant, we can see that the decrease with increasing frequency. It causes polarization gradually declines with an increasing in frequency and becomes stable in the higher frequency, where the space charge and dipole cannot follow the electric field at a very high frequency. Consequently, there is no movement in the dipole, so that the dielectric reduces. And then we can see in table 4 that the higher dielectric constant it has at pure barium titanate. The dielectric properties depend on several aspects including crystalline size, grain size, density or porosity, impurities in material. The larger crystalline size and grain size will result in a higher dielectric constant because they give more space for dipole to move. The conclusion, the crystal structure showed irregular values with increasing neodymium concentration, but neodymium revealed a significant effect of structure. The sample demonstrated the highest dielectric constant about 906, whereas in the pure barium titanate. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Okay, next presenter. Please welcome Ms. Janita Halim from Institut Teknologi 10 November, who will be speaking to us on material and electrochemical characteristic of carbon coat platina chromium cobalt alloy, nitrogen doped carbon for proton exchange membrane fuel cell catalyst. And here is a video presentation that you can watch.
Good morning. It's an honor for me to present what we have been working on today. But first of all, my name is Janita Halim, and I'm an ICTA student. I'm from Department of Material and Metallurgical Engineering. So without any further ado, let's get started. The title of my presentation today is Material and Electrochemical Characteristics of Carbon-Coated PTC-RCO Alloy Nitrogen Doped Carbon for Proton Exchange Membrane Fuel Cell Catalyst. We go to next page. Research background. Lately, we often see on the news that many countries are starting to have an energy crisis. That was pretty sad, but the most important question is how long will we continue rely on fossil energy? How long? Fossil energy, we know that very limited right now, and we know that fossil energy produce carbon emission that increase the temperature of the earth. That could be dangerous if we don't stop it right now. And I think this time is the perfect time for all of us to switch from the conventional energy to renewable energy. Renewable energy in this case, I mean, is PEM fuel cell, of course. And PEM fuel cells, we know that PEMFC produce zero pollution. And PEMFC is all PEMFC need is only water. In Indonesia, 2 per 3 of Indonesia territory is water. So this is, we think this is such a big advantage for us, for all of us. Let me explain how PEM fuel cell works. So this one is anode side and this one is cathode side. Hydrogen entry to anode side, then split into H plus and electrons. H plus transfer through the membrane. The yellow one is the membrane through the cathode side, while the electrons go through the circuit. H2 will be reacted with O2 oxygen. Oxygen will be reduced, and the reduced oxygen will be reacted with H plus itself. Then it becomes the H2 as the output gas. Yeah, H2O. H2O as the output gas. And the PTC. This one is PTC. PTC is the conventional catalyst for PEM fuel cell. Yeah, commercial catalyst. PTC also still have several shortcomings, but here we are with the solution. In this case, we use activated carbon. Why activated carbon? Because activated carbon is cheaper than CNT. Generally, PEMFC use CNT, but CNT is very expensive, so we use activated carbon or AC as the alternative. And AC has big surface area, but also at the same time, AC has low conductivity. So that's why we need PANI. PANI is polyaniline. Yeah, polyaniline. Polyaniline that can increase the conductivity of AC itself. So AC, the first layer is PANI, and the second layer is PTCRCO, which is the catalyst we use in here, and the third is PANI again. Why we choose PTCRCO as catalyst? Because we want to make a cheaper PEM fuel cell, but also at the same time we want to make a high durability and high performance fuel cell. Formulation of the problem. How does the addition of activated carbon doping PANI affect the morphology of the AC PANI PTCRCO PANI catalyst? How does the addition of activated carbon doping polyaniline affect the electrochemical performance of the AC PANI PTCRCO PANI catalyst? Research purposes: analyzing the effect of the addition of activated carbon doping polyaniline on the morphology of the AC PANI PTCRCO PANI catalyst. The second is analyzing the effect of the addition of activated carbon doping polyaniline on the electrochemical performance of the AC PANI PTCRCO PANI catalyst. Literature review, PEMFC, of course, yeah. In the anode side, there is chemical reaction where 2H2 become 4H plus and 4 electrons. In the cathode side, O2 or oxygen and 4H plus and 4 electrons become to H2O. And this picture illustrates a single cell. From outside to inside, a single cell need to contain all of this. So single cell is contained from membrane, catalyst, gas diffusion layer, gasket, the power plate, and it becomes one stack like this picture when the single cell put together. It will be like this. Next, catalyst. What I want to say in this page is PT and PT is the most promising cathode catalyst so far. Yeah. So far, right. For the PEM fuel cell, the most promising. That's why we still use PT for the catalyst. Activated carbon, doping nitrogen. Activated carbon, we can see have big pores, and we hope that doping nitrogen from the polyaniline can fill the pores. That the catalyst can ride on the top of the activated carbon itself. Previous research, you can see in this table, research method. Okay, I forgot. Previous research, we focus on the last two table, PTCOC and PTCRC. Obtain power density 0.27 and 0.284 from this reference. That's why the reason why we want to combine the CR and CO to get the maximum result. Okay, we go to research method. This one is carbon activation flow diagrams. Yeah, I don't need to explain, but yeah, this is the flow diagrams. And this is for the catalyst synthesis flow diagrams. So the carbon must be activated first. Then we synthesize the catalyst PT, CR, and CO. Test plan, we do several tests. AC and AC PANI, we do same thing. PET, SEM, XRD, FTR, FTIR. Well, AC PANI, PTCR, CO PANI, or the final product is SEM, XRD, CV, LSV. Yes. Don't need PET or FTR. Carbon characteristics, XR.
Okay, time's up. And please welcome Ms. Nufia Ilamuti Aturaifa from Universitas Negeri Malang, will be speaking to us on effect of electrolyte type on supercapacitor batteries based on silicon as anode and cassava activated carbon as cathode. And here is a video presentation that you can watch.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nufia Ilamuti-Aturaifa. I'm from State University of Malang. In here, I will to present about my research. The title is Effect of Electrolyte Type on Supercapacitor based on silicon as anode and cassava activated carbon as cathode. Introduction. Battery and supercapacitor are examples of energy storage devices that are widely used. Battery and supercapacitor have advantages and disadvantages. Advantages of battery is high energy density and disadvantages is low power density. Supercapacitor have advantages are high power density and long cycle life, and disadvantages is low energy density. Supercapacitor combining this component of porous supercapacitor material and battery material overcome the respectively weakness of battery and supercapacitor to improve electrochemical performance. This is the component of supercapacitor, and electrolyte believed to be a component other than electrode that play a role in donating the ideal performance of a supercar battery cell. Two types of electrolyte are often used: organic and aqueous. In some previous research, we get cassava have a highest electrochemical performance with a specific capacitance 300 farad per gram in 5,000 cycle and with a 6 molar potassium hydroxide electrolyte. In this research, the manufacture of supercar battery is composed of activated carbon from cassava tuber as cathode and silicon as the anode to improve electrochemical performance. The use of silicon for the anode of supercar battery is because silicon has a long operating voltage, environmentally friendly, and readily available in nature. And then for method, synthesis of cassava tuber activated carbon, first we grinding and drying, and then pre-carbonation and activation with 3 molar potassium hydroxide and stirrer 47 24 24 hours, and then oven carbonation with a furnace with 600 degrees Celsius, and then sample ready to characterization. And for fabrication cassava tuber activated carbon, we use NMP for the solvent, and we mix PVDF and NMP in 60 degrees Celsius for 1 hour. And then for fabrication silicon electrode, we use the emassive formed solvent, and the ratio used for active carbon, burn black, and binder we use 811. And then for fabrication coin cell supercar battery, we shocking the electrode in variation electrolyte. In here we use 6 molar potassium hydroxide and 1 molar 84 NPH4 for 24 hours. And this is how to arrange coin cell. For result and discussion, XRD analyzed. This is a graph of diffraction pattern from activated carbon commercial and activated carbon cassava with activation 3 molar potassium hydroxide and 2 diffraction peak from indicated amorphous bus. And the diffraction pattern, we get good effective electrode material. That because a KOH activation activator affect the intensity of the peak. The peak intensity influence from the cellulose content that form a hexagonal structure. And this is the graph of a diffraction pattern silicon powder according to the standard silicon GGBTS. And from every peak, we use highest intensity. We get highest intensity in 2 theta to 28.4 degree. And the size of the silicon powder is nanoparticle. The performance, the formation of chemical bond on nanoparticle is such a way accelerate the transfer of electron in electrochemical process. And Sam analyzed this is the image from activated carbon to a cassava tuber, and we get a particle size distribution 8.87 micrometer, average power per diameter is 0.988, micrometer and porosity percentage 69.49%. KOH activation can remove impurity on the carbon surface and increase the pore size, the transmission of ion, and are an effective reservoir for the electrolyte. Percentage of porosity is the number of pore affect the amount of chain storage, and this is the image from silicon powder, and the space is spherical. The particle size distribution of silicon powder is 0.065 micrometer. The smaller particle size is used to avoid cracking and crumbling when applied as an electrode to avoid the trace capacitance. And this is the FTIR analyzed. The FTIR absorption peak produced by activated carbon commercial is smaller than activated carbon cassava tuber. This is influenced by the activation temperature. And this is the electrochemical performance. We get a graph time versus voltage from charge discharge galvanometer test. In here we get the stationary peak, and this condition is indicated by the presence of solvent. The composition cell voltage caused by the type of electrolyte used. The use of 6 molar potassium hydroxide electrolyte results in better electrochemical performance when compared to 1 molar ET4 and BF4 electrolyte. Better electrochemical performance when using a 6 molar potassium hydroxide electrolyte is in symmetric supercapacitor. 6 molar potassium hydroxide electrolyte is a aqueous electrolyte that uses water and a solvent to allow for the discovery of a salt, which organic electrolyte cannot produce. Using 6 molar KOH electrolyte was increased in supercapacitor based on cassava tuber activated carbon as cathode and silicon as an anode. Conclusion: cassava tuber activated carbon has been successfully synthesized using the chemical activation. Silicon electrode has also been successfully application in as negative electron for supercapacitor. Exactly diffraction patterns of cassava tuber activated carbon has almost the same of chemical activated carbon, and silicon powder have a crystalline structure. The absorption pattern of a test result on activated carbon has more amount than chemical activated carbon. And the
Okay, time's up. Now moving to question and answer session. You could use chat or raise hand feature, which is available in Zoom if you want to ask a question. For the first session, I will open to question. Okay, first question from Mr. Cornelius to Ms. Nuvia. How to handle the reaction between silicon with calcium hydroxide? Please, Ms. Nuvia, to answer the question.
I want to answer how to handle the reaction between Se with KOH. KOH in here to the electrolyte, and the electrolyte can to faster the transfer of electron in site SE, like that.
Okay, that's enough, Mr. Cornell. Okay, next question from Ms. Adesianti to Ms. Nuvia. I want to asking a question. In this research, why are you choosing calcium hydroxide and the electrolyte as electrolyte? Okay, please, Ms. Nuvia, to answer the question.
Okay, in my research, I choose potassium hydroxide and AT4 and BF4 because from literature to type of electrolyte is many to use, and in potassium hydroxide have a very high ionic conductivity and to the high mobility of oxygen hydroxide anion in water solution and have very low size, and that can increase the uh, specific capacitance. And why I choose the ET4 and BF4 because that have a good conductivity and can improve the specific capacitance, like that.
Okay, Ms. Ade, is that enough? Okay, thank you. Is there any question? Okay, time's up. Now moving to the next speaker. Please welcome Mr. Bukhari Muslim from Universitas 11 Maret, who will be speaking to us on supply chain network design model for technology feasibility of renewable waste treatment, a case study, and here is a video presentation that you can watch.
Assalamualaikum warahmatullahi wabarakatuh. Thanks for this opportunity. I want to present my research about supply chain network design model for technology feasibility of renewable waste treatment, a case study. Okay. Table of content is research. The first, introduction. Second, material and method. Third, result and discussion. Fourth, conclusion. The total waste in Indonesia at 2021 is 41.6 million ton per year. And then the distance between the Jakanan sub-district and the landfill end or TPA is around 23 kilometers. And long transportation affect the big fuel and high carbon emission. And then high cost and require a larger area to build a landfill. The Kapal Selam of pure reactor (PKS) is processed at the location closest to the source of the waste, so that less vehicle fuel is released and fewer carbon emission are released. To further optimize the development of PKS facilities, need the SCND. SCND PKS in Jakanan consists of three entities, namely the first suppliers, household and market waste, and two manufacturer. This is Kapal Selam of pure reactor and distribution center for solid and liquid organic fertilizer. This research is expected to produce a SCND development model for the construction of the Kapal Selam of pure reactor facility, namely by determining the first, number of pure reactor per, second, location of PKS, and the third, the amount of carbon sent by supplier to PKS. Then material and method. The material, the facilities and infrastructure needed in this research are as follows. First, internet access subscription to Scopus Index Journal, and second, literature book, and third, computer for model computing process, and fourth, IBM Alloc Ziplex software for simulation model development. This is the research method flowchart. From the start, and then study object literature review, and then formulation of the problem, and then determination of research techno-economic analysis. It's not the feasible. This is design again, supply chain network design again. After the feasible, is continue establishing a supply chain network, and this is the research object relevant system. This is namely the three entities. The first, supplier from domestic waste and market trace, and second, manufacturing. This is the CV Teloko Farm, Kapal Selam pure reactor. The third, distribution center from solid organic fertilizer and liquid organic fertilizer. At SCND, the methods first, mixed integral linear programming (MELP) used to formulate the capacity location allocation applied to solve the problem. The second, load distance methods, how to choose the optimal location taking into account the distance. The smallest load value will be chosen as the location for the BKS facility, which on 2013. Mathematical formulation. The objective function of this paper is to maximize the profit of opening a BKS facility, and use ILOC Ziplex. Use to solve mathematical formulation. Stopo et al. 2016. This is the influence diagram. The goal research is profit maximization. The profit maximization influence from total income and total cost. Total income influence from supplier total revenue and PKS total revenue. And total cost from total cost of supplier society (PKS) and total cost of PKS. This is objective function, profit maximization. This is from total revenue supplier plus and total revenue from data type PKS capacity. PKS capacity result of 15,000 kilogram per day. In Jakarta district population in the 2022, the 15,341 people. Number of market in Jakarta district, the 3 markets. And price of solid organic fertilizer 800 IDR per kilogram. Liquid organic fertilizer price 13,000 IDR per kilogram. The gas price and 7,000 IDR per kilogram. This is the example calculate to calculate the waste potential. From this calculation, the total potential 18,317 kilogram per day. And then the determination of the location of PKS facility. This is use the load distance methods. After calculate the smallest LD value or load distance methods value, the first one location with 2 facility. The location of the selected PKS is Sembaturagung village. The second, 2 location with 1 facility X selected the Puluhan Tengah and Tulungarejo. After the random model on iLoxiplex, the output model Sembaturagung PKS facilities result 0, the decision not opened. Then Puluhan Tengah PKS facility, the result 1, decision opened. Facilities of PKS Tulungarejo, the result 0, decision not opened. This is the CPLEC processing result. The maximizing profit 4.4 billion IDR. This is the garbage sale, fertilizer sales, gas sale, waste raw material cost, PKS investment fee, PKS fixed fee, and transportation cost. On supplier to the Puluhan Tengah PKS in Puluhan Tengah. Then the number of product in each PKS kilogram per year. This is solid fertilizer to Puluhan Tengah 3.9 million. And then liquid fertilizer
Okay, time's up. Next, please welcome Mr. Eric Danianto from Institute Technologies Blue November, who will be speaking to us on electrochemical performance of nitrogen-doped carbon, MnO2 composite supercapacitor electrode in aqueous electrolyte. And here's a video presentation that you can watch.
Good afternoon, everyone. My name is Eric Danianto
University.
And my partner Demas Muhammad Abian. We are from Material and Metallurgical Institute Technologies Blue November. Here, we would like to presentation our paper with title Electrochemical Performance of Nitrogen-doped Carbon with Magnesium Oxide as Composite Supercapacitor Electrode in Aqueous Electrolyte. Here, the author, Mr. Demas Muhammad Abian, Mr. Sutarsis, Mr. Agung Kurniawan, Mr. Yusuf Radesar, Mr. Eric Danianto at the Second International Conference on Energy Storage Technology and Application, ICESTA 2022. Here the outline of our presentation: the first, introduction; the second, literature review; the third, methodology; the fourth, result and discussion; the last is summary. Introduction. One of the world concerns today is need for electrical energy associated with vehicles that sell electricity. This is to support global commitment in reduce greenhouse gas emission. It is projected by Ministry of Industry that there will be 38,000 electric vehicles in 2024. With the growth and demand, electricity vehicle has an impact on increasing electricity consumption, which is estimated to reach 2,000 kilowatt-hour in 2025, according to Badan Pusat Statistik. The electric vehicle itself has several types of energy storage, and the main one is the battery. The battery has the characteristic with high energy density but low power density. This effect have decreased the speed of charging discharging the battery, cause to decrease acceleration of electric vehicle, and have problematic in uphill condition. Another energy storage that can be used is a supercapacitor, which has a high power density but a lower energy density compared to the batteries. In addition, supercapacitor has another advantage like long cycle life, high efficiency, and can be considered friendly to environment. However, the relative low energy density from supercapacitor is still an obstacle, so that it effort to increase energy density. Here, research purpose of our paper. The first one is analyzing the effect of adding nitrogen as a dopant to the structure and morphology of the nitrogen activated carbon with magnesium oxide, the supercapacitor. The second is analyzing the effect of adding nitrogen as a dopant on performance supercapacitor. Here's the literature review of our paper. The first one is how to get activated carbon. Here from the pyrolysis method. The pyrolysis method gives our pyrolysis char. From the pyrolysis char is added by potassium hydroxide to increase its surface area and porosity. And then magnesium oxide. Magnesium oxide as metal oxide become a reaction addition again that can be increased capacitance. Addition of pseudo-capacitance properties from supercapacitor. And then there is a polyaniline. Atomic radius from atom nitrogen are similar to atom carbon. This process of substitution nitrogen atom on carbon means that some of the carbon atom in a unit cell are replaced by the other atom nitrogen and having an almost same of radius with substitution from the atom.
Okay, thank you, Eric. Now we go to methodology. For the methodology, we use a pyrolysis process for activating carbon. So the carbon from coconut shell that we got, we impregnated with potassium hydroxide and polyaniline for the nitrogen precursor. For the composition ratio, you can see here for NaC1, NaC2, and NaC3. After that, we mix it with MnO2. MnO2 that we got and process it with hydrothermal and annealing process. And then for the composition ratio is 5 for activated carbon, nitrogen activated carbon I mean, and then compared to 1 with MnO. After that, we make it slurry with PVDF and carbon black. For the nitrogen activated carbon and MnO2 is 8 compared to 1 with PVDF, compared to 1 with carbon black. After that, with 8 NMP, and we coat it in nickel foam with 1 × 1 square centimeter of coating.
After that, we dry it in vacuum oven. And then for the testing or electrochemical performance testing here, for the powder of mixed NaC1 MnO2, we test it with scanning electron microscope and XRD. And then for the nickel foam that we got before, we use 3-electrode cyclic photometry for the electrochemical performance. Then for the result, we can see here the XRD result that from the activated carbon here to nitrogen activated carbon composition 3, we can see that the peak of carbon is shifted to right. It means that the carbon, nitrogen in the carbon is succeed to dope to activate carbon. And then you can see for the crystal size here. Then after that, after we mix it with MnO, we test with XRD2. Then we can see the MnO phase here. That MnO that we got is beta MnO2, and then we got Mn3O4 for the NaC3 MnO. And you can see the crystal size of the MnO here. This is Mn3O4, and then MnO2 beta phase. And then we test it with scanning electron microscope. For the scanning electron microscope, we magnify it with 5,000 and then 15,000. For 5,000, it can be seen in structure of NiC1 beta MnO2 uniform, which has a nanoroot shape, with size of 600 till 800 nanometer. Whereas in NaC2 and NaC3 here, Mn3O4 is morphology similar to beta MnO2 but with a different size. As you can see here that beta MnO2 has smaller size compared to Mn3O4, which is for Mn3O4 is around 500 nanometer. You can see the compared here that 15,000 magnification of NaC1 MnO compared to 5,000 NaC3 or NaC2 MnO. It's a little, it's a big difference between Mn3O4 and beta MnO2. And then for the cyclic photometry, from cyclic photometry, we can count the specific capacitance, and then we got for with electrolyte Na2SO4 that the specific capacitance, the biggest specific capacitance that we got is for NaC3MnO, which is the composition, the biggest composition of polyaniline. And then it's the same for NaC3MnO.
Okay, thanks up. Next to the next speaker, please welcome Mr. Fendi Aji Purnomo from Universitas 11 Maret. Will be speaking to us on implementation, VGS, and Laravel on monitoring battery management system. Mr. Fendi will speaking directly.
Yes, thank you. Can I share my presentation?
Okay.
Thank you very much. In the research, title is Implementation QGS and Laravel on Monitoring Battery Management System. And the author is Dewi Maharani, Grafilian, Rika Akila, Sugeng Sulistiawan, and also my name is Pendi Acipurnomo, and Miss Windu, and also Professor Agus Purwanto. Next, please. For introduction, rechargeable battery, such as lithium-ion battery, are used in the majority of renewable energy system. And battery management system is a system that is beneficial for monitoring battery because batteries have their own properties. A battery that is arranged in a series or parallel can be balanced, monitored, and protected with the help of battery management system. A current sensor, voltage sensor, and temperature sensor, and a protective circuit that is important for taking current are all included in the battery management system. So we require a system that can be used by administrator and user of battery management system to provide information on battery state. Next, please. For the method, we use a agile method in the development approach employment. Agile methods are applied in an equitable and structured and strategic way with the cooperation of many stakeholders. So this method involves the job to be completed quickly and creatively. Because it is an adaptive and flexible development methodology, the agile technique was selected. We use requirement and the software requirement. It is a web server, database server. We use MySQL, and also we use framework Laravel and Vue.js for web-based and mobile responsive view, and we also to use a PHP and JavaScript, and for testing the application we use a Postman, and for running system we use a command prompt. Next, please. The topology system, this is a PMS module and connect to ESP and have server power module with sensor. We must have a sensor to detection of temperature in PMS. For the ESP module, we send via Wi-Fi and send to the server the data from ESP. We record on the server and we develop the application for monitoring PMS module. Next, please. For result and discussion in admin thesis process, the administration have 4 dashboards. There are manage monitoring, manage user device information, manage PMS information, and manage user information. Next, please. And for the user business process, the user have a dashboard and they can view and monitoring about the PMS temperature. PMS with the user access after logging contain a graph depicting the state of the PMS at the moment. Battery, as you see, voltage, temperature, current, and total voltage are all maintained along with all the data. and the user will then be aware of what needs to be done to keep their PMS running smooth. Next, please. For the admin and user dashboard, we develop the graphic and can monitoring the value of full text, and the administrator can see the monitoring text, which provide detail of the battery condition. The monitoring page also notice and the administrator if there is a PMS anomaly. For a user device page is also present, and the user device page include tool for adding, edit, and deleting data regarding the user PMS. Next, please. For the notification page dashboard, the user can view data on the state of his PMS in real time and over the specified period of time on the monitoring page. The user may be aware if an anomaly happens. Next, please. In the website-based battery management system, the author we conducted tests using the black box method because the black box testing method is the test that look at the execution result from test data and ensure the functionality of the software. For the black box testing, in the tabel, you can see many activity, and there are login and logout, manage user information, manage PMS information, manage cell information, manage set information, manage user device, and manage monitoring information, and the result is success for black box testing. Next, please. For the conclusion, the battery management system information system that has been designed and with procedure information in the form of graphic and notification. And the information is contained in the form of temperature. There is temperature on sensor 1, temperature on sensor 2, and temperature on sensor 3. And the maximum temperature limit. Voltage, maximum voltage, total voltage, and minimum voltage limit. And for current, there is maximum current limit, current total, and minimum current limit. Next. Thank you very much for your attention.
Okay, thank you, Mr. Fendi Aji Purnomo. Next to the question and answer session, you could use chat or raise-hand feature, which is available in Zoom if you want to ask a question. Is there any question for the presenters? Okay, is there any question for the speakers? Maybe that's enough. Thank you very much for all speakers for addressing today's interesting topic. On behalf of Center for Excellence for Ethical and Digital Technology, Universitas 11 Maret, we would like to thank you for joining us today.
Thank you.
Masuk ai. Opo? Infone Mas.
dalam berbagai platform yang dapat dinikmati dengan mudah dan murah serta dapat
Recording stopped. Recording in progress.
Check one. Check one. Cek 1, 2, 3. Cek 1, 2, 3. Cek 1, 2, 3. Cek 1, cek 2. Sound check 1, 2, dan 3. Check 1, 2, and 3. Check 1. Berarti aku lihat. All right, ladies and gentlemen, welcome back to the second International Conference on Energy Storage Technology and Application, ICESTA 2022. Well, dear participants and ladies and gentlemen, I believe after the lunch break, now you are full of energy to join the second plenary session, as we're going to have Professor Dr. Ramesh T. Subramaniam from University Malaya, Malaysia. So ladies and gentlemen, be prepared, and to ensure the session runs smoothly, I'd like to introduce you all to our dear moderator, Bapak Muhammad Iqbal Al-Fuadi, ST Master of Engineering. So Bapak Muhammad Iqbal, he got his master's degree in chemical engineering from Universitas Gadjah Mada and his bachelor's degree from Universitas 11 Maret. His research interests are on electrochemical characteristic of supercapacitor, which shows positive potentials in providing high specific capacitance, long cycle life, and fast charging times. So ladies and gentlemen, I present to you Bapak Muhammad Iqbal Al-Fuadi as our moderator for the second plenary session. Okay, please have a seat, sir. All right, Mr. Muhammad Iqbal Al-Fuadi, now the time is yours.
Okay, thank you very much, Mr. Arbet, to the nice introduction. Okay, good afternoon, ladies and gentlemen. Today we will come to the plenary session of the number 2. So my name is Muhammad Iqbal Al-Fuadi. I will be the moderator for this second plenary session. Today in this session, we have a keynote from Malaysia. His name is Professor Dr. Ramesh Subramaniam from Department of Physics, Faculty of Science, University of Malaya, Kuala Lumpur, Malaysia. Hello, good afternoon, Professor Ramesh. Can you hear my voice here?
Hi, I can hear.
Okay. Okay, before we start this plenary session, I would like to read his CV. So, Professor Dr. Ramesh is a senior professor in the Department of Physical, Faculty of Science, University of Malaya, Malaysia. He graduated his PhD in University of Malaya on 2004. He was invited as a nominator for the Nobel Prize in Physics for 2021. He also get the rank of number 6 world under the research title about electrochemical devices. He wrote many publications in journals, more than 300 journals, and his professional appointment from 2005 until 2022. He got a lot of research of award and recognition from 2018 to 2022. Okay, now the rule is in this presentation is around 30 minutes, and for the question and answer it will take around 15 minutes. So I would like to invite our keynote speaker, Mr. Professor Dr. Ramesh, to present his topic. So welcome, Professor Ramesh. The place and times are yours, Professor.
Okay, thank you very much. So saya ingin mengucapkan terima kasih kepada Hanif Jamaluddin for inviting me for this plenary session. So let me share my slides first. Can you see the slides?
Yes, yes.
Okay. Thank you. Okay, I'm Ramesh T. Subramaniam from University Malaya. So today in my plenary session, I'm going to talk about hydrogel electrolytes in electrochemical devices towards sustainable smart cities. So you can see from the talk there are three main important things. One is about the electrolyte, one is about the devices, and then the third one is where can we use these things. Okay, before I start my presentation, let me introduce my university for few minutes. University Malaya is actually started in 1905 as a King Edward College of Medicine, Singapore. Then once Singapore and Malaysia become like two different countries, so University Malaya and National University of Singapore are actually together. So you can see from here that University Malaya have a very long history. And then these are the UM profile. So we have like 14 faculties, 2 academics and 2 centers. And we also got like 4 research clusters, many research centers and many academic programs. And the enrollment you can see there are many international students and also international staffs are placed in University Malaya. And our enrollment for the students undergraduate, you can see approximately like 20,000. With the postgraduates about like 9,000. And here are some of the flag bearer of Malaysia. So under the QS World University Ranking, UM ranked 65th. And under the Asia ranking is a 9th. And also the ranking and the green metric all like highly ranked. So here is a field-weighted citation impact of the journals published by University Malaya. So you can see one of the field like energy. So UM is doing comparatively extremely well if compared to the world citation impact of the journals in this particular category. Okay, this is a campus of the University Malaya. So you can see the campus is in the middle of what you call like the capital city, Kuala Lumpur, and you can see this is a city and this is a campus, and it's a very green campus. You got a very beautiful lake as well, and this is where the Faculty of Science is located. So I invite you all to visit University Malaya so that you can experience a new type of what you call like environment. Okay, what is the motivation for our work? As we know, 2019 Nobel Prize in Chemistry was given for the development of lithium-ion batteries. So then there will be predictions for the next next decade. So the things that we are going to focus is autonomous vehicles will hit the fast lane, green machines will rule the road, and renewable energy will power the world. So these are the 3 main, what you call like prediction for the next decade, which are our interest, because these are the things that are related to our ongoing research. Okay, if you look at the, what you call like the first one, the autonomous vehicles will hit the fast lane. So we can see in 2030, we will have a broadly deployed fleets of autonomous electric vehicles operating in cities throughout the world. So when the number of electric vehicles become higher, so we need to really focus how are we going to integrate our research with this kind of changes in the landscape. Then also green machines will rule the world. So the global electric vehicle sales are expected to rise 28% a year over the next decade. And even Volvo promised to only produce EVs by 2030. So there is a huge market in electric vehicles. And also, some European governments have set high decarbonization targets. So in other words, sustainable cities and green cities are interest of many. Okay, here you can see the difference between a sustainable city and not a sustainable city. So obviously people would like to stay in a place where it's really arranged and organized properly. So when we talk about sustainable smart cities, cities with parks, green spaces, solar powered buildings, and rooftop gardens. And also good quality of life, space for nature, and eco-friendly public transit and transport system, plus with the solar energy usage. So here you can see how our smart cities related to our work. So there are three important focus dimensions you can see here in terms of economic, social, and environment. So all these need to be interconnected. So our target will be environmental and economic aspect of smart sustainable cities to reduce air pollution and carbon dioxide emission and create job opportunities. So here you can see the drivers promote the investment in energy storage. So there are three reasons why the funding agency and the researchers are focusing more on the energy storage. One is because increase in electricity bill, and then growing dependence on fossil fuel. We want to come away from that. And also the focus will be the decarbonization. Okay, if you look at the table there, the graph there, we can see the batteries generally show high energy density but low power density. Whereas supercapacitors shows high power density and low energy density. So there is a huge gap between batteries and supercapacitors. So to bridge this gap, we are proposing a new kind of a device called as supercapacitor. Okay, you can see it bridges the gap. And Malaysia's carbon dioxide emission in 2020 increased compared to year 2000, nearly at 69%. And main contributor for this is the transport industry. And how can we contribute to reduce the carbon dioxide emission? If you look currently, most of the electric vehicles are powered by lithium-ion battery technology. But the problem here is the current EVs take 4 hours to fully charge. When they take longer time to charge, then we need to look for some alternatives. And we are also focusing on the energy harvesting devices. When we say energy harvesting devices, it depends on the solar cell. Solar cell have got many types. The solar cells that we are focusing are dye-sensitive solar cells. And we are also doing some research on integrating solar cell together with the energy storing devices. So we have a few grants on this as well. And Malaysian National Automotive Policy. So one of the trusts is to produce energy efficient vehicles. And one of the objectives is to reduce carbon emission in line with the ASEAN equivalent to 100 kilometers by 2025. So the current list of technology development under this national automotive policy is development of advanced electrode and electrolytes for lithium-ion battery charge. So that is where we are working very strongly to produce new type of electrode and electrolyte for this new technology. So the market and the opportunities are really wide. And also to produce next generation battery technology. When we say next generation battery technology means what are the other mean of electrochemical devices that we can produce besides battery technology. Okay, how is this device related to the policy? One, it supports the electrification of vehicles in Malaysia. And also we can produce supercapacitor that have longer lifetime and also longer drive distance. So you see two things there. We produce supercapacitor that would have a longer lifetime and longer drive distance. So these are the two important things. And to produce novel electrode and electrolyte to fabricate supercapacitor. Okay, now the new growth opportunities and innovation driving the e-mobility industry. So you can look at the impact of COVID-19 on EVs as well. So due to this, new lifestyle changes of work from home and travel or shop capacitors store high amount of energy, but lithium-ion batteries will take long time to be fully charged. So these overcome the challenges. How can we overcome? We can do like the cross-linking, blending, copolymerization, or incorporation of additives. So all these are the possibilities that we can use to overcome the drawback of the solid polymer electrodes due to the lower ionic conductivity. So here is the evaluation of polymer electrodes. The first generation you can see they are salt-based polymer electrodes. Then they use of plasticizers as a main additive. But the problem started when these plasticizers make the electrolyte become very flexible, so difficult to handle. So that's where the nanocomposite, which is the third generation, was produced. So this third generation, by using nanoparticles, the mechanical strength of the electrolytes can be enhanced. At the same time, the aging properties, where they can retain the high ionic conductivity, also has been improved. In progressive year, radiation and other techniques are used to improve the ionic conductivity. Okay, these are new materials I'm introducing here, the hydrogel electrolytes. I do welcome many of you to come and work with us on these projects because it's really interesting. Where hydrogels are three-dimensional hydrophilic polymer network. And the beauty of these hydrogels are they can be made by physical or chemical. So physical hydrogels we can do like ionic cross-linking, whereas like a chemical hydrogel done by using the cross-linking agents. So here are some of the examples of the hydrogels. So in other words, like a polyvinyl alcohol, it can be made as a electrolyte. But by manipulating or by changing the process method, we can change that same polyvinyl alcohol to become as a hydrogel. So for example, if you are using physical cross-linking, you have to use like a free-solving and create a hydrogen bonding. Whereas chemical cross-linking, we can use by adding like a glutamate and also borax. So these are the possibilities. So here are more examples: hydrosan, cellulose, guar gum, carrageenan, pectin, and so on. Okay, next, why hydrogel as electrolyte? Okay, you can see they are highly flexible, self-healable, hydrophilic, thermally stable, compressible, and also stretchable. So all these are the possibilities. Okay, here you can look at the mechanical properties of hydrogel of acrylic acid. So you can see here, okay, how nicely we can stretch them, then how to twist them, and you can also do the bending, and you also can do the knotting. So all these are the possibilities. And here we also can see the mechanical property of hydrogel, where they are very sticky and also highly adhesive properties. So when we do this kind of materials, then the contact problem between the electrode and electrolyte can be avoided. They will stick very well to the surface of the electrode materials. Okay, here a very short video you can see how we can handle or how flexible the hydrogels are. Okay, you can see how sticky are they. Okay, then we can highly stretchable. We can do any type of changes. So by doing this kind of electrolyte can be used for any flexible applications. Okay, like a wearable electronics and all these things. Okay, you can see. So these are highly conducting electrolyte. Okay, here you can see the conductive hydrogel network provides continuous electron conduction pathways. So by doing this, we can have a good ionic conductivity. The other beautiful properties that hydrogels exist is self-healing properties. When we say self-healing properties, just say for example, accidentally there is some breakage or some cut. So normally what happens, the performance will drop. But in hydrogel, even if they are broken, they can actually can be connected and they can grow together because of the networking structure. So they got the automatic self-healing properties which can regenerate or can make the device to work again. Okay, the other new materials that we are using as a hydrogel electrolyte is our natural resources called as a natural rubber. So we are using natural rubber as our main source and to create them as a hydrogen electrolyte to be used as an electrolyte. And not many natural rubber are used. Normally natural rubber is used as an electrolyte where the performance are very poor. But by changing them as an electrolyte or as a hydrogel, we can produce many different type of applications. The other materials which I also wanted to introduce here is the magazine. Magazines are flexible, 2D layered porous hydrophilic materials with high electronegative terminated group as electrode materials. So you can look here, MEX. So MEX means that the M stand for the metal and A stand for the elements within the green boxes there, and the X will be either carbide or nitride. So this is a new type of electrode materials. And this magazine, we are synthesizing many different types of magazine in our lab to be used as an electrode materials. Okay, here you can see the natural rubber and also the magazine, how it can be prepared. And this is a prototype that we prepared, and also you can see the devices. And now, I already showed you about the electrolyte, and I will also show you about the electrode. So now, here is a super capillary. Okay, when we talk about the super capillary, you can see here, we have a binder-free battery-type electrodes and capacitive electrodes. So one side will be battery-type electrodes and the other side will be the capacitive type of electrodes. So it will be more like an asymmetrical device. So by using this kind of devices, we can get the positive properties of both batteries and super capacitors. And recently, we also come up with the all-in-one configuration. So when we say all-in-one configuration means, we do the electrode and electrolyte together and there is no separator. So without separator, it also can reduce the dead weight of the devices. So how to produce the all-in-one configurations? So this is a method. So for example, we use like a polymer electrolytes. This electrolyte, and make them as a solution, and then make them as a fluid. After we make them as a fluid, we soak in sulfuric acid and add glutaraldehyde, and then this becomes as a hydrogel electrolytes. So once they become as a hydrogel electrolyte, we add aniline and pyrrole, and these things will polymerize and make a layer of the electrode materials. So that means the electrolyte and electrode are really embedded together, and this will produce a very nice, what you call like a film, which comprises of both electrolyte and electrodes. So by using this, we need to use a separator. This is one of our new invention. So this is an example, sample how it look like. Okay, you can see how nicely the all-in-one configuration can be made. Okay, next we go for methodology. When we talk about methodology, some of the experiments I just want to share with you some results. So you can see the synthesis of polyacrylamide hydrogel, how we prepared, and then you can see the lithium sulfate are added as an ion because all these materials are lithium ion conductors. So this is a sample. How flexible hydrogen electrolytes you can get it. Okay, we do many characterization. Some of the results I can share with you here. Okay, these are mechanisms, how the interaction occurs, and this interaction can be proved by using like the FTI analysis, where the change in peak and also the intensity, and then what I call like all these properties shows there is a good interaction between the reactors. And then here you can see like lithium sulfate are pure crystalline salt, but there is no peak appeared in hydrogen electrolytes because of the complete dissociation of the salt in hydrogen electrolyte matrix. So it shows that the lithium salt that we added are conveniently embedded or complexed with the hydrogen electrolytes. And you also can see the TGA graphs where there is a weight loss occurs at different point. So then we know at what temperature these materials can be applied. But initial weight loss generally due to the water. Okay, next the surface morphology you can see here. The FESM shows porous morphology of the hydrogel electrolytes, and this porous morphology is useful for the transportation of ions. And with the addition of salt, the pore size are reduced. Then EDX analysis confirms the presence of acrylamide. So you can see that also. Okay, we have conducted
I'm sorry, Professor. It's still 5 minutes again.
And the highest conducting material shows about 143 farad per gram. Okay, which is a good value when you compare this one. So these are the results of the super capacitors.
Excuse me, Professor.
Yep.
It's still 5 minutes again, so maybe
I will wrap up.
Okay.
I will wrap up. Okay. Then CV results shows also like a similar value, and then like a GCD you can observe also showing about 155 farad per gram. So we can use either GCD or CV to calculate the capacitance of the materials. Okay, another type of materials that we are using is by using PDOT PSS. So these are additives. So by using these additives, the conductivity can be even enhanced further. So here you can see that ionic conductivity is improved. Then we can see the capacitance are improved tremendously. Okay, we got like a 327 farad per gram, almost improved like a 100%. And GCD also shows a similar values. And we also do some derivatives. So by using the acrylamide, we are using some derivatives where we create and synthesize this new type of electrolyte, and similar calculation was made, and you can see FTR results shows a good complexation between the derivatives and the cross-linking agent that we have added. XRD shows a good complexation, and morphology shows highly porous nature of hydrogen. Again, easy transportation of ion towards respective electrodes, which make them highly conductive. And the conductivity also is about 10 to the power of -3 Siemens per centimeter, which is a good value for any kind of applications. But the CV values you can see for the derivatives reduced 102 farad per gram. Okay, for GCD also very similar. So this is a summary of the values that which I showed. So again, the polyacrylamide which is added with the PDOT PSS shows the best specific capacitance values compared to the pure polymer and also the derivatives. So this is the one I mentioned earlier, that we also can integrate the energy storage devices with the solar cells. This integration even a good results. So here are the things that way forward. The last slide for the discussion. Electric hybrid vehicles are better than petrol diesel vehicles in terms of fuel economy, noise and emission. And we also can conclude the manufacturing cost of supercapacitor will be lower than the commercially available supercapacitors and batteries. And supercapacitor can only be used in electric vehicles towards smart, sustainable cities. Okay, last part, I just wanted to share with some of the opportunities and on the panel and also in the committees. So one of the things is a Fulbright. So there are a lot of opportunities in Fulbright. So if any of the academic staff or students in Indonesia, so you prefer to take part in these programs, please contact me, I can guide you. you will have opportunities to work in US department, in the US universities. I'm a Fulbright scholar from the Princeton University. So this is one of the good opportunity I want to share with you all. Second is a Global Young Academy. Every year, 15 September is a deadline to be the Global Young Academy. So by being a member of this Global Academy, these are more towards the young academics who are below 40 years old. You will get many grants, many opportunities to be involved. So I'm also an alumni of the Global Young Academy in the selection panel. So please connect with me if you need any guidance. And the other one is a TWAS. So I'm also a TWAS, what they call like a young affiliate fellow. TWAS is another body you should involve because there are many opportunities there as well. And Indonesia also got some representative under here. So our headquarters is at Beijing, the Chinese Academy of Science. So those who are interested, please communicate with me regarding this opportunity as well. And Erasmus is another nice program. Recently, I got about like 700,000 euro for a project on the sustainable cities and smart cities. Maybe we can work together with this project as well. So there are a lot of opportunities in here under international research and capacity building. Please go through this opportunity as well. And in we also got like an excellent PhD scholarship. So those who are interested, please go to the website and you apply for the PhD scholarship. Then maybe you can come and do PhD in or maybe we can do the hybrid, some part in the Indonesia and some part in Asia. So there are a lot of opportunities there where we can work together to make both of us site, and your institution to be very successful. So with that, if you want to go fast, go alone. If you want to go far, go together. So hopefully we can work together and we go far together as well. So thank you very much for my family, all my teachers, students and collaborators, friends, taxpayers, and not forgetting my brother Anif Jamaluddin for giving me this opportunity to share our work with your group. Thank you again.
Okay, thank you very much, Professor Ramesh. Give applause to Professor Ramesh. Okay, now we move to the question and the answer session. Okay, for the online participant, if you want to ask a question to Professor Ramesh, you can raise your hand in the future or use chat. And for the offline participant, if you want to ask to Professor Ramesh, you can raise your hand and then the committee will give you the microphone. So from the participant, there is any question? One or two questions? Okay, Professor, maybe the first one from me.
Yeah, sure.
Okay, I'm interesting about the supercapacity. It's the first time I hear about this. So in my thesis, I just understand about the supercapacitor and the battery. Whereas the battery have a low energy density and it has a high power density. So what is the supercapacity usually for?
Okay, for example, like if we want like a high power, normally we go for the supercapacitor. But if we say we want like a high energy, normally we go for the batteries. But the problem is when we come to application, people want both high energy and also high power. Like something like one is like a marathon runner, the other one like a 100-meter runner. But obviously people prefer a person to be like he can run 100 meters also very well, and he also want the marathon also to be run very well. So that's why we got the idea to combine these batteries and supercapacitor. So one side we use like a battery type electron, and the other side we use a capacitive type of electrons. By using the two different types of electron and sandwich with the electrolyte, we can get the properties of both supercapacitor as well as the batteries. And it shows what I call like improved power density and also energy density compared to the supercapacitor and batteries alone.
Okay, thank you very much, Professor Ramesh, for the answer. Okay, maybe from the participant, there is one or two questions. Okay, Mr. Cornelius.
Okay, thank you for the opportunity. Hello, good afternoon, Prof. Ramesh. It is a very interesting topic that you bring today. My name is Cornelius. I would like to ask you about your data regarding the gel polymer electrolyte. Yes. How is the stability in terms of the storage and its over potency of the electrolyte? Thank you very much.
Okay, thank you. So when we talk about the stability compared to the polymer electrolyte, the hydrogel polymer electrolyte shows improved what do you call like a stability. So one of the reason is like in my presentation, I even mentioned that these hydrogel electrolytes, the difference between the hydrogel electrolytes and the electrolytes are, for hydrogel electrolytes, we are using like a cross-linking agent. When we use a cross-linking agent during the preparation itself, they already give a very good strong interaction between them. So even I mentioned, when just say we cut the electrolytes become like two pieces and we connect them again, they can, because of this cross-linking agent, they can even connect them together and they can show the properties as well as before we cut them. So in other words, hydrogel polymer electrolytes can show self-healable property. So in terms of stability, hydrogel polymer electrolytes are highly stable compared to the normal polymer electrolytes. So it can be improved.
Is it enough, Mr. Cornelius? Okay. Maybe one more question from the audience. Okay, so because the time is empty, so ladies and gentlemen, finally we come to the end of this session. Again, we would like to say thanks to Professor Ramesh for addressing today's interesting topic. Thank you very much, Professor.
Thank you very much.
Okay. Then also we would like to say thanks for all participants for joining us in the second plenary session today. I think this is enough from me. Thank you very much for your attention. I will give it back to Mr. Albert.
Okay, stay still, Mr. Iqbal. We're going to take a picture on Zoom together with Professor Ramesh. We're going to capture this beautiful moment. You can look at the camera, sir. Okay, everybody, if you're on Zoom, also, I would like you right now to turn on your cam. We're going to take a picture together, a screenshot, okay? In 3, 2, and 1. Captured. Okay, one more time. In 3, 2, and 1. All right. Thank you. Thank you. Okay, ladies and gentlemen, give big round of applause for Bapak Iqbal Al-Fuadi, our dear moderator. Okay, ladies and gentlemen, right now we're going to continue to the next session, which is the parallel session 2. So we're going to start 5 minutes from now. So please choose your room. This room will be room B1, B2, and B3. This room will be room B1, so room B2 and B3 next to this room. Check again your program, ladies and gentlemen, to know the speaker in each room. All right, thank you, and we're going to go back again after the parallel session for award announcement and also closing ceremony. Thank you. Mas minta tolong untuk
Assalamualaikum, Mbak Soraya. Kan belum mulai ya. Nggak. Ini menyapa dulu tamunya. Mari Mas Frengki. Mbak Soraya. Nah, sekaligus ngetes.
Ya, Pak.
Halo. Ya, ditampakin ini dong. Ini teman-temanmu masa lalu pada kangen sama kamu loh. Sombong amat, videonya nggak ditunjukin Soraya ini. Ada Cornel, ada Prof Nizam, nunggu-nunggu kamu ini. Tadi aja ini loh, yang PIC-nya ketakutan, Pak itu Mbak Soraya udah masuk, tolong segera disambut. Gitu, saya udah langsung disuruh nyambut loh Mbak Soraya ini dari Pertamina ini Mbak Soraya ini. Ini calon penggantinya Bu Nike. Ya. Halo. Siapa? Loh ini pejabatnya Pertamina nih Mbak Soraya ini.
Iya Pak. Oh Yudi.
Lah mana videonya? Nggak kelihatan, cuma tulisannya aja. Hah?
Enggak Pak.
Mari Pak Warmin, selamat datang Pak Direktur Solo Pos. Terima kasih rawuhnya. Nanti saya ngikut. Saya enggak apa-apa, ini dari isu yang umum. Nanti pas saya ini. Ini yang Inka. Ini dosen vokasi UNS. Nggak apa-apa, ini nanti sama Pak Warmin. Ini zoomnya jauh sekali ya itunya ya. Itunya. Oh sama. Ini yang Pertamina sudah masuk sambil kita monitor Pak Agus Cahyana. Nanti Pak Agus Cahyana maunya presentasi terus langsung ditanya. Kalau yang nanya jenengan biar mengarah ke bisnis. Beliau banyak pengalaman ya. Mantan sekjen perindustrian terus Menteri SD. Kok masuk suaranya ya? Suaranya bocor ya? Oke. Selamat datang Pak Andianto. Terima kasih rawuhnya.
Selamat siang, terima kasih Bapak.
Ini saya sudah bersama Direktur Bisnis Solo Pos ini Pak Warmin. Nanti mau nanya-nanya Pak Andrianto.
Baik.
Kita tunggu sebentar ya. Ini selamat datang Pak Kiwi. Pak Dr. Kiwi. Ya ini sudah habis wisuda dari UGM S3, belum syukuran ke Solo.
Akan datang.
Ya. Ini di luar negeri atau di Jakarta Pak Kiwi?
Lagi di Myanmar Pak.
Oh lagi di Myanmar ya?
Iya. Selamat siang Pak Kiwi. Salam kenal.
Sambil ini nunggu satu ini Pak Agus Cahyana. Sudah. Yang ini Pak. Ya.
Pak lagi di mana Pak Adrianto?
Pak Adrianto ini juga di Jakarta ini, nggak ke Solo.
Di Jakarta. Oh.
Iya.
Ini acaranya semuanya online apa ada online offline?
Sebetulnya offline, kalau berkenan hadir ke Solo sambil makan tengkleng offline, tapi Pak Ardianto sibuk jadi nggak ke Solo ini. Yang ke Solo cuma dari Inka sama kami. Ya, jadi yang online ada Pak Kiwi, Pak Agus Cahyana, sama ini Pak Ardianto gitu.
Ya, mohon maaf.
Saya juga mohon maaf.
Yeah.
Pak, bagaimana itu keadaan apa fuel di Indonesia, Pak Dianto? Fuelnya masih cukup apa gimana nih?
Ya kalau memang untuk gasolin kan kita memang selalu impor ya Pak ya, karena kapasitas produksinya Pertamina dengan demand bedanya hampir 50%.
Waduh, benar juga. Kita itu berapa kebutuhannya berapa sih Pak per bulan?
1,5 juta barel per hari. 1,5 juta barel per hari.
1,5 juta barel per hari itu 200.000 ton.
Pak Agus sudah hadir di Zoom ya, Pak Agus.
Ya, sementara kapasitas kilang kita hanya 1,1.
Ya, terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Selamat siang Pak Agus.
Siang Pak Andianto.
Pak Agus Cahyana sudah rawuh, sudah hadir?
Sudah.
Baik, karena para narasumber sudah hadir, mohon izin kita mulai ya Prof. Wahyudi ya. Baik, Bapak dan Ibu yang saya hormati, bersyukur sekali dan berbahagia sekali kita pada siang hari ini hadir pada acara The Second International Conference Energy Storage Technology and Application. Kita akan bicara tentang kendala dan peluang bisnis pada ekosistem energi storage dan EV di Indonesia dengan narasumber yang hadir pada siang hari ini. Nanti yang pertama karena beliau memang ada acara lain adalah Pak Agus Cahyana Wirakusuma. Beliau adalah staf khusus Menteri ISDM. Kemudian hadir juga nanti Pak Ferry Pandu Wijaya PhD, Kepala SBU Tier 1 dan 2 PT Inka Persero. Hadir di Solo ya Pak ya. Gimana perjalanan Madiun Solo? Alhamdulillah aman ya. 1 jam ya. Ya sekarang dalam kondisi serba keterhubungan ini, Madiun Solo 1 jam, Solo Semarang 1 jam gitu ya. Solo Surabaya 2,5 jam, luar biasa. Juga hadir beliau adalah Pak Andianto Hidayat, VP Research and Innovation Technology PT Pertamina. Nanti kita akan banyak ngobrol dengan beliau terkait dengan perkembangan ekosistem storage dan EV di Indonesia. Kemudian juga Pak Dr. Kiwi Aliwarga, beliau adalah CEO UMG Idea Lab. Dan saya kali ini saya hanya menemani Bapak dan Ibu, nanti pemain utamanya Prof. Wahyudi aja. Prof. Wahyudi dari PUI Baterai UNS, Pusat Unggulan Iptek UNS yang luar biasa, yang menjadi bagian dari ekosistem kendaraan listrik di Indonesia. Ya, baik. Ini untuk yang pertama Pak Agus dulu ya, Prof ya. Pak Agus Cahyana. Pak Agus, waktunya silahkan. Berapa menit untuk Pak Agus ini? 15 menit? Ya, Pak Agus nanti silahkan menyampaikan materi 15 menit dan setelah itu tanya jawab sebentar. Monggo, silahkan Pak Agus Cahyana.
Terima kasih Bapak dan Ibu sekalian, Prof. Wahyudi, Pak Andianto, terus yang lain. lain yang saya tidak bisa sebutkan satu persatu. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera bagi kita semua. Selamat siang. Jadi saya hari ini sebenarnya diminta oleh Bu Intern untuk menggantikan beliau menyampaikan paparan karena beliau tiba-tiba ditugaskan Pak Menteri ke Inggris. Ya, jadi saya tanya, Bu Intern mau ngasih apa? Baterai aja lah katanya gitu. Jadi saya akan spesialis pada EV aja karena kalau saya lihat tornya itu menyangkut energy storage ya secara keseluruhan. Baik, izinkan saya mau share screen. Share screen, bentar. Apa sudah bisa dilihat?
Sudah Pak, sudah.
Ya, baik. Jadi saya namai presentasi saya konsep pengembangan industri baterai EV nasional. Kemarin saya menyampaikan paparan yang sama, tapi hanya dikasih waktu 7 menit, pendek sekali di forumnya apa namanya yang di balai sidang di itu kira-kira harganya hampir sama ya mengenai hal yang sama. Baik, Bapak dan Ibu sekalian, saya memberikan ini gambarnya. Sebelah kiri ini adalah irisan daripada tanah air kita, ya, yang ada nikelnya. Jadi yang tengah-tengah itu barangkali dari UNS sudah sangat kenal, itu adalah limonite, cikal bakal daripada baterai kita yang sebelah kanan. Dan yang paling bawah itu adalah saprolite, ya, yang nikel kontennya lebih tinggi. Jadi yang limonite itu di bawah dari saprolite. Zaman dulu saprolite itu digunakan untuk ferronikel dan sebagainya, untuk stainless steel. Jadi biasanya diambil dulu, disingkirkan, baru diambil bawahnya. Nah, alhamdulillah dengan adanya baterai ini, ya, kita bisa menggunakan atas maupun bawah. Yang bawah atasnya itu menjadi baterai, yang bawahnya bisa menjadi untuk membuat stainless steel dan sebagainya. Nah, saya akan mulai dulu barangkali mengajak Bapak dan Ibu sekalian melihat tataran global sebelum kita berpikir secara nasional. Pertama, bagaimana sih bisnis baterai global? Ya. Nah, ini sebelah kiri adalah negara penghasil lithium ion battery, ya, tahun 2021. Jadi jumlahnya itu sekitar sekarang itu 700 gigawatt hours, dan 79% atau 80% dibuat di Cina. Kemudian Amerika nomor 2, jauh 6,2, Hungaria 4 dan sebagainya. Jadi Indonesia belum ada. Nah, jadi kita mau bicara bisnis baterai global betul-betul merayap dari yang nggak ada apa-apanya. Nah, siapa sih pemainnya? Ini sebelah kanan, ya. Dari yang merah ini, Cina ini 34% adalah dari CATL, nomor 1. Nomor 2 LG 14%. Nomor 3 ini BYD 12. Jadi kalau ini jumlahkan bertiga saja sudah separuh dari dunia. Nah, inilah kalau kita lihat gambarnya di sini semuanya merah, ya, karena memang itu asalnya di Cina semua, ya. Jadi tidak heran kalau 80% bisnis baterai global memang sudah sejak saya kira 2012-an lah didorong oleh Cina, itu sangat-sangat kencang. Nah, gimana 2035 gitu ya ke depan? Ini kita lihat ke belakang. Apakah kita bisa main di dalam bisnis ini? Nah, kewajiban kita untuk mulai merubah tadi saprolite atau limonite itu menyangkut rantai produksi EV dan baterai yang luar biasa. Kita harus mulai dari refining, jadi yang warna coklat tadi kita harus refine, kemudian kita bangun menjadi baterai material, kita bangun menjadi sel. Nah, ini adalah bagian daripada industri baterai. Nah, downstreamnya adalah 4-wheeler EV, ya, 2-wheeler EV, kemudian ISS. Jadi energy storage yang dimaksud di dalam TOR itu saya maksudkan ISS untuk infrastruktur termasuk untuk otomotif. Nah, saya memberikan gambaran ini. Ini adalah gambar refinery yang saya kunjungi kira-kira tahun 2019 kalau nggak salah sebelum. Ini ada di Ramu di Papua Nugini, kepunyaan Cina. Jadi dia menggunakan proses HPAL yang ada di refining ini. Kira-kira itulah yang akan yang saya buka bisnis baterai global. Mungkin nanti saya kira nanti UNS yang juga sudah pernah saya kunjungi labnya akan menjelaskan lebih dalam mengenai masalah baterai. Baik. Nah, tadi pertanyaan saya adalah 2035. Nah, menurut sumber dari yang saya peroleh, nah tadi kan 2001 adalah sekitar 700 gigawatt hours. Proyeksi tahun 2035 kalau tidak ada apa-apa akan menjadi 5,3 TWh atau kira-kira 5.300 gigawatt hours. Jadi kalau dikalikan hampir 8 kali atau 7 kali lebih. Ya, jadi ini suatu perkembangan yang luar biasa di mana pendukungnya adalah passenger kendaraan, ya, kendaraan, nanti ada komersial dan sebagainya. Jadi kira-kira demikian. Nah, perkaranya sekarang kita ada di mana gitu, ya. Proyeksi yang saya dapatkan dari PT IB yang kebetulan dulu saya pernah menjadi komisaris utama di sana, ya. Jadi tahun 2035 itu
putus-putus ya Pak Agus.
sekitar 60 gigawatt kira-kira. Bapak dengar? Oh, internet connection is unstable. Maaf. Apa saya keluar dulu atau gimana?
Atau videonya mungkin bisa dimatiin dulu Pak Agus. Kameranya.
Dia matikan, baik.
Iya.
Iya, baik. Sebentar. Kamera. Ya,
sudah.
Sekarang gimana? Oke. Jadi
suaranya lebih jelas, wajahnya Pak Agus yang nggak jelas ini.
mohon maaf.
Nggak apa-apa.
Jadi tadi sampai di mana saya, Pak?
Sampai di yang bagian 2 itu, Pak Agus. Yang
ini, sampai di sini.
Iya, iya.
Oke, jadi tahun 2021 sekitar 700 giga, tahun 2035 akan jadi 5, tera atau sekitar 5.300 gigawatt hours. Nah, di Indonesia sendiri forecast kita dari PT IBC, di mana saya pernah juga jadi komisaris utama di sana, itu kira-kira seperti ini, 60% oleh roda 4, kemudian sekitar mungkin 20% roda 2, kemudian ini energy storage untuk konstruksi, dan ini untuk ekspor. Jadi kalau kita bandingkan demand kita terhadap permintaan di tahun 2025, kita itu hanya 1,1% kebutuhan kita. Jadi memang kita belum besar, walaupun ini sudah luar biasa forecastnya. Itulah yang kita hadapi, dan ini menjadi tantangan bagi kita semua untuk melakukan akselerasi penggunaan mobil dan motor listrik yang sebenarnya pemerintah sangat mendorong itu seperti sudah dikeluarkannya ada 1 kepres, 2 impres, ya, tidak tanggung-tanggung. Baik. Nah, kita memiliki keunggulan kompetitif untuk itu. Jadi untuk mencapai 60 giga itu saat ini diperkirakan populasinya hitungannya sekitar nanti akan mencapai 8,6 juta unit dan 2,2 juta unit ya di tahun 2035 itu. Di mana penjualannya itu kira-kira hampir separuhnya listrik dan sisanya masih motor bakar. Ya, baik sepeda motor maupun kendaraan 4. Kita diberikan oleh Tuhan Yang Maha Kuasa kelebihan-kelebihan untuk kita pakai sebagai modal untuk membangun. Ya, kita ini nomor 16 ekonomi terbesar di dunia dan proyeksi kita dengan kerja keras mudah-mudahan nanti menjadi nomor 5. Cadangan mineral kita sangat besar untuk nikel misalnya, koper, mangan dan sebagainya cukup besar. Kita ini adalah pasar terbesar di ASEAN, tetap dan produsen nomor 2. Dan kita jangan lupa bahwa baterai itu kira-kira merupakan nilainya di kendaraan roda 4 itu hampir 35% daripada seluruhnya. Jadi ini merupakan sesuatu keunggulan yang harusnya kita manfaatkan baik untuk di dalam negeri maupun untuk kebutuhan ekspor. Nah, mungkin nanti dari UNS akan menjelaskan, tetapi ini saya mengambil supply chain dari baterai. Jadi kita mulai dari limonite yang tadi saya gambarkan, ya kan, kemudian diproses, ya, di HPAL, kemudian nanti dibuat menjadi refinery solvent dan kemudian dibuat prekursor. Ditambah dengan sulfat, ditambah dengan mangan menjadilah prekursor. Tambah litium menjadi katoda. Kemudian kita pasang anoda, kita pasang elektrolit, jadilah sel. Sel dirakit menjadi packing, siap ke mobil. Nah, Bapak dan Ibu sekalian, di sini letak keunggulan kita. Sampai saat ini saya mendapat data dari Kemenperin, paling tidak sudah ada 5 perusahaan yang sudah bergerak di di hulu di sini, ya. Jumlahnya itu 240.000 ton nikel per tahun. Belum saya masukkan PT ABC atau Indonesian Battery Corporation karena masih di dalam proses negosiasi joint venture. Ini saja kalau saya jumlahkan dan saya hitung pelan-pelan dengan kandungan nikelnya, dengan nilai daripada listrik yang terkandung. Kalau dijumlahkan ini yang di hulu saja sudah 6% daripada kebutuhan dunia yang sebesar 5.300 gigawatt hours. Belum ditambah IBC yang kita sudah tahu bahwa IBC sedang berbicara dengan 2 produsen terbesar yang tadi, CATL dan LG. Jadi saya pikir paling tidak ini bisa mendekati 10% daripada kebutuhan bahan baku untuk baterai dunia. Nah, kalau kita lihat dari gambar yang sebelumnya, Cina dan Amerika saja hanya 6%. Jadi kalau kita disebut pemain bahan baku baterai itu sudah boleh dikatakan kita akan masuk ke area itu. Baik, jadi saya kira ini yang sudah kita ketahui. Kita grafit katanya punya, tapi saya masih kasih tanda tanya. Aluminium, nikel, kopel, steel, mangan, kobalt, lithium saya coret dan iron. Jadi kenapa sih kita tidak mengembangkan ini? Saya sebagai bagian daripada SDM sangat mendorong bahwa produk-produk yang ada di tanah kita ini dapat ditingkatkan nilai tambahnya menjadi berharga bagi kesejahteraan rakyat dan juga negara. Nah, saya kira tadi sudah saya ungkapkan bahwa PT IB atau Industri Baterai Indonesia, orang sering menyebutnya IBC, Indonesian Battery Corporation, itu memiliki roadmap seperti ini. Jadi kenapa tadi saya hanya menyampaikan hulunya ini saya sudah masukkan ada 5 perusahaan ditambah PT IBC. Jadi pada posisi sekarang 2022-2023 PT IB sudah mulai masuk ke ekosistem sepeda motor. Tadi di rapat dengan Menko Marves dilaporkan bahwa akan ada transaksi bahwa PT IB akan memiliki sepeda motor, sehingga dia akan mulai tahun ini dengan bisnis ini, dan kemudian dia akan juga memproduksi sel, walaupun tentu bukan sel, pack manufacturnya, jadi belum sampai sel. Nah, sel itu kira-kira nanti akan selesai di tahun-tahun berikutnya. Di tahun 2024 ya, ini kira-kira yang akan dilakukan swap operator, kemudian two wheels manufacturers ya, ISS ya, energy storage dia akan masuk ke situ. Nah, mulai memproduksi two wheel cell to pack, berarti tapi di sini masih mengimpor, tapi kemudian nanti pada tahun 2025 akan mulai produksi sendiri karena sudah jadi ya, lokal precursor manufaktur sudah jadi, kemudian katode sudah jadi. Nah, nanti selnya akan jadi 2026. Jadi selama ini dia akan masuk dulu, selnya masih dia impor tapi sudah main di pack. Kenapa? Jadi supaya sudah mulai main di bisnis, jangan nanti baru mulai main. Jadi itu ada persiapan-persiapan yang sudah dilakukan. Nah, ini akan terbentuk nanti selnya di sini. Kemudian tahun 2005 itu sudah masuk ke ini four wheel cell to pack manufacturing. Jadi akan memiliki membuat packingnya. Walaupun sekarang pun sudah akan joint venture dengan LG yang sedang membantu membuat pack. Jadi ini kira-kira roadmap industri baterai Indonesia dari hulu ke hilir.
Ya, Pak Agus, waktunya 1 menit lagi, Pak Agus.
Baik ya, saya kira ini kira-kira roadmap industri baterai kita. Mudah-mudahan ini bisa memberikan masukan kepada Bapak dan Ibu sekalian yang akan terus berdiskusi. Nah, saya tutup. Saya cepat sekali bahwa untuk mengembangkan itu perlu insentif. Insentif atau ada 3 jenis: lokalisasi kendaraan, meningkatkan ketertarikan penggunaan, meningkatkan populasi. Ini semua ini harus kita tekuni. Dari semua ini yang ada baru yang merah ini, ya. Nah, oleh karena itu kalau kita lihat ini yang sudah diberikan oleh pemerintah, nanti Bapak dan Ibu sekalian bisa baca, mudah-mudahan. Dan itu adalah akan terus berkembang, mendorong tumbuhnya populasi untuk 3 tujuan tadi. Yang lain harus dibangun, saya kira saya akan lewat. Di sini ada katoda ini baru 45%, masih ada anoda, masih ada elektrolit, ada separator. Jadi masih terbuka bagi industri-industri lainnya. Kesimpulannya, jadi saya kira ini tidak akan saya baca. Yang penting bahwa kita baru mulai, kita harus mempercepat. Kita punya bahan baku, kita punya chance yang tinggi. Kita akan menggunakan joint venture, tapi harus win-win, ya. Kita harus mampu menggunakan itu untuk industri dalam negeri. Dan terakhir, untuk ISS khususnya saya tambahkan, inilah kira-kira nanti akan tahun 2060 dalam rangka NCE itu, bahwa kita akan pembangkit EBT kita, energi baru terbarukan, adalah sekitar 587 gigawatt hours, di mana PLTS-nya 361 gigawatt hours, dan Bapak dan Ibu sekalian mengerti bahwa PLTS sangat membutuhkan baterai. Saya kira demikian
terima kasih
masukan yang saya, ya, mudah-mudahan bermanfaat. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Tepuk tangan untuk Pak Agus ya, memberikan kepercayaan diri ya kepada kita bahwa sebenarnya kita dari sisi modal mineral itu sudah salah satu yang terbanyak ya, Prof. Ayudi ya, di dunia gitu ya. Dan bagaimana dengan 2035, mudah-mudahan akan ada insentif-insentif lain dari pemerintah sehingga untuk bisa mempercepat industri baterai kita, sehingga kendaraan listrik juga akan semakin banyak ini di Indonesia. Monggo ada pertanyaan, silahkan.
Silakan Pak Agus, ini di ruangan kami juga kehadiran salah satu komisaris BUMN ini, barangkali Pak Yoga Katon mau nanya begitu. Ada juga beberapa praktisi industri dan juga para peneliti, ada peneliti dari PUI Baterai Lithium. Monggo pertanyaan Pak Yoga. Oke. Kan saya turun kalau ada ini, nanti soalnya Pak segera ada acara dengan Pak Menteri begitu. Iya, kalau
lagi zoom. Silakan Pak.
Iya, terima kasih. Jadi tadi kalau kita melihat roadmap-nya sampai dengan tahun 2030 Pak ya, seperti itu. Jadi dengan tahapan mulainya kalau saya melihat ini dari hilir, karena kan menyiapkan satu ini dulu, satu marketnya disiapkan, terus kemudian baru tahapannya ke hulu seperti itu. Tapi satu sisi hulu sudah dikerjakan juga seperti itu. Jadi ada kelihatannya nanti muaranya ada di tengah nih, akhirnya ada di tengah seperti itu. Nah, saya melihat ada beberapa hal yang memang kalau kita melihat pemetaannya tadi itu saya belum bisa memprediksi mungkin tahapan-tahapannya Pak Agus ya. Jadi misalnya saja potensi yang ada di, katakanlah nanti lihat marketnya juga sudah ada Pak, bahkan seperti Inka, seperti MAB, terus kemudian ada juga mungkin ada Bakri ya, seperti itu. Dia sudah membuat transportasi umum seperti itu, seperti bis dan kereta. Itu aja Pak Agus, terima kasih. Terima kasih Prof. Nizam. Ya.
Jadi judul yang saya sampaikan Roadmap Industri Baterai Indonesia dari IBI Pak ini. Jadi PT IBI memiliki, ya kan? Jadi memang kalau Bapak melihat ini masih sentris kepada masalah nikel, ya kan? Kita sadar bahwa baterai itu kan ada jenis-jenis lain, ada LFP dan sebagainya, dan khususnya untuk kendaraan-kendaraan berat, ya, yang memang masalah ruangan dan masalah berat tidak menjadi masalah. Jadi Bapak dan Ibu sekalian, nanti roadmap yang ada. Jadi ini roadmap yang saya sebutkan adalah roadmap industri baterai Indonesia. Jadi IBI, jadi PT IBI, ya. Nanti kalau misalnya kita sudah sering ketemu, kita bisa membuat roadmap untuk industri baterai Indonesia itu yang adalah resultante daripada berbagai industri yang ada. Saya tahu yang Bapak sebutkan itu mungkin dari produknya Pak Hermawan, PT ABC menggunakan LFP, ya kan, dia sudah mampu membuat sampai 100 mega dan sebagainya. Itu merupakan kekayaan yang bisa kita gunakan untuk ICESTA terutama, ya, karena ICESTA tidak terlalu sensitif terhadap berat. Jadi saya betul sekali Pak Nizam bahwa ini merupakan roadmap yang saya ambil dari PT IBI, ya. Dan untuk yang lain lebih banyak kepada nanti akan menjadi mixnya. Nah, PT ABC memang sudah membuat dengan mengimpor prekursornya. Nah, sebelumnya malah material aktifnya, prekursor mereka bikin sendiri di Tangerang sana. Jadi pemakai-pemakainya betul, ada MAB, ada nanti yang G20 dengan PT Inka dan sebagainya. Itu saya kira merupakan bagian-bagian memperkaya hasanah penggunaan energy storage yang non nikel. Cuman bahan-bahan untuk LFP itu saya kira tidak sekaya daripada nikel gitu ya. Nah, itulah yang menjadi bagian daripada kita semua. Kami dari ESDM sangat menunggu masukan dari tempat Bapak bagaimana kira-kira untuk bisa mengembangkan roadmap LFP di Indonesia. Saya kira itu.
Terima kasih. Mungkin nambah satu lagi pertanyaan ya Pak Agus ya. Kebetulan masih ada satu audiens. Monggo Pak Andi. Kiranya dapat lebih pendek begitu pertanyaannya.
Terima kasih. Perkenalkan, saya Anif Pak Agus dari PUI Baterai juga dan ingin sedikit bertanya. Tadi kan lebih banyak yang disoroti adalah katoda ya. Padahal tadi juga sama mau mencoba graphite gitu kan. Dan kalau kita mengarah ke anoda gitu kan, kita punya potensi silikon juga beberapa material karbon bisa dari biomas atau activated carbon kan limbah-limbah dari kelapa sawit juga bisa kita kembangkan gitu Pak. Dari roadmapnya kok belum ada, mungkin bisa sebagai tambahan masukan seperti itu Pak. Itu dari kami. Makasih.
Terima kasih Pak Anif. Ya, jadi memang betul sekali ya. Ya saya nggak boleh lebih dari waktu yang ditentukan. Jadi saya tidak bisa juga terlalu panjang. Jadi baiklah Pak Anif, itu saya catat sekali bahwa memang tadi saya sudah sampaikan bahwa di samping katoda ada komponen lain yang harus kita kembangkan ya, anoda ya dan sebagainya. Malah kemarin teman menelpon kita harus mengembangkan copper foil ya, di samping aluminum foil. Jadi banyak sekali yang memang harus kita kembangkan di samping itu yang memang akan diperlukan baik untuk katoda maupun anoda. Jadi bukan saja grafitnya barangkali, tetapi juga foilnya dan sebagainya. Karena sekarang tiba-tiba harganya melonjak bukan main, ya kan? Itu juga harus kita pikirkan bersama. Terima kasih atas masukannya. Kalau saya sangat terbuka untuk kita. Tadi terus terang itu adalah roadmap yang kita ambil dari PT IB, Industri Baterai Indonesia. Jadi saya nggak pakai PT depannya. Itu sebagai contoh yang jelas komitmennya ya, dan tahun berapa dia akan buat, siapa partnernya, dan berapa rupiah yang akan dia keluarkan untuk investasi. Nanti kalau memang ada yang lain yang akan masuk, kita masukkan semuanya. Ya, menurut saya. Demikian. Terima kasih. Saya kembalikan kepada Pak Moderator.
Pak Agus, ini kan susah sekali ketemu Pak Agus nih. Boleh satu pertanyaan lagi dari saya gitu. Nah, ini sebetulnya beberapa waktu yang lalu saya sempat juga melalui webinar Solo Pos PUI UNS itu mengundang salah satu kepala seksi ya di ESDM di webinar keempat kami. Katanya kan mau ada revisi peraturan ESDM yang berkaitan untuk akselerasi utamanya bisnis, karena sudah mulai ketahuan bahwa beberapa hal terkait misalkan saja implementasi infrastruktur yang ada sekarang seperti charging station, kalau government tidak ikut mengatur begitu untuk mendorong agar menggunakan standar yang jumlahnya sedikit itu agak susah gitu. Belum lagi masalah sekarang ini kan Internet of Things untuk menjalankan bisnis sepeda motor listrik maupun mobil kan sudah mulai. Di sisi yang lain database konsumen itu sudah mulai dihimpun oleh para provider sepeda motor listrik maupun barangkali mobil listrik. Nah, kira-kira bocorannya apa ini Pak Agus? Kemarin katanya akan segera direvisi yang lebih agresif begitu dan melindungi konsumennya itu lebih begitu. Terima kasih Pak Agus.
Baik, tadi baru saya kira memang ini material yang akan dibicarakan di Kementerian Marves yang hari ini. Jadi Revisinya itu menyangkut mengenai tarif tenaga listrik untuk SPBKLU dan SPKLU. Nah, itu sudah dikeluarkan nomor 13 tahun 2020. Nah, itu akan kita sempurnakan supaya memberikan lebih kemudahan lagi. Dan itu sudah ditargetkan akhir bulan ini harus selesai. Nah, saya tidak bisa mendahului, tapi kalau Bapak pelajari Permen ESDM nomor 13 tahun 2020 mengenai tarif tenaga listriknya itu akan lebih disempurnakan supaya lebih menarik lagi investor untuk masuk. Kan kita sudah sepakat khusus untuk EV ya bahwa infrastruktur salah satunya adalah mengenai SPKLU dan SPBKLU. Ya, jadi itu sangat menentukan konsumen untuk membeli karena kemudahan. Nah, itulah yang tadi disampaikan oleh teman dari SDM bahwa insya Allah mudah-mudahan akhir bulan ini bisa dikeluarkan sehingga mungkin nanti bulan depan Bapak-bapak bisa menyaksikan bahwa aturannya akan lebih kondusif terhadap membangun ekosistem tadi kan. Jadi ada 3 jenis milik pemerintah, misalnya milik PLN, kemudian nanti PLN akan bekerja sama dengan swasta dan full swasta. Nah, kemudian berapa besar charge daripada harga listriknya, itulah yang akan diatur supaya lebih kondusif. Saya kira itu saja yang bisa saya sampaikan. Pada waktunya akan disampaikan dengan resmi.
Terima kasih. Ini Pak Warmin rasanya cukup untuk Pak Agus. Ini juga barangkali akan segera ada acara dengan Pak Menteri.
Iya, Pak Agus, terima kasih Pak Agus atas waktunya, dan mudah-mudahan ke depan kita ada kesempatan lagi untuk ini Pak, berdiskusi dan bersinergi Pak.
Ya, baik.
Ya.
Saya mohon maaf dari Bu Inten yang nggak bisa hadir langsung sehingga saya mewakili beliau. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh. Saya pamit undur diri.
Waalaikumsalam warahmatullahi wabarakatuh, dan terima kasih Pak Agus. Gitu.
Ya. Siap Pak Agus.
Kita beri aplaus kepada Pak Agus.
Aplaus untuk Pak Agus. Baik, setelah Pak Agus Cahyana, berikutnya adalah narasumber kita dari Pertamina ya, Prof. Wahyudi ya. Pak Andianto Hidayat masih bersama kami?
Ya.
Masih Pak.
Pak Adianto, silakan Pak, waktu Bapak juga sama 15 menit untuk menyampaikan paparan atau barangkali presentasi yang bisa disampaikan. Silakan.
Ya, tapi nanti mohon izin Pak Adianto kalau waktunya longgar ini ketiga-tiganya biar presentasi 15 menit gitu nggih Pak Adianto nggih. Jadi setelah nanti Pak Andianto nanti ada Pak Kiwi dan juga Pak Febri dari Inka. Nah, setelah itu kita coba diskusi gitu.
Siap.
Terima kasih.
Monggo Pak Andianto.
Ya, Prof. Wahyudi, ya. Baik, terima kasih. Silakan tolong di-share materinya. Baik, selamat siang Bapak Ibu sekalian, salam sejahtera buat kita semua. Senantiasa kita panjatkan puji syukur kepada Allah Subhanahu wa taala yang telah memberikan kita semua kesehatan dan perlindungan sehingga hari ini kita dalam keadaan sehat walafiat. Hari ini saya mendapatkan amanah dari teman-teman panitia. Terima kasih atas kesempatannya. Diminta untuk bicara mengenai pengembangan baterai dan hidrogen ya di Pertamina seperti apa, dan kaitannya dengan upaya-upaya Pertamina untuk melakukan dekarbonisasi menuju net zero emission. Nanti ada beberapa slide yang akan terkait di situ. Tapi sebelumnya saya ingin memperkenalkan diri dulu mengenai apa sih research and technology innovation yang ada di Pertamina. Silahkan next. Nah, sesuai dengan apa ya yang lagi tren di dunia saat ini, bahwa semua perusahaan energi itu harus memiliki rating ESG ya, di mana itu merupakan indikator maupun parameter yang dipakai oleh lembaga keuangan internasional maupun oleh investor untuk melihat apakah perusahaan ini telah memiliki kesadaran, inisiatif, dan program-program yang nyata untuk mendukung environment, kemudian sosial dan governance yang transparan. Nah, tahun lalu kita mendapatkan nilai 28,1. Nah, itu menjadi oleh Sustainalytics ya. Itu adalah medium risk, ranking 15 dari 251 industri migas dunia, atau kira-kira di percentage 7% teratas gitu. Kita diukur mengenai bahwa Pertamina memiliki kesadaran untuk lingkungan, kemudian juga responsibel terhadap lingkungan sosial, dan memiliki good corporate governance. Nah, dengan indikator ini investor akan terus mendukung upaya investasi di Pertamina dan menguncurkan dananya untuk Pertamina bisa mengembangkan kegiatan usaha menuju ke transisi energi di masa depan. Lanjut. RTI itu merupakan Integrated Research Center-nya Pertamina. Kami bergabung di tahun 2017. Setelah sebelumnya itu ada beberapa research center ataupun grup-grup peneliti yang ada terpisah di hulu, di hilir, di pemasaran, di direktorat gas gitu ya. Kemudian di tahun 2017 dibakukan untuk menjadi sebuah unit integrated research center, sehingga kami bisa berbagi expertise, berbagi resources, dan bisa memperkuat kemampuan penguasaan teknologi yang ada di Pertamina. Kemudian di tahun 2020, di tahun 2020 kita berubah nama menjadi INV ya, Innovation and New Venture, karena waktu itu terus terjadi pemisahan antara holding dan sub-holding di Pertamina. Dan tahun 2021 kita resmi namanya berubah menjadi Research and Technology Innovation, karena New Ventures-nya terpisah. Karena New Ventures ini adalah bagian dari inkubasi bisnis-bisnis baru yang ada baik dari dalam Pertamina maupun dari luar Pertamina, terutama yang berkaitan dengan energi bersih, energi inovatif yang mampu membawa Indonesia ke net zero emission. Lanjut. Nah, untuk organisasi saat ini di tempat kami dibagi menjadi 3 grup utama. Yang biru paling kiri adalah 2 grup peneliti. Grup peneliti yang bidang upstream, grup peneliti bidang downstream. Kemudian yang hijau tengah itu adalah laboratorium pendukung, dan yang orange kanan itu adalah bagian dari planning and commercial development yang merupakan jembatan antara riset sebelum diimplementasikan di unit bisnis. Nah, kita melihat bahwa human resource merupakan challenge buat Pertamina saat ini, karena memang para peneliti-peneliti senior sudah mendekati sudah pada pensiun dan belum ada gantinya, sehingga kita tetap harus mengembangkan kapabilitas peneliti yang semakin cepat ini untuk menggunakan tenaga-tenaga baru. Apalagi Pertamina mulai banyak masuk ke energi-energi baru terbarukan, bidang-bidang baru, fuel cell, hydrogen, baterai, energy storage, kemudian juga new energy lainnya untuk menjadi power. Itu membuat Pertamina juga makin harus mengembangkan human resource-nya dan juga infrastruktur dari penelitiannya. Lanjut. Untuk melakukan penelitian, tujuannya kita adalah melakukan optimasi dari existing resources, sumber-sumber daya yang ada di Pertamina saat ini maupun di dalam negeri. Mungkin juga melakukan recovery, exploring dari new resources, sumber-sumber non-konvensional terutamanya, dan juga energi-energi baru terbarukan. Kemudian meningkatkan operational excellence dan memastikan bahwa Pertamina bisa melanjutkan bisnis secara sustainable di masa depan, di mana terjadi era transisi energi. Ini dipengaruhi oleh energi tren dunia, kemudian peraturan internasional maupun di dalam negeri, kemudian juga potensi sumber daya alam, sumber daya energi yang ada, sekaligus juga prioritas dari strategi Pertamina saat ini sesuai dengan RJPP. Lanjut. Nah, untuk melakukan penelitian tersebut kita tidak sendirian, kita melakukan penelitian menggunakan peneliti internal, in-house researchers, namun juga kita juga menggunakan partnership. Nah, ini partnership kita sangat besar, sangat banyak sekali, baik itu apakah universitas, perguruan tinggi, dan lembaga penelitian yang ada di Indonesia, maupun juga beberapa industri, maupun juga teknologi provider, lembaga penelitian yang ada di internasional, apakah itu di Eropa, di Amerika, maupun di Asia. Jadi ini membuktikan bahwa Pertamina juga mendapatkan kepercayaan, memiliki kapabilitas research yang handal, dan memiliki sumber daya yang bisa dipakai untuk implementasi teknologi-teknologi baru, maupun juga era baru dalam mengembangkan energi bersih masa depan. Termasuk diantaranya adalah bekerja sama dengan UNS ya, yang sudah berjalan hampir sepanjang RTI ada, karena waktu itu memang dengan baterai itu kita sudah mulai di tahun 2017 bersama UNS, dan untuk dengan LPDP sudah akan masuk tahun ketiga yang akan ditutup nanti kira-kira minggu depan kalau nggak salah. Lanjut. Nah, ini riset Pertamina di bidang baterai ya. Jadi Pertamina menyadari bahwa ke depan market migas itu akan shrinking karena terjadi disrupsi teknologi. Namun juga kita tidak mungkin bisa melepaskan aset-aset infrastruktur retail yang sudah ada, dan juga tidak ingin kehilangan market transportasi darat, transportasi ringan penumpang yang ada di Indonesia. Sehingga kita melihat kita tidak mungkin menjadi pabrikan mobil, tidak mungkin menjadi pabrikan kendaraan bermotor. Ya, kita melihat bahwa karena ini energy company, maka Pertamina harus masuk dan melakukan inovasi di bidang baterai sebagai penampung atau storage energi masa depan yang memungkinkan kendaraan listrik bisa bergerak. Evolusi teknologi baterai sudah dimulai dari tahun 1900-an dengan lead acid waktu itu ya, yang sudah sangat kita kenal berupa aki, kemudian menuju ke zinc karbon, kemudian mulai ada nickel based. Nickel based juga saat ini masih banyak digunakan di kendaraan hybridnya Toyota, itu masih menggunakan nickel mangan hydrate. Nah, kemudian juga ada baterai alkalin, dan mulai tahun 2010-an kita sudah masuk ke lithium battery. Nah, ini yang akan terus kita kembangkan, terutama tadi sesuai dengan yang disampaikan pembicara sebelumnya ya, Pak Agus Cahyana, bahwa kami di Indonesia bersama-sama dengan UNS, juga bersama-sama dengan IB nantinya akan mengembangkan tipe lithium baterai yang nickel rich, karena memang sumber daya nikel kita sangat besar. Nah, untuk yang LFP memang saat ini tidak menjadi prioritas di Pertamina. Namun kalau nanti misalnya industri itu memang bertumbuh dan diminati oleh market, tentu bisa kita lihat lebih lanjut apakah akan menjadi concern. Namun untuk penelitian baterai Pertamina memang lebih fokus ke yang pertama dulu adalah NCA, nickel cobalt alumina, dan kemudian menjadi nickel cobalt mangan. Ini semua merupakan memenuhi kebutuhan tantangan customer untuk mobility, komunikasi, maupun juga lifestyle di masa mendatang. Lanjut. Nah, development tadi ya saya sampaikan, kita mulai tahun 2016 ya, ketika Pertamina masuk ke bisnis baterai di dalam sebuah energy forum tahun 2016. Kemudian ada grup research yang khusus menangani baterai di Pertamina dengan bergabungnya dibentuknya Research Technology Innovation. Kemudian tahun 2017 kita memastikan bahwa di grup peneliti Pertamina ada terkait dengan energy storage, kemudian juga mengenai BMS bekerjasama dengan ITS, maupun ITB, UNS, dan UPER ya, misal Pertamina. Kemudian tahun 2018 kita melanjutkan ke pemanfaatan green petroleum coke sebagai salah satu material untuk anoda. Kemudian juga kita mengembangkan kerjasama dengan UNS itu tahap awal menggunakan LFP maupun NCA, dan selanjutnya membangun prototipe Pertamina battery cells yang cylindrical waktu itu. Kemudian tahun 2019 prototipe Pertamina battery pack, battery swapping station, dan battery management system sudah terselesaikan studinya dan ada prototipe-nya. Kemudian melakukan pilot project untuk implementasi dari BEST. Di tahun 2020 kita melanjutkan R&D untuk NCM cathode, kemudian juga anoda material yang menggunakan synthetic graphite dari green petroleum coke, lanjutan dari tahap sebelumnya. Kemudian juga masuk ke solid state baterai menggunakan RLZO. Lalu kita mulai large scale production untuk katoda aktif material dari NMC, NCA, LFP. Tahun 2021 lalu kita sudah memiliki prototype untuk NCM, nikel kobalt mangan tipe lithium ion baterai yang menggunakan komposisi 822, kemudian 622. Kemudian prototype all solid state baterai, kemudian juga material katoda, dan juga dengan 3 BUMN, Antam, Main ID, dan PLN, kami membentuk Industri Baterai Indonesia atau Indonesia Battery Corporation yang saat ini dikelola di bawah Pertamina Power Indonesia. Nah, tahun 2022 ini kita terus melanjutkan large scale production dari material aktif katoda NMC, NCA, LFP untuk lithium ion baterai menggunakan pendanaan dari LPDP CRISPR dan masuk ke tahun ketiga yang akan diakhiri di bulan ini. Dan terakhir kemarin barusan kira-kira 3 minggu lalu ya, di bulan September kemarin kami telah meresmikan laboratorium baterai kami yang gedungnya sudah resmi, sudah selesai di Dan Monggot. Kami sekarang sedang menunggu kedatangan dari alat-alat untuk lakukan pengujian, evaluasi, dan studi baterai tersebut. Next.
1 menit lagi, Pak Andianto.
Baik, ini adalah kerjasama dengan universitas dan beberapa lembaga penelitian. Lanjut, langsung ke hidrogen aja. Nah, selain baterai, kita juga melakukan pengujian penelitian next di bidang green hydrogen, karena kalau blue hydrogen ini masih memerlukan kerjasama dengan teman-teman hulu dalam bagaimana menginjeksikan CO2-nya ke dalam sumur tua Pertamina. Kalau green hydrogen memang sudah lama, itu sudah tidak digunakan lagi. Kita tidak lagi menggunakan gas alam sebagai bahan baku, tapi kita lebih menuju ke green hydrogen dengan pemanfaatan itu untuk industri, untuk transportasi, ataukah nanti untuk power generation. Jadi Pertamina mengharapkan kita bisa menggunakan sumber-sumber energi terbarukannya di dalam Pertamina, apakah itu nanti menggunakan geothermal, ataukah nanti menggunakan solar PV, atau bahkan mungkin kapasitas hydropower untuk menjadi energi bersih, energi hijau yang digunakan elektrolisa air menjadi hidrogen dan O2. Lanjut. Ini beberapa kerjasama kita, termasuk salah satunya nanti dengan INKA yang ada Pak Ferdi tadi akan berbicara dari INKA. Kita akan mengembangkan fuel cell untuk memanfaatkan hidrogen ke dalam gerbong generatornya PT Kereta Api, kerjasama juga dengan ITS dengan pendanaan dari LPDP. Lanjut. Oke, ini beberapa sumber potensial yang bisa digunakan Pertamina untuk membangun green hydrogen di Pertamina dari sumber-sumber geothermal yang ada. Oke, saya kira itu yang bisa kami sampaikan ya, karena waktunya juga sudah habis. Nanti kalau ada diskusi dengan senang hati kami akan melakukan diskusi. Yang jelas Pertamina siap untuk berpartisipasi aktif dan terus mengkomersialkan penelitian-penelitian yang terkait baterai bersama UNS, utamanya adalah yang tipe cylindrical 18650 yang masih menggunakan nikel. Dan setelah itu kita akan masuk menggunakan hidrogen sebagai energi masa depan dan memanfaatkan infrastruktur yang ada di Pertamina maupun mengembangkan infrastruktur baru, karena kedepannya mau tidak mau hidrogen adalah merupakan sasaran untuk energi berikutnya ya, yang dimana merupakan energi bersih. Demikian yang bisa saya sampaikan dari Pertamina. Nanti kita ketemu lagi ketika sesi diskusi. Saya kembalikan kepada moderator. Terima kasih Prof.
Baik, terima kasih Pak Adianto. Kita berikan aplaus kepada Pak Adianto. Mohon berkenan untuk mengikuti presentasi berikutnya dan nanti bisa disambung dengan diskusi. Pak Warmin, ini kita panggil pembicara berikutnya aja.
Monggo, silakan.
Ini doktor baru dari UGM dan juga sekaligus CEO UMG Idea Lab. Kami persilahkan Dr. Kiwi Aliwarga. Kita berikan aplaus kepada Pak Kiwi yang saat ini sedang di Myanmar ya, gitu. Monggo Pak Kiwi. Sama 15 menit ya Pak Kiwi, nanti disambung dengan diskusi setelah presentasi dari pembicara terakhir.
Oke, saya mohon bisa langsung ya. Kelihatan Pak?
Ya, clear.
Terima kasih semua teman-teman, rekan-rekan yang sudah hadir. Terima kasih juga kepercayaannya Pak Wahyudi dan tim UNS supaya saya bisa sharing sedikit di sini. Mungkin saya mulai dari UMG Idea Lab. UMG Idea Lab itu adalah venture capital dan venture builder. Salah satu startup kita, salah tiga gitu. Ada yang berkembang di clean energy, di renewable energy, yaitu di battery, di solar cell, baik di Indonesia maupun di Myanmar. Tadi kita dengar dari Pak Agus bahwa EV market itu akan berkembang 13 kali lebih banyak daripada saat ini. Kalau saat ini EV sales itu sekitar 2,2 juta kendaraan, di tahun 2035 itu menjadi hampir 42 juta. Jadi benar-benar extraordinary growth. Dan kalau kita lihat dari mana datangnya, itu kebanyakan datangnya itu dari China dan Eropa. Kenapa China dan Eropa? Karena ekosistem supply chain battery dan EV, bukan hanya battery ya, EV secara keseluruhan itu yang sekarang yang paling mature adalah dari China. Karena mereka sudah mulai lebih awal dan mungkin Eropa dan Amerika sudah sulit untuk ngejar ekosistem dan supply chain yang buat China sekarang. Kalau kita lihat cost baterai per kilowatt hour itu sudah turun dari dulu tahun itu sudah hampir hanya sedikit di atas $100. Nanti di tahun 2024 itu akan turun di bawah $100. Jadi kalau dia turun, pasti demand untuk baterai itu akan meningkat. Jadi kita akan melihat energi ke depan akan didominasi oleh baterai. Mungkin sekitar 15 tahun ke depan. Jadi akan berkembang 4 kali lebih banyak dari tahun 2020. Dari 432 gigawatt hour menjadi 1.800 gigawatt hour. Kita akan lihat tetap China adalah dominasi, susah digodek. Dan kalau kita ngomong tentang EV battery, kita harus juga mengerti tentang power generation. Jadi kalau kita lihat demand-nya dari PLN itu bilang demand-nya itu 327.000 unit. Battery charging infrastructure-nya itu akan mencapai 32.000 unit di 2031. Itu ekspektasi. Tapi kenyataan mungkin berbeda. Nah, dari electric vehicle itu banyak sekali kesempatan yang bisa diambil para startup, para perusahaan bisa consider marketplace-nya, baterai swap-nya, EV tracking-nya, terus charging station-nya, home charging-nya, community-nya, test drive-nya, akan banyak sekali ide-ide baru di sekitar battery dan sekitar EV di kemudian hari. Jadi kita nggak perlu takut bahwa industri itu akan kurang, tenaga kerja akan nggak ada. Bukan, tenaga kerja itu tetap akan dibutuhkan, mungkin akan lebih banyak, tapi industrinya itu berubah. Yang kita kenal industri sekarang itu seperti ini sistemnya. Tadi Pak Agus berbicara banyak tentang battery untuk EV. Saya lebih power generation itu apa? Coba kita lihat Indonesia saat ini masih didominasi oleh hydropower. Coba kalau kita lihat di sebelah kanan, PV, solar cell di Indonesia itu relatif utility scale IPP-nya itu relatif stabil dari 2020, 2021, 2022. Ya. Ada grid type-nya juga stabil, tapi rooftop PV itu bertambah signifikan, hampir double, ya, rooftop. Jadi kenapa rooftopnya pertambahnya hampir double? Karena kesulitan bagi PLN untuk menyiapkan infrastruktur, apalagi di daerah-daerah bagian timur, ya, di mana mereka lebih convenient dan lebih murah saat ini untuk membangun ICESTA. Jadi solar cell dengan battery capacity terus distribution, jadi nggak terhubungkan dengan national grid. Coba kita lihat di sini, solar cell capacity di Pulau Sebira itu adalah 400 kilowatt. ISS kapasitinya 900. Jadi small island. Jadi electricity itu dispersed dari remote area. Jadi kalau kita mau koneksi seluruh Indonesia itu bisa, tapi terlalu mahal. Untuk mencapai 100% electrification di target di tahun 2002, itu kita harus berinovasi. Jadi harus mempunyai standalone power plant. Ya, berarti harus ada storage-nya, yaitu battery. Kalau kita lihat energy storage need di Indonesia itu adalah sekitar 900 ya, terawatt hour di tahun 2050. Capex untuk battery itu akan berkurang mencapai 0,6 juta dolar per megawatt hour. Jadi sekarang ini 0,6 dan nanti 2040 2050 itu hanya sekitar 0,15 miliar, jadi 150.000 dolar kita sudah dapat buat bikin 1 megawatt hour. Jadi imagine ya, kalau nanti bikin hydropower itu 1 megawatt hour itu akan 1,5 juta dolar, tapi untuk solar ya, dan baterai itu hanya 1,5 sampai 200.000 dolar per megawatt hour. Jadi kita bisa imagine bagaimana meledaknya. Ini kita bisa lihat. Tadi kita bilang, oh Indonesia butuh banyak. Lihat, ini adopsinya kan. Target vehicle-nya untuk roda 2 itu 13 juta, untuk roda 4 2 juta unit di 2030. Jadi akan demand untuk battery, demand untuk EV, komponen juga penting, itu sangat besar, sangat besar sekali. Jadi apa sih sekarang, kenapa kalau kita tahu kedepannya sangat besar, kenapa sih sekarang adopsinya masih lama? Biasanya memang adopsi itu akan lama, suddenly increasing at accelerated rate, exponential rate. Karena waktu pertama-tama ya public awareness masih rendah, terus biaya pertama itu masih terlalu tinggi. Ketiga, infrastruktur charging dan fast charging itu masih sulit, masih sedikit, dan juga limited performance. Jadi daya jangkau di Amerika atau di Eropa atau di China baru sekitar 500 km per single charge. Jadi masih belum convenient. Jadi kalau begitu gimana sih caranya pemerintah untuk incentivate atau untuk mendukung industri ini berkembang? Tadi Pak Agus juga sudah jelaskan, di sini saya jelaskan ada insentif, ada disinsentif, ada standarisasi, dan ada compensation. Ya. Roadmap untuk charging station targetnya 2021 93, tapi aktualnya 93. 2021 187, 2022 targetnya 500, 2021 572 dan 3000. Tapi kita tahu sendiri bahwa kita masih jauh dari target, karena adopsi electric vehicle-nya masih limited di Indonesia. Jadi itu dari saya untuk apa yang dikerjakan oleh IDLF. Saat ini kita ada elektro, yaitu solar dan baterai untuk kebutuhan rumah.
Baik, Pak. Ya, Pak Kiwi, ini tepat waktu sekali ya, 15 menit. Tepuk tangan untuk Pak Kiwi atas presentasinya, yang akan dilanjutkan oleh presentasi berikutnya dari Pak Febri Panduwijaya selaku Kepala SPU Tier 1 dan 2 PT Inka. Pak Febri, waktu untuk Bapak 15 menit juga, silakan.
Terima kasih. Assalamualaikum warahmatullahi wabarakatuh. Selamat sore Bapak Ibu semua. Terima kasih atas undangannya ke sini, J. Kami dari PT Inka senang sekali bisa berpartisipasi dalam focus group discussion ini mendukung ICESTA 2022. Nah, di sini kami ingin menjelaskan mengenai aplikasi dan tantangan battery storage pada kereta diesel hybrid dan bus listrik. Kami memberikan sudut pandang sebagai industri pengguna baterai itu sendiri. Next. Yang pertama, next saja. Kami sampaikan mengenai aplikasi battery storage pada kereta diesel hybrid. Next. Seperti kita ketahui Bapak Ibu bahwa di dunia kereta berdasarkan sumber energinya kereta itu dibagi menjadi electrified line dan non-electrified line. Kalau kita lihat di electrified line ada KRL, LRT, kereta cepat. Adapun untuk non-electrified line ada kereta diesel, baik diesel hidrolik maupun diesel elektrik. Bapak Ibu mungkin tahu yang tengah itu adalah KRD Pramex dulunya, yang melayani jalur Jogja Solo, yang sekarang sudah dielektrifikasi. Nah, elektrifikasi ini mempunyai performa atau energi efisiensi yang paling tinggi dan sangat ramah lingkungan. Namun harganya sangat mahal sehingga tidak semua line itu dielektrifikasi. Yang non elektrifikasi mempunyai kendala dari sisi emisi, noise, fuel consumption dan lain sebagainya. Next. Ini adalah profil railway line di seluruh dunia. Kalau kita lihat di sini bahwa pertumbuhan elektrifikasi di dunia itu hanya 1% per tahun. Dan di Indonesia ada 92% jalur yang belum dielektrifikasi. Kenapa? Karena nilai dari atau biaya elektrifikasi itu sangat mahal. Bahkan lebih dari 2 juta US dollar per kilometer. Jadi kita bisa bayangkan per kilometer lebih dari 2 juta US dollar. Dan tidak semua jalur itu adalah high traffic density sehingga tidak perlu dielektrifikasi. Kalau kita lihat success story dari jalur Jogja Solo yang dulunya dilayani oleh kereta diesel menjadi kereta listrik, itu karena sudah menuju ke high traffic density sehingga pemerintah berani mengeluarkan investasi untuk elektrifikasi. Kalau tidak, pasti akan tidak bisa ke arah sana. Nah, di sini ada potensi 92% jalur di seluruh Indonesia yang belum dielektrifikasi. Ini adalah peluang yang sangat besar bagi kita sebagai industri atau bagi Bapak Ibu semua sebagai researcher untuk masuk ke teknologi-teknologi yang lebih ramah lingkungan di jalur non elektrifikasi. Next. Sebagaimana kami sampaikan tadi bahwa untuk jalur non elektrifikasi masih didominasi oleh kereta diesel dan kereta diesel mempunyai isu environment, kemudian ada juga isu electrification cost, sehingga kita perlu suatu solusi kereta yang lebih environmentally friendly dan biayanya lebih rendah. Jadi biaya lebih rendah ini bila dibandingkan dengan biaya elektrifikasi. Tentu kalau biayanya dibandingkan dengan kereta konvensional pasti akan lebih tinggi ketika kita menambahkan battery storage system di sana. Next. Nah, banyak sekali cara untuk energy saving pada sistem penggerak kereta. Kalau kita lihat bahwa kereta itu ketika regenerative braking, energinya itu bisa dikembalikan lagi ke jala-jala atau listrik aliran atas apabila itu kereta listrik. Namun apabila itu kereta diesel, sayang sekali hanya dibuang sebagai panas di brake resistor. Nah, ada beberapa cara yang bisa dikembangkan, baik itu mereduksi lossnya dengan membuat konverter dan motor yang lebih less loss time, kemudian kontrolnya diimprove dan sebagainya. Dan ada juga cara dengan menambahkan energy storage system di dalam kereta atau di dalam jaringan kereta tersebut. Next. Nah, energy storage sendiri itu apa saja? Kita tahu ada banyak ya, ada superkapasitor, ada flywheel, ada kemudian baterai, ada yang lithium ion, ada lead acid dan sebagainya. Kalau kita lihat untuk kereta-kereta jarak jauh, supaya bisa mendekati performa dari diesel engine yang spesifik atau energy density dan power density-nya tinggi, baterai dan fuel cell ini yang paling cocok karena energy density-nya lebih besar daripada yang lainnya. Jadi kita tidak akan membahas superkapasitor, flywheel dan sebagainya di paparan kali ini. Tentu mereka punya keunggulan, namun untuk kereta jarak jauh yang lebih cocok adalah baterai dan fuel cell. Next. Nah, dari sistem hybrid sendiri ada banyak cara bagaimana kita bisa menghibridkan suatu sistem kereta. Apakah itu nanti dipasang di keretanya ataukah dipasang di jaringan, misalkan di dekat substation, supaya ketika kereta listriknya regeneratif energinya bisa disalurkan ke baterai yang ada di substation. Ada juga yang ditambahkan di dalam kereta, tentu akan menambah berat kereta namun bisa menambah potensi penyerapan regeneratif brake energy. Nah, bila kita bandingkan untuk yang kereta diesel, ada yang series hybrid, ada yang parallel hybrid. Kalau series hybrid itu sama-sama dengan diesel engine, maksud saya bisa saling menggantikan peran antara diesel engine dan baterai untuk performa kereta. Namun di parallel hybrid, diesel engine dan baterai sama-sama berkontribusi untuk menggerakkan kereta. Jadi bila salah satunya hilang, maka akan terjadi penurunan performa. Next. Beberapa contoh kereta hybrid di dunia kami sajikan di slide ini. Yang pertama adalah shunting loco di Jepang, dan yang kedua adalah KRDE hybrid juga dari Jepang. Ini tidak membatasi bahwa di seluruh dunia banyak pengembangannya ya Pak. Jadi tidak hanya di Jepang. Nah, di shunting loco sebelah kiri diesel engine-nya dikurangi, jadi baterainya ditambah di situ, diesel engine-nya dikurangi. Ini bisa dilakukan karena pola operasi shunting loco yang tidak selalu menarik rangkaian dalam jumlah yang banyak. Kalau di sisi kereta hybrid yang sebelah kanan, baterainya ditambah dengan kapasitas yang sama. Karena apa? Ketika nanti berada di stasiun, keretanya bisa dijalankan hanya dengan baterai tanpa harus menurunkan performanya. Tentu yang di sebelah kanan ini biayanya lebih mahal daripada yang sebelah kiri. Nah, energy savingnya yang sebelah kiri bisa 36% direduksi, kemudian yang sebelah kanan energy savingnya bisa 10-20% dari hasil pengukuran langsung di lapangan oleh manufaktur tersebut. Ya, yang menarik di sini adalah C rate dari baterai. C rate dari baterai yang digunakan di kereta itu cukup tinggi Bapak Ibu. Yang lokomotif ini sampai 5C, yang kereta KRDE sampai 20C. Jadi ini baterai yang performansinya cukup tinggi. Next. Challenge-nya adalah ketika battery fail, bagaimana performa kereta itu bisa dipertahankan. Kalau yang kasus lokomotif tadi, performanya pasti akan turun ketika ada fail di baterai. Fail di baterai ini maksudnya misalkan BMS-nya error atau ada koneksi yang tidak sesuai atau mungkin baterainya ada kendala dan sebagainya. Yang lokomotif performansinya bisa diturunkan. Yang kanan, yang KRDE performansinya tetap sama karena ketika tidak ada baterai, diesel engine-nya ada di kereta sudah bisa menjalankan kereta dengan performansi sesuai desainnya. Namun sekali lagi biaya yang dibutuhkan tentu akan sangat besar. Bahkan Jepang pada tahun 2007 lalu mengembangkan kereta hybrid lebih kepada pride dari negara tersebut bahwa dia bisa membuat suatu kereta yang lebih ramah lingkungan dibandingkan kereta diesel konvensional. Next. Kemudian kami akan menyampaikan aplikasi battery storage pada bus listrik. Next saja. Ini potensial EV bisnis di Indonesia tadi sudah disampaikan oleh Pak Agus bahwa jumlahnya ini lebih besar ini dari yang kami tuliskan di sini. Ternyata sekarang potensinya sudah sampai 59 gigawatt hour, yang ini mungkin data yang lama dan ini merupakan challenge kita semua baik dari Inka maupun stakeholder Inka. Next. Ini adalah milestone pengembangan EV di Inka. Jadi dulunya Inka juga membuat mobil-mobil kecil, kemudian membuat bis berbasis CNG, kemudian tahun 2019 lalu kami masuk tapi bukan ke bis listrik. Kami mengembangkan tram baterai. Tram baterai adalah tram yang kami beri baterai, jadi tidak ada mesinnya. Pada Hakteknas tahun 2017 yang lalu, bakalan dari tram ini dipamerkan di Solo pada waktu itu. Jadi kemudian kami lanjutkan pengembangannya sampai menjadi prototip tram baterai. Barangnya masih ada di Inka. Kemudian tahun 2020 kami melihat potensi EV yang cukup besar. Akhirnya kami mengembangkan prototip bis listrik. Alhamdulillah waktu itu jadi satu, meskipun nilai TKDN-nya masih rendah. Dan tahun ini kami mendapatkan order sampai 53 bis listrik dan kurang lebih nanti 30 unit akan digunakan pada KTT G20 di Bali bulan depan. Next. Ini adalah overview dari bis listrik kami. Komponen-komponen utamanya ada baterai, motor controller, dan baterai charger. Inka masuk di battery king Bapak Ibu. Jadi nanti di slide berikutnya akan kami jelaskan bahwa baterainya itu berbasis LFP 600 volt 138 kWh 5 pack dalam satu bis. Kami juga membuat battery chargernya yang sudah kami pasang 1 unit di Bali. Nah, Inobus kami sudah mendapatkan sertifikasi pada akhir bulan Agustus yang lalu. Nah, baterai LFP ini menggunakan baterai sel dari ABC Bapak Ibu. Terima kasih Prof. Agus pada waktu itu yang mengenal ke ABC. Sebenarnya kami berjalan beriringan dengan ABC, jadi ketemunya itu sudah di tengah-tengah. Mungkin kalau ABC tahu bahwa potensi bis listriknya ini sangat besar, mereka tidak 26650 tapi mungkin ke prismatik atau yang lain. Jadi setelah mereka menyelesaikan lini produksinya, baru ketemu langsung order sampai 21 bis Bapak Ibu. Satu bis itu 12.240 sel. Jadi Bapak Ibu bisa kalikan berapa banyak sel yang kami order ke ABC untuk bis listrik ini. Next. Ini adalah produk structure dari bis dan lokal kontennya. Jadi kalau kita lihat di sini masih banyak Bapak Ibu yang komponen-komponen itu bisa kita lokalkan. Potensinya masih cukup besar. Jadi ada drivetrain dan baterai utamanya yang menyumbang nilai paling tinggi pada struktur harga dari bis listrik. Nah, untuk TKD-nya sendiri kami hitung apabila komponennya banyak yang dari luar bisa 46%, tapi kalau baterai, motor, controller itu kita kembangkan di Indonesia bisa sampai 76%. Tapi ini adalah self assessment dari kami yang sekarang masih dalam proses penghitungan dengan pihak surveyor Indonesia. Next. Kemudian ini ada structure produk dari baterai. Bapak Ibu pasti sudah sangat hafal ini. Jadi sebagai battery packer, Inka juga masuk ke battery packer Bapak Ibu. Ada banyak potensi yang bisa kita kembangkan battery cellnya dari ABC, namun sebagian komponen atau material masih kita impor. Next saja. Ini adalah manufacturing proses. Nah, pada saat ini karena konsorsium PTN-nya ketuai oleh ITS, jadi kami bekerja sama dengan startup yang dimiliki oleh ITS yaitu Udio. Sebagian proses kami lakukan di Inka, jadi waktu itu kami akhirnya menyewa salah satu mesin spot welding, kemudian kami letakkan di workshop kami dan kami bisa melakukan semua proses ini kecuali untuk sortir baterai karena sortir baterainya tidak kami miliki. Jadi foto-foto ini adalah foto-foto yang kami ambil di workshop kami di SBU Tier 1-2 di Inka, bisa menjadi battery packer saat ini. Next. Ini adalah perbandingan Bapak Ibu antara battery pack yang kami buat menggunakan baterai ABC dan battery pack yang kami impor dari Tron E Taiwan yang menggunakan baterai prismatik. Nah, di sini kita bisa lihat bahwa dari sisi kapasitas kurang lebih sama, namun dari sisi berat baterai pack dengan ABC ini lebih berat, 270 kg dibandingkan 200 kg per packnya nih. Kalau per bis dikalikan 5 nih, bedanya sampai 350 kg per bis. Ini kan cukup signifikan beda beratnya. Nah, dari sisi harga sayangnya juga lebih mahal. Jadi tidak terus kemudian ketika kita lokalkan harga baterainya bisa lebih murah. Jadi 150% ini adalah kasar, sebenarnya lebih dari 150% dari harga kalau kita impor baterai dari luar. Next. Kita ingin sampaikan Bapak Ibu tantangan ke depan itu apa saja. Next saja. Yang pertama dari sisi materialnya, bahwa kami sebagaimana tadi dibahas berbasis litium bukan berbasis nikel, karena kami lebih yakin dengan baterai LFP dibandingkan yang jenis lainnya dari sisi safety, karena ini adalah baterai untuk transportasi publik yang mana apabila terjadi kesalahan di sana akan menyebabkan banyak nyawa melayang atau banyak kendala-kendala yang lainnya. Jadi kami lebih yakin, dan apabila kita bandingkan kendaraan-kendaraan publik di negara Cina itu juga dan atau mungkin Jepang juga lebih berbasis pada LFP. Mungkin beda dengan negara-negara Eropa karena mereka sangat yakin bahwa Meskipun dengan NMC mereka bisa mengelola panas dari baterai tersebut. Tapi kalau kami kita di negara tropis, sehingga kita tidak terlalu yakin menggunakan baterai NMC untuk bis listrik maupun kereta listrik atau kereta diesel hybrid. Next. Kemudian dari sisi energy density Bapak Ibu, ini sebenarnya kami harapkan Bapak Ibu sebagai researcher bisa meningkatkan energy density dari baterai ini. Kalau kita tadi bandingkan ada 350 kilo perbedaan berat baterai di satu bis listrik. Kalau misalkan Bapak Ibu bisa melahirkan resep-resep baterai yang lebih bagus, yang lebih performanya jauh lebih tinggi, maka energy density ini bisa kita capai sehingga meskipun kita menggunakan baterai silindris, namun beratnya tidak jauh berbeda dengan ketika kita mengimpor baterai prismatik dari luar. Nah, kami juga berharap tidak hanya baterai silindris tapi juga baterai prismatik Bapak Ibu. Kalau dari sisi berat tadi lebih besar, dan dari sisi volume itu juga lebih banyak yang kita perlukan karena ada banyak ruang kosong ketika kita menggunakan baterai silindris. Nah, kami juga berpikir bahwa apakah Inka perlu sampai mengimpor baterai prismatik dari luar kemudian kita rakit sendiri. Tentu akan sayang PT ABC yang sudah sedemikian sedemikian besar ingin memajukan keinginannya untuk memajukan industri baterai nasional, terus kemudian tidak kami gunakan. Nah, handicap seperti ini yang kami harapkan dapat dipecahkan solusinya. Nanti Bapak Ibu bisa meriset, nanti bisa kerjasama dengan Inka dan lain sebagainya untuk bisa menghasilkan baterai yang lebih tinggi performansinya. Kemudian dari sisi rate, karena di kereta juga memerlukan penyerapan energi regeneratif yang cukup tinggi, tadi sampai 42% di slide yang sebelumnya, itu memerlukan baterai dengan minimal C-rate 3C. Kalau kami diskusi dengan ABC, C-rate 3C ini hanya bisa dilakukan, namun performanya sangat turun jauh daripada ketika C-rate-nya 1C. Jadi masih banyak PR di sini Bapak Ibu. Kalau bisa 3C akan sangat bermanfaat untuk kereta-kereta Inka. Jadi penggunaan brake resistor itu bisa kita minimalkan atau bahkan kita hilangkan. Kalau untuk bis listrik mungkin cukup 1C karena regeneratif brake-nya tidak terlalu besar, tidak terlalu signifikan. Next. Kemudian dari sisi cost, memang tadi sudah disampaikan oleh pembicara sebelumnya, memang ke depan akan semakin turun, namun pengalaman Inka saat ini baterai lokal itu masih 150% atau 1,5 kali lebih tinggi daripada kalau kita impor langsung baterai dari luar. Ini PR kita bersama jadi Bapak Ibu. Next. Nah, ini kolaborasi slide yang terakhir bahwa kami sebagai industri ingin bekerja sama dengan kampus-kampus dan juga tentunya harus perlu ada dukungan dari government untuk bisa melahirkan suatu ekosistem supply chain untuk EV di Indonesia. Kami di industri sangat mengharapkan ada battery cell manufacturing, battery pack assembly, battery management system, battery cooling system, dan lain sebagainya. Dan kami siap untuk mengkomersialisasi hasil R&D dengan kampus-kampus. Nah, di kondisi saat ini untuk cell manufacturing ada ABC, namun bisa di-improve lagi kami yakin. Kemudian battery pack assembly kami juga sudah masuk ke sana saat ini. BMS kami masih belum masuk, masih impor. Ini ada peluang. Tahun depan kami berharap bisa membuat BMS sendiri. Kalau Bapak Ibu dari UNS di penelitian propulsi hybrid dengan Inka membuat BMS sendiri, nanti kalau hasilnya bagus bisa kita gunakan. Dan kemudian dari universitas kami juga sangat berharap bahwa Bapak Ibu sebagai researcher bisa menemukan suatu resep untuk membuat performa dari baterai itu lebih tinggi dan harganya tentu lebih murah. Dan kami juga siap untuk join research dengan kampus-kampus yang ada di Indonesia termasuk UNS. Kurang lebih demikian paparan dari kami. Semoga bisa memberikan pencerahan bahwa kami sebagai industri keinginannya seperti ini Bapak Ibu. Jadi kalau misalkan nanti kami mentok harganya kok tetap tinggi dan sebagainya, sayang sekali kalau kami harus impor kan. Ini yang pesan yang ingin kami sampaikan. Terima kasih, mohon masukan Bapak Ibu semua. Assalamualaikum warahmatullahi wabarakatuh.
Ya, tepuk tangan untuk Pak Pandu dari Inka. Bapak dan Ibu yang saya hormati, ternyata banyak sekali ya peluang kerjasama industri dengan kampus. yang mudah-mudahan nanti bisa terwujud ya setelah meeting ini atau setelah diskusi ini. Saya membayangkan juga ternyata high cost juga ya pakai KRL itu ya, Pak ya. Tadinya sebelumnya saya membayangkan dulu ada Manja ya Pak Yudi ya. Manja itu Madiun Jaya, kereta Madiun Jaya yang sempat beroperasi. Katanya kalau orang Madiun ke Jogja itu piknik, tapi kalau turun Solo itu mau beli batik, gitu ya. Secara tradisional begitu ya. Baik, Bapak dan Ibu, teman-teman semua, juga yang menyaksikan di YouTube Expos Live, ya, ini juga ditayangkan secara live di YouTube Expos Live. Monggo kalau ada pertanyaan kepada 3 narasumber, ada Pak Febri Pandu Wijaya dari INKA, Pak Andianto Hidayat, VP RTI, ya, Riset dan Teknologi Innovation dari PT Pertamina, juga Pak Kiwi Ali Warga dari CEO UMG Idea Lab. Monggo, kalau ada pertanyaan kita buka.
Silakan Bapak Ibu, barangkali juga yang dari yang pertama ini langsung boleh.
Monggo, monggo.
Ini ada salah satu startupnya UNS nih dari Batek. Silakan Mbak Rina.
Baik, Assalamualaikum warahmatullahi wabarakatuh. Terima kasih atas waktunya Pak Warmin, Prof. Yudi. Jadi perkenalkan, nama saya Rina dari Batek. Batek salah satu startup UNS yang fokus memproduksi baterai sel dan baterai pack untuk beberapa aplikasi EV maupun ESS. Pada sore hari ini terima kasih Pak Andi, Pak Kiwi, Pak Febri sudah menyampaikan materi yang sangat menarik. Ada beberapa pertanyaan begitu, khususnya untuk Pak Andi. Yang pertama, menurut Pak Andi, the future energy di Pertamina khususnya untuk lithium ion battery ini akan bertahan sampai berapa puluh tahun ke depan, dan kapan Pertamina tadi kan disampaikan ada air battery ya, hidrogen, itu apakah bisa dijelaskan seperti apa dan potensinya seperti apa di masa depan? Kemudian apa sih challenge terberat bagi Pertamina khususnya di Research and Innovation Center ini untuk bergabung menuju transisi energi di dunia. Kemudian yang kedua, pertanyaan untuk Pak Kiwi sebagai venture capital dan venture builder ya, menurut Pak Kiwi gitu, apa sih insentif yang sangat diperlukan, karena Pak Kiwi sangat dekat dengan startup khususnya di energi baru terbarukan di Indonesia. Jadi insentif apa sih sebenarnya yang sangat diperlukan startup di energi baru terbarukan di Indonesia ini? Itu pertanyaan dari saya, terima kasih atas waktunya.
Iya, baik. Silahkan Pak Andi langsung dijawab pertanyaan dari Mbak Rina dari Batek.
Baik, terima kasih Mbak Rina ya atas pertanyaannya. Kita menjawab ya bahwa saat ini umur teknologi mesin itu tidak lagi sama dengan sebelumnya ya, ketika motor bakar ini panjang. Nah ini banyak inovasi-inovasi tapi masih menggunakan bahan bakar petroleum based. Nah untuk baterai itu kayaknya teknologinya akan makin pendek-pendek dan akan muncul teknologi-teknologi baru dengan energy density yang makin besar dan juga berat yang makin ringan, tentu makin diminati oleh pemakai. Ya memang kami belum pernah membayangkan ataupun melakukan proyeksi ya kira-kira umur lithium baterai itu seberapa. Tapi kalau kami sih melihat bahwa untuk minyak ataupun internal combustion engine itu minyak masih akan dibutuhkan di peaknya di tahun 2035. Baru setelah tahun itu nanti mulai sama dengan baterai dan mulai disalip oleh baterai. Nah untuk baterai sendiri, nah kita lihat saat ini kan memang kita usahakan lah supaya industri baterai itu masih bisa kita misalnya jadi pemain di situ dengan menggunakan nikel yang ada di Indonesia gitu ya. Memang karena kita nggak punya lithium, jadi kita mencoba masuk ke nikel. Nah tentu memang ini harapannya itu sampai tahun 2045 itu masih bisa dipakai ya yang nickel based gitu. Meskipun nanti di tahun 2030-an kita akan melihat bahwa akan masuk solid state baterai, tapi itu kan di masalah elektrolitnya saja ya. Untuk anoda, untuk elektrodanya kan masih sesuai dengan apa yang ada sekarang. Jadi harapan saya sih sampai tahun 2045 itu kemungkinan besar baterai-baterai berbasis lithium ataupun yang nikel ini akan masih banyak dibutuhkan untuk masyarakat. Karena memang untuk teknologi solid state itu juga masih menggunakan elektroda yang standar. Nah, untuk jenis-jenis baterai yang lain yang akan ditemukan ke depan kami kurang tahu. Di RJPP-nya Pertamina tadi mungkin maksudnya Mbak Rina itu ya RJPP ya, rencana jangka panjang perusahaan. Memang kami membagi low carbon fuel ke depan itu ada beberapa. Jadi ada yang menggunakan biofuel, ada yang menggunakan baterai, ada yang terus hidrogen gitu ya. Nah, jadi memang terbagi-bagi, tidak semuanya terus satu, semua baterai atau semua biofuel gitu atau semua hidrogen. Jadi ada semacam clustering gitu. Jadi ya kita di Pertamina akan mencoba masuk ke seluruh energi bersih yang akan dimanfaatkan ataupun yang diperlukan oleh masyarakat ke depan, apakah itu dari berupa green diesel atau renewable diesel atau juga mungkin biodiesel, terus green gasoline, renewable gasoline, terus juga ada green aftur, renewable aftur yang untuk bahan bakar pesawat, kemudian juga untuk baterai, terutama masih akan kalau tadi berbeda dengan Pak Febri ya, beliau lebih prefer ke LFP, tapi kami mencoba karena ini merupakan rangkaian dari bisnisnya EV, maka ya kami di Pertamina akan lebih fokus untuk nickel based baterai. Nah, baru habis itu kita juga akan masuk ke hydrogen. Nah, itu ada beberapa teknologi yang akan terus kita kembangkan, terutama juga dari sisi pembangkitan hidrogennya supaya bisa semakin murah. Apakah menggunakan renewable energy, apakah menggunakan new energy gitu, atau mungkin menggunakan energi lain, dan juga bagaimana melakukan transportasi hidrogennya sendiri menggunakan hydrogen storage apa, kemudian juga nanti pola logistiknya seperti apa, itu kemudian apa kita akan bermain untuk international market atau tidak. Jadi Pertamina mencoba melihat dari keseluruhan. Bahkan juga kita juga sekarang masuk ke bioetanol ya, karena bioetanol itu kan nanti akan menggantikan blending ya, di blending bisa dengan gasolin untuk meningkatkan octane number. Jadi kalau dilihat dari sisi portofolionya, kami masih lebih fokus ke yang liquid fuel, terutama yang low carbon fuel. Namun juga sudah mulai melihat ke baterai, rangkaian dari industri baterai Indonesia dan juga hydrogen. Saya kira itu jawaban saya, mudah-mudahan sesuai dengan harapan Mbak Rina.
Ya, baik. Terima kasih Pak Andianto. Dan berikutnya Pak Kiwi, tadi ada pertanyaan Mbak Rina tentang insentif apa gitu ya, yang bisa yang diharapkan dari pemerintah gitu. Silakan Pak Kiwi.
Ya, ini pertanyaannya bagus banget dan luas banget karena renewable energy ini sektornya banyak sekali ya. Sektornya banyak sekali di Rina. Jadi kalau kita mau ngomongnya dipersempit dan lebih praktikal ya saya sih mau minta government itu untuk membeli barang yang diproduksi oleh perusahaan lokal yang TKDN-nya tinggi. Nah itu harus konsisten. Tadi Pak Hinka Pak itu udah bilang bahwa harga kita itu di atas 150% baterainya aja gitu kan. Dan yang lainnya di atas 150%. Karena apa? Karena ekosistem Cina itu dibuat 10 tahun yang lalu, 15 tahun yang lalu. Sampai 15 tahun ke depan kita nggak bisa ngalahin soal harga sama Cina. Nggak akan bisa. Ya. Kita harus membangun ekosistemnya dan dia itu dihajar-hajar itu dari luar. Ya. Dari Cina dibanting-banting harga itu sampai kita nggak bisa buat sendiri. Nah itu harus punya komitmen yang keras dari pemerintah untuk memakai produk lokal yang ber-TKDN tinggi. Nah itu satu. Kedua, untuk dibeli itu kan harus punya sertifikasi, punya certain standar. Para pemain baru, ya, kalau Pertamina sih nggak perlu gitu ya, banyak uangnya gitu. Tapi para pemain baru yang mau masuk ke sana itu harus didukung selain oleh kerjasama dengan universitas, universitasnya juga harus lengkap labnya. Ya. Ketiga, dananya juga harus ada. Keempat, expertise-nya juga harus ada. Nah, itu adalah kelima, sertifikasinya jangan dibuat berbelit-belit. Ya. Kalau bisa ya dibantu, tapi tidak mengurangi standarnya. Gitu. Jadi kalau misalnya standarnya sudah terbentuk, ya, kualitasnya sudah terbentuk, tinggal dibeli, gitu kan. Kalau dibeli, perlahan yang masuk ke industri itu semakin banyak. Nggak usah nanti kalau sudah seperti Cina, ya kan insentifnya dikurangin. Cina juga dulu pertama diinsentif, ya. banyak diinsentifnya supaya industri lokalnya itu maju, entah dengan pajak, entah dengan cuti, entah dengan kebijakan nasional yang lebih nasionalistik untuk membeli produk lokal. Jadi itu yang lebih praktikal lah. Di segmen-segmennya itu akan banyak lagi tuh, Rina. Semoga menjawab pertanyaan kamu. Terima kasih.
Ya, baik. Terima kasih Pak Kiwi. Berikutnya pertanyaan masih kita buka ya, Prof. Yudi.
Ya,
baik.
Juga nanti boleh kalau yang mau tanya lewat chat, tapi ini di sini sudah ada yang angkat tangan. Ini salah satu komisaris BUMN, Pak Yoge Katon. Silakan.
Assalamualaikum warahmatullahi wabarakatuh. Bapak-bapak semuanya yang saya hormati, saya masih agak newbie kalau urusan baterai ini karena baru tahu sedikit. Saya ingin tanya satu hal yang utama adalah kalau kita bicara tentang green energy dan sebagainya, saya pikir development yang dilakukan oleh pemerintah maupun swasta maupun perguruan tinggi ini sudah luar biasa dalam mendevelop di sisi hilirnya. Kalau bicara kadang-kadang sekarang kompor saja orang sudah promosinya aja cepetan ganti kompor listrik dan sebagainya begitu. Mobil pun kita juga sudah develop, baterai juga sudah develop. Yang saya agak dalam tanda petik sebenarnya agak ragu karena saya tidak tahu sebenarnya bagaimana ketahanan dari sisi hulunya. Jangan sampai saya itu khawatir kadang-kadang semua orang dibawa ke sisi hilirnya semuanya dengan baterai, semuanya dengan listrik. Tapi hulu kita ini sepanjang yang saya tahu dominantly masih didominasi oleh PLTU batubara. Sementara batubara itu hari ini juga up and down. Saya ingat saya 2008 ketika masih bekerja di kawasan industri, kita pernah shortage listrik luar biasa besarnya. Hampir industri berjuangnya luar biasa. Beberapa waktu yang lalu bahkan kita itu juga masih kesulitan batubara karena pengusaha batubara lebih cenderung mengekspor batubaranya keluar. Sampai bahkan di industri semen sendiri kita kesulitan batubara karena domestic market obligation yang dibebankan itu kan volumenya kecil dan orang tetap bicara bisnis. Ini mumpung batubara selama ini kita struggling, hari ini mumpung naik kita ekspor lah gitu kira-kira. Jadi bahkan industri dalam negeri pun kita nggak kebagian. Nah, kalau sampai terjadi kita sudah kadung membangun hilirisasi semuanya energi ini semuanya oke semua. Nah ternyata masalahnya kalau sampai di hulunya pembangkitan ini bermasalah kan, jadi saya nggak tahu membayangkannya seperti apa gitu. Keseimbangan suplai demandnya listrik itu kira-kira seperti apa gitu kira-kira. Hari ini PLN barangkali getol juga untuk menjual apa namanya excess capacity-nya listrik itu luar biasa, atau mungkin bebannya PLN untuk membayar IPP juga barangkali juga menjadi beban bagi PLN. Tapi itu hari ini. Nanti kira-kira bagaimana kalau kemudian batu bara juga semakin terbatas karena ini kan non renewable gitu ya kira-kira. Itu kira-kira apa sudah dipikirkan? Apakah barangkali Indonesia juga sudah memikirkan tentang energi nuklir? Barangkali kalau di luar sudah batu bara semakin banyak dimatiin, di Eropa dimatiin batu baranya gitu kan, kecuali kalau karena sekarang perang dinyalain lagi gitu kira-kira. Tapi ini barangkali perlu dipikirkan. Yang kedua, ketika kita menggencarkan semua yang berbau listrik ini, beban itu kan sebenarnya ada di rumah tangga. Saya tadi bisik-bisik sama Prof. Agus, kira-kira sebenarnya beban rumah tangga itu berapa minimalnya kalau kita punya mobil listrik, terus kemudian berapa VA ini kira-kira di rumah kita harus punya. Jangan-jangan kita punya listrik di rumah setiap hari kita ngecas 10 jam gitu kan, butuh 10.000 VA gitu misalnya, ternyata beban kita juga jadi lebih mahal untuk bayar listriknya gitu kira-kira. Nah itu aja kira-kira, terima kasih.
Sayangnya staf ahli ESDM sudah exit dari WhatsApp gitu Pak. Tapi tenang, nanti kalau jawabannya susah dikasih ke sebelah kanannya, ini kan teman kuliah S1-nya suruh jawab Pak. Monggo Pak Warmi. Tapi kalau nanti dari ketiga pembicara ini, nanti Prof Agus harus jawab. Kan itu pertanyaan dari temennya. Gitu.
Iya. Apa langsung aja diaturin jawab ya, Prof Yudi?
Ya, langsung saja dari Prof Agus. Tapi yang tiga narasumber kita coba kita tawarkan terkait dengan pertanyaan tadi begitu. Mungkin juga dari Inka, karena Inka salah satu pengguna kendaraan listrik kan pasti sudah melakukan asesmen ya, kalau sampai termasuk visibility bisnis akan sudah diperkirakan begitu. Monggo Febri, Pak Warmin yang biar jawab ya. Ini teknik elektro ITB nih Pak, jadi juga muridnya almarhum Pak Peki, jadi kan harus kuat juga gitu kan urusannya gitu.
Iya Pak Kak, mungkin kami menjawab yang nomor 2 aja. Kalau yang nomor 1 di sisi pembangkitan mungkin cocoknya Pak Agus atau Pak Andianto Hidayat dari Pertamina. Di sisi nomor 2, baterai untuk bis listrik itu kan 138 kWh Bapak. 138 kWh. Kami menyediakan charger itu supaya bisa ngecas dalam waktu 2,5 jam. Per gunnya atau per nozzle-nya itu 60 kW. Jadi ya kurang lebih 60 kVA yang harus disediakan di rumah untuk bis listrik. Tapi kalau untuk mobil supaya bisa ngecasnya lama mungkin 2.200 atau sekitar 6.600-an itu masih bisa kita gunakan Bapak. Tapi itu kan nanti akan berpengaruh pada berapa lama chargingnya. Jadi kami membuat charger yang 2 kali 60 kW itu karena permintaan dari customer, bis itu harus bisa dicas full dari 0 ke 100% selama 2,5 jam maksimal. Jadi itu hitung-hitungannya seperti itu Pak. Jadi dari keinginan customer berapa banyak, berapa waktu yang diizinkan, kemudian kami turunkan menjadi berapa kilowatt charger yang kami buat. Jadi Inka saat ini sudah membuat dan sudah kami deliver 1 unit charger ke Bali Bapak. Memang komponennya masih banyak yang impor, namun perakitan dan desainnya sudah kami lakukan sendiri di Madiun. Demikian Bapak.
Ya baik, mungkin Pak Andi bisa menjawab pertanyaan dari Pak Yoce. Monggo Pak Andi, yang soal pembangkitan batu bara.
Pak Yoke ya, mohon maaf ini sebetulnya karena kan Pertamina ini di industri migasnya ya, kalau itu untuk pembangkitan memang lebih cenderung ke PLN ya. Namun memang kami kemarin 2 tahun lalu pernah melakukan kajian dengan sebuah lembaga studi di Jepang yang memproyeksikan ya kira-kira peningkatan kebutuhan pembangkitan listrik dengan adanya electric vehicle itu seperti apa. Memang mereka concern apabila terus pembangkitan itu tetap akan dijalankan menggunakan yang kotor atau yang berbasis batu bara. Jadi mereka lebih mengencourage apabila ke depan untuk energi listrik yang dipakai untuk kendaraan bermotor juga berbasis energi bersih. Misalnya apakah renewable energy, kemudian juga termasuk juga mungkin nuklir. Memang kalau berbicara nuklir ini kan sangat sensitif ya. Pertamina sendiri juga saat ini mulai menjalin kerjasama dengan BRIN untuk mengkaji pemanfaatan energi nuklir, tapi supaya tidak bergesekan dengan PLN karena di RUPTL-nya memang belum ada. Jadi kami mencoba memanfaatkan energinya nuklir ini, baik yang energi listriknya maupun nanti energi panasnya itu untuk membangkitkan hidrogen juga. Nah kita akan terus melihat itu sehingga apabila nanti sudah ada prototipe-nya, sudah ada demo plan-nya, tentu kesadaran ataupun juga atensi dan juga confident level dari pengambil kebijakan di energi itu akan melihat bahwa nuklir juga berpotensi. Yang jelas saya tidak mengharapkan bahwa ke depan ini akan terus dikembangkan pembangkit listrik yang berbasis fosil, terutama dari batu bara. Jadi jangan hanya memindahkan ya asapnya dari tadinya asap di kendaraan bermotor dari pembakaran bahan bakar, pindah ke pembangkit listrik yang berbahan bakar batu bara, tapi terus mobilnya bersih. Jadi soalnya cuma memindahkan emisi karbonnya saja, tapi supaya kita juga melihat bahwa emisi karbon itu memang berkurang dengan adanya energi listrik ini ataupun electric vehicle ini. Di Jepang juga mulai tren bagaimana soalnya supaya kita mulai mengurangi kepemilikan mobil ya. Jadi mobil itu nanti semuanya di jalan itu adalah milik bersama. Kita bisa manggil mereka untuk kita masuk dan kita tidak perlu mendiamkan mobil itu di garasi kita ya, karena jangan sampai mahal tapi terus diam saja. Jadi mereka lebih mencoba encourage untuk ride sharing atau juga ride hailing ya. Jadi kita memanggil kendaraan yang akan kita pakai. Kalau itu nanti sudah normal dan sudah berbudaya, tentu tidak susah kita untuk mencari kendaraan dan itu berbasis listrik. Kita panggil, kita pakai, habis itu kita turun, mereka jalan lagi cari penumpang lain gitu. Itu tentu suatu kondisi ideal di mana ownership dari kendaraan pun sudah jadi tidak penting gitu. Memang saat ini kendaraan juga menjadi prestise ya, tapi itu mungkin akan mulai berkurang dengan lifestyle yang berbeda karena kesadaran terhadap energi listrik ini memang makin berat. Jadi itu sih ide kami ya, karena memang kami bukan bergerak di bidang pembangkitan listrik, tapi lebih di energi yang menggerakkan mesin bakar. Jadi bayangan kami seperti itu, hasil studi kami juga seperti itu Pak Yugo. Mudah-mudahan menjawab. Barangkali itu yang bisa saya sampaikan. Terima kasih.
Ya, baik. Terima kasih Pak Andi. Baik Bapak dan Ibu, karena sudah hampir jam 4, monggo kita satu pertanyaan lagi untuk para narasumber. Silakan. Ya, kalau ngecasnya 2,5 jam, harusnya sudah sampai ke tujuan itu ya. Ya, monggo. Bapak dan Ibu yang di Zoom atau yang ada di ruangan. Iya.
Yang dari Zoom barangkali, khusus untuk yang dari Zoom ini, yang terakhir, mungkin hostnya bisa memonitor, ada nggak? Tidak ada ya, baik. Sudah tidak ada nih Pak Warmin, dan juga sudah jam 4 begitu.
Ya, baik Bapak dan Ibu yang saya hormati, para narasumber yang luar biasa pada sore hari ini. Terima kasih telah mengikuti webinar tentang kendala dan peluang bisnis pada ekosistem energi storage dan EV di Indonesia. Sebelum kita akhiri, kita beri aplaus untuk para narasumber, teman-teman semua. Ada Pak Andianto, Pak Kiwi, kemudian Pak Febri Pandu, dan juga tadi ada Pak Agus. Mudah-mudahan ini memberikan insight ya, pencerahan gitu ya bagi perkembangan teknologi baterai di Indonesia, baterai listrik ya, yang mudah-mudahan juga ini industri mengikuti. Jadi dan tadi ada banyak manfaat juga, banyak apa ya, semacam celah-celah industri dan kampus kita bisa bersinergi ya Pak Febri ya, untuk ya mewujudkan energi listrik yang lebih available untuk industri dan untuk masyarakat. Kita akhiri, Prof. Ayudi.
Siap.
Ya, mudah-mudahan bermanfaat. Kita beri aplaus untuk kita semua. Mohon maaf jika ada kekurangan, kita tutup. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Terima kasih.
Terima kasih Pak Adianto, Pak Kiwi. Untuk yang hadir ini dikasih pandel UNS Pak. Nah nanti kalau Pak Adianto minggu depan kan ada closing LPDP, kita siapkan pandelnya juga. Gitu. Kiwi pasti kan sebentar lagi ke Solo lagi. Ya, makasih.
Okay, ladies and gentlemen, that was the panel session from B1 room, and right now we're going to have the token of appreciation for the speaker. Okay, the first one. Yeah,
Cek 1 2 3. Satu dua tiga mat. Ngambek sama saya Pak.
Tes, nyala, ya. Oke, gak ada ya. Kalau gini bisa. Begitu ini bisa sekarang. Okay, so ladies and gentlemen, right now we have come to the end of the conference, but before we're gonna go with the announcement of best paper and also best presenter at ICESTA 2022. Deg-degan ya, so ladies and gentlemen, I'm going to announce right now. The first one, we're going to go to the best presenter. Okay, so anyone here present today? Ada yang tadi semuanya present di sini ya? Okay, start with J. Can you guess who is it? Best presenter start with J is? Oh, best paper. Okay, best paper goes to Chico Hermanu Brilianto Apriwibowo, Sarjia and Sasongko Pramonohadi and F. Anangwijaya. Best paper entitled Impact of Fresh and Retired Batteries for Optimal Battery Energy Storage Systems on Operation Costs for Increased Flexibility. Okay, boleh ke tengah mas? Alright. And now, also we're gonna announce the best presenter. Okay, nanti kita barengan ya kasih sertifikatnya ya. Best presenter goes to Jenita Halim. Okay, do we have Jenita Halim here? Online. Okay, we're gonna send the certificate. So we're gonna go with the best paper first, and yep, we're gonna deliver the certificate for best paper. Congratulations once again, Chico Hermanu Brilianto Apribowo, Sarjia, Sasongko Pramonohadi, and F. Danang Wijaya. Okay, we can take picture. Yay, best paper ya. Congratulations, ICESTA 2022 is so happy to have you as best paper. Okay, for Jenita Halim, we're going to deliver the certificate to you as best presenter. Thank you for joining ICESTA 2022. Well, ladies and gentlemen, that was the end of ICESTA 2022. Albert, it's really an honor to be your host. Okay, have a good day and see you at ICESTA 2023, everybody. Amin. Ya, saya dengar aminnya, Bu.
Okay, we're going to take a picture, everybody. Okay, don't go anywhere first. Oke, Bapak Ibu, kami silakan untuk berfoto bersama terlebih dahulu. Monggo, silakan, terutama, dari organizers, kami silakan boleh berfoto bersama. Kita akan mengabadikan momen di sore hari ini. Dan tentunya setelah foto bersama, nanti silakan menikmati coffee break yang sudah kami sediakan. Mari silakan. Oh baik, LCD-nya kita matikan terlebih dahulu. Iya, agak trauma ya Bu, mukanya kena sinar ya Bu. Baik, mari teman-teman panitia, organizers, organizing committee, please. Nanti mungkin ada yang di atas, ada yang di bawah, ya, ada yang di atas panggung. Mari teman-teman ya, dan untuk juru kamera kami silakan untuk boleh menata kira-kira baiknya seperti apa ya. Ada yang di atas mungkin, ada yang di bawah. Pak Kornel ini kita turunin yuk. Ini harusnya diturunin nih. Mari silakan untuk organizer, teman-teman organizer boleh berfoto bersama. Ini boleh geser, boleh geser. Siapa Mbak Nita? Yuk dipanggilin satu-satu Mbak Nita.